I może rozpoczniemy od przemówień gości, których zaprosiliśmy na naszą konferencję. Zapraszaliśmy pana prezydenta Krzysztofa Żuka, jest prezentacja przygotowana.
Witam Państwa bardzo serdecznie.
Oczywiście pan marszałek Stawiarski. Mamy troszeczkę pewne problemy techniczne, ale już panowie tutaj sobie z tym wszystkim uporają się.
Szanowni Państwo, panelowe spotkanie dyskusyjne Innowacje w praktyce odbywa się w Lublinie już po raz 7. Bardzo się cieszę i gratuluję organizatorom, że mimo obecnej sytuacji jednak mamy szansę spotkać się i serdecznie witam Państwa podczas dzisiejszego wydarzenia. W tym roku ze względu na zagrożenie epidemiczne konferencja odbywa się w formie online, co pozwala na udział gości z kraju i z zagranicy. Panelowe spotkania dyskusyjne, konferencja, wystawa i warsztaty z roku na rok stają się okazją do wymiany poglądów i doświadczeń między naukowcami a praktykami. Prowadzą również do ważnej merytorycznej dyskusji na temat sposobów komercjalizacji innowacji naukowych w wielu dziedzinach. Głównym celem tegorocznego spotkania jest upowszechnianie znaczenia osiągnięć naukowych, a także wymiana doświadczeń oraz integracja studentów, doktorantów i młodych naukowców. Podczas konferencji głos zabiorą doświadczeni badacze, młodzi naukowcy, dyrektorzy i kierownicy przedsiębiorstw przemysłowych, a także przedstawiciele Urzędu Marszałkowskiego oraz Urzędu Miasta Lublin. Miasto Lublin znajduje się obecnie w bardzo istotnym punkcie. Trwają zaawansowane prace nad stworzeniem nowej strategii rozwoju Lublina 2030. Strategia ta jest tworzona w sposób partycypacyjny. Chcemy wspólnie odpowiedzieć na pytanie, jaki ma być Lublin w 2030 roku. Dlatego tak ważne jest, aby swoją opinię na ten temat przekazało nam jak najwięcej osób reprezentujących różne środowiska. Głos środowiska naukowego oraz przedsiębiorców jest dla nas szczególnie istotny, gdyż dzięki współpracy środowiska nauki i biznesu udaje się wprowadzić innowacyjne rozwiązania w lubelskich przedsiębiorstwach i instytucjach. Dziękuję organizatorom dzisiejszego wydarzenia, Polskiej Akademii Nauk, oddział w Lublinie oraz Centrum Innowacji Naukowo-Edukacyjnych. Szczególne podziękowania kieruję na ręce profesora Politechniki Lubelskiej, pana Tomasza Klepki. Wierzę, że udział w wydarzeniu będzie dla Państwa źródłem inspiracji, szansą na nawiązanie kontaktów z przedsiębiorcami oraz stworzenie interdyscyplinarnych zespołów badawczych i określenie obszarów ich możliwej współpracy. Do zobaczenia.
Bardzo dziękujemy panu prezydentowi za tak ciepłe słowa. Ja nie ukrywam, że to tworzy zespół, ale o tym jeszcze powiem na koniec. Teraz bym bardzo prosił o prezentację pana marszałka Jarosława Stawiarskiego, który też przygotował dla nas fragment wystąpienia, ale chciałem jeszcze nadmienić, że panelowe spotkania dyskusyjne Polskiej Akademii Nauk oddział Lublin są w tym roku współfinansowane ze środków Europejskiego Funduszu Rozwoju Regionalnego.
Witam Państwa bardzo serdecznie. Podczas panelowych spotkań dyskusyjnych Polskiej Akademii Nauk oddział Lublin. Szanowni Państwo, w dobie pandemii, a niedługo postpandemii, innowacje i to, co się wiąże z innowacjami będą...
Szanowni Państwo.
Witam Państwa bardzo serdecznie. Podczas panelowych spotkań dyskusyjnych Polskiej Akademii Nauk oddział Lublin. Szanowni Państwo, w dobie pandemii, a niedługo postpandemii, innowacje i to, co się wiąże z innowacjami będą na pewno kluczowym dojściem do tego, co się nazywa tworzeniem na nowo nowoczesnej gospodarki. Województwo lubelskie należy do czołowych regionów w Polsce, gdzie innowacyjność jest na bardzo wysokim poziomie. Mamy tu największy, bardzo duży odsetek firm, które zajmują się innowacyjnością, co w tak zwanym obszarze rolno-przemysłowym województwa lubelskiego bardzo dobrze nas klasyfikuje w całej Polsce. Szanowni Państwo, życzę Wam bardzo owocnych dyskusji i wielu dobrych przemyśleń, które pozwolą regionowi lubelskiemu, a także całej Polsce w dobie panującej pandemii, tak jak powiedziałem na początku, postpandemii, mam nadzieję, że już niedługo, na wypracowanie nowych rozwiązań, a także rzucenie innowacyjności na szale tego, co się nazywa odbudową polskiej gospodarki. Dziękuję i do zobaczenia.
Dziękuję bardzo panu marszałkowi. Jak państwo widzicie, mamy wsparcie samorządowców. Teraz mamy też wystąpienie pana prezesa Polskiej Akademii Nauk Oddział Lublin, pana profesora doktora habilitowanego Cezarego Sławińskiego. Bardzo proszę o wystąpienie.
Szanowni Państwo, jeśli spojrzymy na statut oddziału Polskiej Akademii Nauk w Lublinie, to do zakresu działalności należy m.in. integracja życia naukowego i współpraca ze wszystkimi instytucjami naukowymi regionu oraz popieranie i popularyzacja prac naukowych i prac rozwojowych o istotnym znaczeniu dla gospodarki regionu i kraju. Inicjatywa organizacji konferencji naukowo-technicznej pod nazwą Innowacje w praktyce została podjęta 8 lat temu przez profesora Tomasza Trojanowskiego, ówczesnego prezesa oddziału PAN w Lublinie, oraz profesora Tomasza Klepkę, przewodniczącego Komisji Nauk Inżynieryjno-Technicznych oddziału Polskiej Akademii Nauk w Lublinie. 7. z kolei konferencja, pomimo że zorganizowana jest w trybie zdalnym, zawierać będzie wystąpienia zarówno doświadczonych badaczy, jak też młodych kolegów oraz potencjalnych odbiorców innowacji, czyli przedsiębiorców. Szczególnego efektu organizatorzy upatrują w postaci zacieśnienia współpracy pomiędzy uczelniami i instytutami naukowymi, a przedstawicielami z zakładów przemysłowych. W imieniu oddziału Polskiej Akademii Nauk w Lublinie, organizatora tego wydarzenia, chciałbym podziękować Państwu za udział w konferencji, a szczególne podziękowania chciałbym złożyć pani profesor Agnieszce Wiercińskiej z UMCS, przewodniczącej Komisji Rozwoju i Promocji Osiągnięć Młodych Naukowców, oraz panu profesorowi Tomaszowi Klepce z Politechniki Lubelskiej, przewodniczącemu Komisji Nauk Inżynieryjno-Technicznych oddziału Polskiej Akademii Nauk w Lublinie, którzy są głównymi organizatorami tego wydarzenia, za ogromny wkład pracy w przygotowanie tej konferencji. Wszystkim Państwu życzę dobrych wystąpień oraz owocnych obrad. Dziękuję bardzo.
Dziękujemy panu prezesowi za bardzo ciepłe słowa i wsparcie. Teraz chciałbym przedstawić parę słów pana rektora, profesora doktora habilitowanego Radosława Dobrowolskiego, rektora UMCS.
Dzień dobry Państwu. Chciałbym serdecznie, gorąco powitać wszystkich uczestników kolejnej edycji konferencji pod nazwą Innowacje w praktyce.
Witam wszystkim.
Dzień dobry Państwu. Chciałbym serdecznie, gorąco powitać wszystkich uczestników kolejnej edycji konferencji pod nazwą Innowacje w praktyce. Wydarzenia, które już na trwałe zapisało się w kalendarzu imprez naukowo-badawczych i edukacyjno-promocyjnych miasta Lublin, a jego ranga i znaczenie z każdym rokiem wykracza poza sferę regionalną, ogólnopolską, nabierając coraz bardziej zasięgu międzynarodowego. Rok 2020 przyniósł nam wyjątkową sytuację i nie myślę tu o sytuacji gospodarczej czy politycznej, ale tej, która w swoim wymiarze dotyka wszystkich ludzi na całej kuli ziemskiej, czyli o pandemii koronawirusa. W tej trudnej sytuacji, w której przychodzi nam funkcjonować, spróbujmy znaleźć odrobinę optymizmu. Mimo że spotykamy się wyłącznie w przekazie wirtualnym, chciałbym, ażeby poprzez ten fakt można było dotrzeć do większego grona ludzi, większego grona odbiorców, a zatem i żeby informacja o tej konferencji mogła mieć rzeczywiście zasięg międzynarodowy. Wszystkim uczestnikom, wszystkim organizatorom już teraz pragnę serdecznie pogratulować tej imprezy, która z roku na rok, jak powiedziałem, urasta do miana rzeczywiście imprezy ważnej i rozpoznawalnej. Tego sobie życzmy, ale przede wszystkim życzę Państwu poza owocnymi obradami, choć tylko w formule wirtualnej, dużo zdrowia, odporności i przeczekajmy te czasy wszyscy w dobrej kondycji.
Dziękuję bardzo panu rektorowi. Kolejne wystąpienie mamy przygotowane przez rektora Politechniki Lubelskiej, pana profesora doktora habilitowanego inżyniera Zbigniewa Patera.
Witam wszystkich uczestników konferencji Innowacje w praktyce. Jako rektor Politechniki Lubelskiej mam zaszczyt i honor kierować instytucją najbardziej innowacyjną w Polsce. Politechnika Lubelska co roku w rankingu perspektyw zajmuje czołowe miejsca pod względem innowacyjności. W ostatnim rankingu zajęliśmy zaszczytne pierwsze miejsce. Również biorąc pod uwagę ilość patentów, które uzyskujemy, jesteśmy jedną z najlepszych uczelni w Polsce. W ubiegłym roku uzyskaliśmy 116 patentów, co było drugą liczbą w naszym kraju po Zachodniopomorskim Uniwersytecie Technologicznym w Szczecinie. Równocześnie zgłosiliśmy najwięcej patentów w Polsce. Te fakty świadczą o tym, że nasi pracownicy są bardzo kreatywni i poszukują ciągle to nowych rozwiązań. Cieszę się, że w ramach konferencji będą mieli możliwość spotkania z przedstawicielami różnych środowisk naukowych z innych uczelni, a także z zakładów przemysłowych Lubelszczyzny. Mam nadzieję, że we współpracy naszych pracowników powstaną kolejne ciekawe rozwiązania. Niektóre z nich są już obecnie prezentowane na tej konferencji. Życzę wszystkim uczestnikom konferencji owocnych obrad i sukcesów w życiu zawodowym, ale przede wszystkim zdrowia, bo te życzenia są dzisiaj jak najbardziej na czasie. Dziękuję bardzo.
Bardzo dziękuję panu rektorowi. Mamy też wystąpienie pana prorektora Uniwersytetu Przyrodniczego, doktora habilitowanego Bartosza Sołowieja. Bardzo proszę.
Szanowni Państwo, bardzo dziękujemy za zaproszenie do uczestnictwa w 7. Ogólnopolskiej Konferencji Naukowej Innowacje w praktyce. Konferencji, która jest bardzo istotna, jeśli chodzi o różnego rodzaju innowacyjne rozwiązania technologiczne, które będą służyć przede wszystkim naszemu społeczeństwu. Uniwersytet Przyrodniczy w Lublinie jest uczelnią praktyczną. Uniwersytet ma 65 lat, ma 7 wydziałów, które skupiają naukowców przede wszystkim działających praktycznie, naukowców, którzy mają szerokie, w tym międzynarodowe doświadczenie, jak polepszyć nasze życie, jak wdrożyć pewne rozwiązania, które ułatwią nam życie. Jeśli chodzi o temat dzisiejszej konferencji, to jest on bardzo istotny. Z naszej strony będziecie Państwo mogli usłyszeć coś na temat innowacyjnych technologii w gospodarce wodno-ściekowej, wykład, który wygłosi pan profesor Krzysztof Jóźwiakowski. Nasze dokonania, jeśli chodzi o naszą uczelnię, są potwierdzone różnymi certyfikatami. Przede wszystkim certyfikaty takie jak uczelnia liderów, czy dobra uczelnia, dobra praca, uczelnia odpowiedzialna społecznie, jak również uzyskany tytuł lidera, lubelskiego lidera innowacji predestynują nas do uczestnictwa również w tym wydarzeniu. Bardzo cieszymy się, że możemy uczestniczyć w nim z tak szacownymi uczelniami lubelskimi, jak również z naszymi przyjaciółmi, władzami naszego miasta, regionu czy województwa. Natomiast bez Was, przedsiębiorcy, te innowacje nie miałyby dużego sensu, ponieważ to Wy je wdrażacie i to Wy jesteście istotni w tym procesie i dzisiaj bardzo serdecznie dziękuję za uczestnictwo również z Waszej strony. Wszystkim Państwu życzę przede wszystkim zdrowia w tych niestety niestabilnych, covidowych czasach i mam nadzieję do zobaczenia na żywo. Życzę Państwu również wymiany doświadczeń, kontaktów i tego, żebyśmy wdrażali te innowacje w praktyce. Dziękuję bardzo, do zobaczenia.
Dziękujemy bardzo panu rektorowi. Współpracujemy też z lubelskim biznesem. Od wielu lat mamy patronat Lubelskiego Klubu Biznesu. Mamy też wystąpienie pani prezes. Bardzo proszę.
Dzień dobry Państwu. Witam serdecznie wszystkich na konferencji Innowacje w praktyce. Tym razem organizowanej w formule online. Można powiedzieć, że sytuacja pandemii wpłynęła na nas tak, że formuła organizowania konferencji stała się bardziej innowacyjna, stała się bardziej hybrydowa i mam nadzieję, że nie przeszkodzi ona w nawiązaniu tych relacji pomiędzy nauką i biznesem, do jakich została zorganizowana. Gratuluję serdecznie profesorowi Tomaszowi Klepce tego pomysłu, tej konsekwencji, determinacji w realizacji tego przedsięwzięcia. Powiem może banalnie, ale świat nie zatrzymał się na COVID. W zaciszu laboratoriów naukowych, ale też w laboratoriach firmowych kontynuowane są pomysły biznesowe, realizowane innowacje, które następnie będą aplikowane i komercjalizowane. I to jest ta dobra wiadomość, że nawet w COVID-zie ta cecha nasza, ludzka, ta kreatywność dalej funkcjonuje, ma nadal taką potrzebę wyrażania siebie w formie innowacji. Natomiast potrzeba do tego dobrych warunków i będą to inne warunki, które tworzymy.
Okay, so welcome everybody. This is my pleasure to announce a workshop on energy harvesting. I'm sorry for some delay, which was related to some technical problems. So my name is Grzegorz Litak, and I'm from Lublin University of Technology. This is a workshop which we organize in frame of our project Dialogue, and this is embedded in some larger event, which is Innovations in Practice. So we hope that you could enjoy our scientific presentations, and I should tell that the presentation is divided into 3 panels. So the first would be before lunch, and then there would be another part, and most of the speakers would be young researchers. For this session, we have another chairman. This is my PhD student, Bartłomiej Ambroszkiewicz, who is also presenter of one of these presentation. And I would like also to draw your attention to some experienced researchers and professors, like Professor Pradeep Malaji, and also Professor Mohamed Belhak, and Professor Alper Ertik. They are also our participants, and they will give some presentations. So I would like now to ask Bartłomiej to lead the session. The first speaker would be Mohamed Rayes Ahmad Vali. Okay.
Oh, hello. I would like to welcome our participants at Conference Innovations in Practice 2020. And today we have 3 sessions, 3 main sessions of mainly young researchers and 3 main prelegents. And now I would like to start with our first presenter from India, Mohamed Rayes Ahmad Vali. And the title of his presentation is Interacting Oscillators in an Array for Energy Harvesting. Hello, you can share your screen.
Yeah, okay, thank you. Myself Riyaz, I am doing MS Scholar from Applied Mechanics in IIT Madras. Title of my talk is Interacting Oscillator from Energy Harvesting from Interacting Oscillators. This is just for representation, and I will move to next slide. Coming to outline of my talk will be divided into basic introduction and
I hear you well, Mohammed, and I think everybody else.
Okay. Thank you. Coming to outline of my talk, I will give basic introduction on energy harvesting, and then I will talk about my system model and the equation of motion which I have developed, and voltage equation, simulations and observations. Basically, energy harvesting is harvesting energy from ambient sources like thermal energy, wind energy, vibration energy. In this study, we are taking vibrational energy for energy harvesting. This vibrational energy is mainly used to power the remote sensors. But the problem with the earlier literature that is done on vibrational energy harvesting is linear harvesters are limiting the broadband energy harvesting capabilities, and also some saturation of power is happening. In this study, we are considering nonlinear harvesters, which are considered in an array. Along with nonlinearity, some mistuning is also given in a pattern-wise mistuned pattern-wise manner. Coming to my system, actually, I have designed the system for a general M by N array. We are looking into model how to design that. So presently, I have taken this system which is similar to my system from one of the reference. The basic modification for my system is the axial springs will be connected at an offset from the base. And in place of bobs, there will be magnets, and below the coil. So this acts as a electromagnetic energy harvesting. The equation of motion is developed for all the pendulums. It is similar to the equation of motion. And as it is array, it will be running from rows 1 to Z and columns 1 to N. Based on the limit which is coming outside the limit, those terms get cancelled, and those coming terms get cancelled. Voltage equation is magnetic flux. Hello?
Yes, Mohammed, I hear you, but we have some technical problems.
I am hearing some.
Yes, we are hearing also echo.
Electrical equation given is magnetic flux density into length of coil into distance between the coil and magnet and angular velocity. This equation we are taken from an experimental system. Coming to the mistuning pattern, this opportunity.
Okay, so thank you, Mohammed, for your presentation. And I have a question to other participants. You can answer. You can ask the question to every presentation. So you can ask it online, otherwise via chat.
you find such components or frequency. Here you can see the time series, just measured time series. Here you can see the some acceleration and also the amplitude versus frequency. So this is white noise property, and you see that you can have such acceleration, which is a Gaussian random type acceleration, and then you have this acceleration is applied to the frame, which is stabilizing the system, and you would have some inertial force acting on the moving magnet in this case. So the next you can describe by model, a nonlinear model, this behavior. You have moving magnet again, and you have the coils, and during the magnet motion, you could have have current, induced current in the coils. So this is the current here, and the resistor is attached to the circuit, electrical circuit. So the problem which Wei Wang is studying in this case is linearization of a stochastic model. So you have originally you have nonlinear equation because you have z to the power 3. However, you have later you would have some equivalent model which is linear. So this is the equivalent linear system, and you need to calculate some coefficients. So the coefficient, damping coefficient, and this is a linear the spring coefficient, and this can be done also by some method calculating the difference between the original and the equivalent model. So you calculate some variations, and then you estimate the coefficients. So let me go to the results, because here there is some mathematics, and if you look to the results of numerical analysis, you can see that, for example, you can compare theoretical results which are coming from this linearization with some averages which are calculated from the simulation. So the simulations are obtained, simulation results are obtained from the original model. So you have some you change the noise intensity and cubic coefficient, which is coming from the structure of the system, and here you can have some other results. For example, here there is some result for the current, which is very important for energy harvesting. So the next is also the electromechanical coupling coefficient, which is which is also playing some role. And you see that the relations are not linear here. So finally, there are some estimations for the displacement and current, so theoretical and simulation results, and you can see also that in this graph you can see the displacement, which is shown versus time. And you see that the error of the calculation between the models, this equivalent linearized model and the nonlinear model is quite small. For some other parameters, maybe for larger noise, it is not a very good approximation. You can see from the results. There is some discussion of potential shape of a potential. So you can see here. This is the potential versus displacement, and there is also. I mean that this is the current square versus noise intensity, and this is like we expected for the linear system. So this potential is also seems to be parabolic shape. Yeah. So the consequence maybe is that you have a linear relation, and here there is some conclusion. So this equivalent linearization technique was applied to study the response of electromagnetic harvester subjected to Gaussian noise. The performance of electromagnetic energy harvester is independent of shape of a potential function. The increase of noise intensity has a positive effect on the output of the system, while for the system parameters, the influence is opposite. The output of the system is actually the current and the power output, but the parameters, maybe one can conclude that these parameters are from the linearization method. Maybe it's not the best. So I would like to show you. Thanks for your attention. I'm sorry that my presentation was maybe not far from perfect. However, I've got this presentation from Weibank a few hours ago. Yeah. Thank you for your attention.
Oh, thank you, Professor, for the presentation. And actually, I think we overcome the technical problems. So now there is a time for the next presenter. There is Ravindra Kondaguli from Lakati College of Engineering and Technology. So Ravindra, you can share your screen now and you can start your presentation.
Okay, sir. Am I audible? Am I audible, sir? Hello?
I hear you.
Okay, sir. I'm sharing my screen.
Yes, we see it, but you can try with slideshow, but I'm not sure there will be broadcast.
I will make slideshow. Okay, now I think
I see your screen.
Okay, I am Ravindra Kondaguli, research scholar, BLD Engineering College, Bijapur. I'm working under Dr. P.V. Marji, BLD Engineering College, Bijapur, located in Karnataka, India. I'm giving a presentation on design of automotive exhaust thermoelectric generator. Thermoelectricity refers to the phenomena in which thermal energy is converted directly into electrical energy and vice versa without moving parts. There are no moving parts in a thermoelectric device. Thermoelectric device is a solid state device made up of semiconductors connected by metals sandwiched in between by ceramic substrate. If we see the energy transfer, 90% of the electrical energy in the world is produced by thermal energy. And during the conversion, there are a lot of wastage of energy. That is, thermal energy is a low grade energy. Therefore, we cannot convert entire thermal energy to electrical energy. About if we see a nuclear power plant, automobile vehicle, or a factory, about 60% of the thermal energy is lost in the form of waste heat. Therefore, there is a need of our to convert that thermal energy to electrical energy. That can be efficiently done by thermoelectric generator. If we take an internal combustion engine, only 25% of the available energy from of an internal combustion engine is converted to effective power, and about 40% of the thermal energy or heat energy is lost to the exhaust gases of the internal combustion engine. That can be trapped by thermoelectric generator. We can also use the thermoelectric module as a Peltier module, and we can cool and produce a thermoelectric refrigerator or a thermoelectric air conditioning unit. This is a thermoelectric cooler here, what is showing, and this is a thermoelectric refrigerator. As there are no moving parts, therefore it can work more efficiently. But the problem for a thermoelectric device is it is not more efficient. The efficiency of a thermoelectric device is very low, and this will reduce by using a thermoelectric device in a refrigerator or a Peltier device in a refrigerator. We can reduce fluorocarbons, and we can reduce the ozone depletion and other effects. And a thermoelectric module basically consists of semiconductors which are connected electrically in series and thermally in parallel. This is a thermoelectric module. This is a thermoelectric module, and thermoelectric module are mainly used in a place where there is of no efficiency. It means efficiency of a thermoelectric module is very low. Therefore, thermoelectric module is mainly used when there is efficiency is not a concern. That is, it is mainly used in the spacecrafts where the efficiency is not a concern. And the process of producing a thermoelectric module, which converts thermal energy to electrical energy, includes this synthesis of a thermoelectric module. It includes initially production of the material and ingot or sintering of it, and producing and metallization of it, and dicing into its legs, and legs are produced, and connecting those ingots or legs, that is series, electrically in series and thermally in parallel. And after that assembling, this is a process of thermoelectric module production. And the thermoelectric module, it involves a technology from nano to micro scale. That is, it involves physics at elementary physics level. What is the electron, what is the bandwidth, band gap that is made. Therefore, it is a multidisciplinary approach. A thermoelectric module involves the material science study, it involves microstructure, it involves continuum study, and it involves, for the application in the automobile vehicle, it involves mechanical and automobile knowledge. Means it is a multidisciplinary approach, a thermoelectric module. Okay, my present work is using a thermoelectric module to convert exhaust gases if we see the exhaust gases of an automotive vehicle, the temperature of the exhaust gas of the automotive vehicle is about 400 to 600 degrees Celsius or 300 to 600 degrees Celsius. Using those exhaust gases, electricity can be produced. That is to design and fabricate an automotive exhaust thermoelectric vehicle. And the other purpose, objective of the work is to measure the power produced by the thermoelectric generator and to compare the results of the power produced by the thermoelectric generator with the analytical and numerical results by calculating in answers. Here, our experimental setup is like this. We have used on the test bench, we have not directly yet used on the automotive vehicle. We have on one side, we made hot gases to flow using a heat gun. On the other side, we made cold water to flow. And in between that, we have kept a thermoelectric module. This is a schematic diagram. And this one is the experimental setup of the thermoelectric generator. Experimental setup. In this, we can say this one is a heat gun. Cold water is flowing on one side, and in between that, there is a thermoelectric module. In between that. And we have varied some parameter. We have measured the temperature, voltage. We have measured what is the amount of power that is produced by the thermoelectric module at what temperature. That we have measured and compared those results with simulation and using formulas. We have compared the result. First, I want to explain the results. I want to explain the simulation that is done in ANSYS. We have done the simulation in ANSYS FEA. We have done modeling of the same. This is a commercially available thermoelectric generator. If we break it, inside that it contains this. If we break it, it contains P and N type of semiconductors. Or pillars. We have modeled that in ANSYS design modeler. We have modeled that, and we have meshed it in ANSYS mesh, and we have applied boundary condition according to the experimental results, experimental values, whatever there. We have applied the boundary condition, and we have measured what is the power produced by the thermoelectric module using ANSYS. That is one thing we have done, and we have also done by using mathematical modeling. We have solved this equation, that is zero dimensional. What is the amount of heat that is entering the thermoelectric generator? This is Seebeck heat, resistance, ohmic heat, and conduction heat. What is the amount of heat that enters the thermoelectric generator? What is the amount of heat that is leaving the generator? And what is the power produced by the thermoelectric generator? That we have calculated using analytical modeling. And we have compared the results of analytical modeling, numerical simulation, and experimental. That we have done. This is the experimental setup which we have used. There we have on one side hot gases are made to flow, on another side cold water is there. In between that, thermoelectric module is sandwiched. Okay, and these are the properties of the commercially available thermoelectric module. We have assumed some assumption, because we have assumed that the properties of the material are independent of the temperature, because Seebeck coefficient, they depend on temperature. We have assumed as well as thermal resistivity, they depend on temperature. We have assumed initially that they are independent of temperature, and losses due to radiation and convection are neglected. All electrical and thermal contact resistance are neglected, and the thermal Thomson effect we have neglected. with those assumptions and with the geometric property, with these available geometric property, we have simulated and we have calculated power by ANSYS method, by analytical method, and we have done the experiment and we have got the results as like this. Here, in the results, we observed that we have got power produced by the thermoelectric module in terms of milliwatts. And we have also observed from this graph, we have observed that the power produced increases as the temperature difference by the from the hot junction and cold junction increases. The power produced has increased. And from this graph, we can observe, we have observed that the trend is same for all the three. The trend is same for experimental results, analytical, and ANSYS. Whatever the results power produced by the thermoelectric generator, we have compared the results in this graph. We have compared the results of the power produced and we have got the power produced in terms of milliwatt. And next step what we have done is, instead of using one thermoelectric module, we have used two thermoelectric module connected in series. And we have used three thermoelectric module connected in series. And what we got, these are the experimental results. These are the power versus temperature for one thermoelectric module, two thermoelectric module in series, three thermoelectric module in series. These are for the experimental results. From experimental results, we can got that with the increase in the number of the thermoelectric module, the power produced has increased. Means if we connect a large number of thermoelectric module in series, we can produce good amount of power from the exhaust gas of an automotive vehicle. Okay. And from conclusion, we got a conclusion that from the above analysis, we can conclude that thermoelectric modules can be used to produce electricity from exhaust gases of the automotive vehicle, because exhaust gases of the automotive vehicle are having higher temperature compared to the ambient temperature. That temperature difference can be utilized to produce electricity, but it is in milliwatts. Therefore, we can connect thermoelectric module in series to produce more amount of thermoelectric module. Still, we are working on it. We have used only 1, 2, and 3 thermoelectric module. If we use about 10, 20, or 30 in series, we can produce, we are confident that we can produce electricity in terms of watt, because when we have used 3 thermoelectric modules in series, we got about 80 at 250 degrees Celsius only. We have got a power of about 80 milliwatt. Means if we use 10, 20, or 30 in series, then we hope that we can get a good amount of electricity in terms of watts. And from the results, we can compare the results of experimental, numerical, and analytical are comparable. We can compare the results and they are comparable. The trend is same for experimental, numerical, and analytical method. And these are the reference which we have used. And thank you for the attention, and thank you for Lublin University of Technology for giving me an opportunity to talk. If any questions, please.
Yes, I encourage to ask some questions regarding the presentation. So you can do it via chat or otherwise on the online. Okay, Ravindra, so thank you for the presentation, but maybe one question from me. Do you plan to apply this setup in real, for example, in the engine, or
yes, sir. No, sir. Yes, sir. We have planned to actually set in the engine, and initially, but there were vibration and other things were there. Therefore, and even we are planning to whatever the thermoelectric module which we have used here, they are made up of bismuth telluride. Their maximum temperature sustainable capacity is about 300 degrees Celsius, 300. But if we install that on the actual engine, there the temperature may be higher. Therefore, initially we want to do it on a test bench. Further, we want to go for the actual automotive vehicle. Therefore, initially but they are available. The thermoelectric module which are made up of silicon, which are made up of other material, they are robust and they can sustain a temperature of more than 500 degrees Celsius. They are available. But what we have used the thermoelectric module which is made up of bismuth telluride, which can sustain about 300 degrees Celsius only. Therefore, we have used on test bench initially.
So that's fine, because of course in the engine you've got higher temperatures, so
yes,
you can adjust your setup to the real environment.
Yes, sir. Yes, sir.
Okay, so I don't see any other questions. So I think now we've got one of the first main presenter, Professor Pradip Malaji, and maybe I will share my voice to Professor Litak. He will some more words about his activity in energy harvesting. And Ravindra, I think he's also your
yes,
supervisor, right?
Yes, sir. My PhD supervisor. My supervisor.
Okay, so it's actually good connection now. So we are from PhD student. Now we will have a presentation of professor. And I will share my voice to Professor Litak.
It is my pleasure to tell some words about Pradip Malaji. So we have some collaboration which we started maybe 2 years ago, where once we met on conference in Lisbon. However, we continue some collaboration and with Pradip Malaji. So Pradip was a visitor, also using this dialogue project. He was a visitor to Lublin University of Technology, and we also organized a visit to him. So it was very nice to attend in a workshop in Karnataka, and unfortunately the time is not very good for visits, for the contact visits, but we can communicate on the distance, and we have some we have one paper which was published, and some other projects going on with Pradip Malaji. So this Pradip Malaji is very active on energy harvesting, and this activity has different directions, because he started from some pendulum system, but he also invented recently some new systems. So he is continuously doing some new studies in this topic, energy harvesting, but using different approaches. Yeah. So Pradip, you can probably start your presentation.
Ravindra should start sharing.
Yeah. Okay. Okay. Very well. You can start, Pradip. You can start your presentation. Yeah.
Thank you, Professor Litak. I think my screen is, you can see my screen?
Yes. I can see your screen, and I can hear your voice. Yeah. Okay. This is perfect. Yeah.
Thank you very much, Professor Litak, for introduction. Today, My theme for today's presentation is concept of energy harvesting. So already we have seen previous two presentations on energy harvesting. Two of them are connected to electromagnetic energy harvesting, and the previous one of my students, he presented on thermoelectric energy generation. So there are various types of energy harvesting systems as a part of workshop. So I've been asked to present some concept of energy harvesting. I'll be covering some basics of energy harvesting and what are different types of energy harvesting, their limitations and future of energy harvesting. Maybe this is useful for the students or researchers who are trying to work in energy harvesting, and most of us who are already working in energy harvesting, for them it may be some kind of refresher. So starting with where exactly I come from, already Professor Litak has told, so I belong to India. So this is a place where exactly in India, my institute is located. Its place is Bijapur. It's in between Bangalore and Mumbai. It's an historic place. You can find monuments belonging to 5th century here. Our institute, we have some few research facilities here, so mainly on tribology, image processing, alternate fuel, nanoscience, hydrology, phytochemistry. Especially on energy harvesting related, we are in the process of setting up a lab on noise, vibration, and energy harvesting. So we have already got funding of $81,000 so far, and we're expecting some more from some other fundings. So we'll be having a full-fledged vibration and energy harvesting lab in future. So coming on to the today's presentation, this will be flow of my presentation. We'll start with why exactly we need to go for energy harvesting, then what are the different mechanisms through which we can harvest energy, their limitations, then how we can overcome those limitations, other options available with energy harvesting. So is it possible to go for control and energy harvesting at a time? And we'll end with the summary. Coming out of the introduction, so we'll just go through why it is required and what are the different systems, how exactly, what is the definition of this present energy harvesting and how it differs from conventional energy harvesting. To start with, now we are in the era of internet. So how it has evolved, just pre-internet, we had means of communication was just telephone, mobile, or SMS. In previous decades, 2 to 3 decades back, the internet was introduced to the world. Then we had a soft communication, the internet of content, through which we are able to send email, information, and entertainment. Further, with the evolution, so we are able to use this internet for services. That is the era of internet services. We had e-commerce, e-productivity, e-market, that is training techniques. Then we had internet of people, so social media. We're having Facebook, Twitter, WhatsApp. So this has advanced. This made people come together nearby, and this is because of this only today we're able to meet virtually online and making this particular workshop success. So going ahead, at present, we are listing a lot of things on this particular word, Internet of Things, in short called as IoT. So this is nothing but connection between machines, and we are trying to identify, track, monitor, and share using this IoT. But this has advanced, internet has advanced, and we are making use of this internet for IoT. So along with this advancement, it has brought some problems that need to be addressed. Our present technological demand is, including India, most of us, maybe Singapore, they have set up smart cities, and other European countries, including India, we are trying to go for smart cities. We need to connect the structures, buildings, and maybe transportation together and have on-hand data every time. So for this, we'll be needing a lot of sensors, thousands of sensors to work. So they are miniature sensors. They are self-organized. but the question is, are they self-powered? This is a problem that we need to address if you want to actually adopt IoT system in real life system. One of the problems that we are facing is with advancement in electronics, size of sensors are decreasing, but we are not able to decrease the size of battery. Or other options which can replace batteries to power up the sensors which can make them self-powered. One of the options may be energy harvesting. So we are surrounded by a lot of sources surrounding us. It may be mechanical source, radio frequency, thermal, solar. So these sources on the site can be converted into useful electrical energy through some generation system or through some mechanism. Either this can be stored or can be directly utilized for the sensor. You will see what amount of energy we can harvest from this kind of system. So usually it is limited at present, it is limited up to milliwatts. So why exactly we need energy harvesting? So first one is health concern. So we cannot rely on lithium batteries now because of we are going for, we are trying to reduce carbon footprint. Maintenance, we need to be, we don't want to replace our batteries frequently. We want infinite life of our energy system. Accessibility, some places where we cannot go frequently and change our batteries. So then for that case, energy harvesting is one of the best options. So application-wise, we have a lot of application areas identified where we can go for energy harvesting. Maybe biomedical, wireless sensing, or structural health monitoring. If you compare energy harvesting system with battery, we can see that with time, so battery will drain and it has limited lifetime. If you go for energy harvesting, so though battery has initially very high energy capability, with time it reduces, but energy harvesting, it has from beginning, it has very low energy harvesting capability, but it has, we can say theoretically, it has infinite life. Then, so we are talking about energy harvesting. Energy harvesting, for most of us, for all of us, it's not a new terminology, or it's not a new technology. From decades back, we were harvesting energy for different purposes. So like we have wind turbines, we have solar panels, we have hydro power plants, thermal power plants. So they are meant to produce power in terms of mega scale, maybe in terms of megawatt per centimeter cube, if we talk in terms of density. So also we have some independent, like autonomous generators to supply for some particular buildings or home, so which can produce energy in terms of mesoscale, so in terms of watts per centimeter cube density. And we are talking about something microscale where we can produce energy ranging from ultra watt to microwatt per centimeter cube. So our interest, and then this particular topic, is all related to this microscale energy harvesting. So definition of our energy harvesting system, so today's talk will be in terms of microwatt or from ultrawatt. So this energy can be usable for small sensors. So this is how we can go for miniaturization of sensors and IoT. This energy harvesting system, this method can make IoT possible and feasible. So we have different sources as we discussed previously, and which source can harvest what amount of energy. If you take photovoltaic, it's based upon light intensity. The output energy ranges from microwatt to milliwatt. Vibration, here also it ranges from ultrawatt to microwatt. In some cases, it is also possible to harvest in terms of milliwatt in case of vibration energy harvesting. If you go to thermal, previously we have shown thermal energy harvesting, but the previous study, sometimes we, based on size, we're able to get in terms of milliwatt also, or we can go for watt, but that is for bigger application purpose, for using for IC engines. For microscale, it varies from microwatt to milliwatt. Also, we have radio frequency energy harvesting from radio frequency source. So it has range. It is ranging from again ultrawatt to microwatt range. So these are the different ranges. So from different types of energy sources, we can harvest the energy. Now coming on to mechanism, we have seen what are the different resources through which we can harvest energy. Then what are the different mechanisms that are available to convert available resource source to the useful electrical energy. I'll be mainly focusing on vibration energy harvesting here, but I'll just start with the previous one, my students were presented on thermoelectric energy harvesting. We'll just go through how exactly it works. It has been shown in previous slide, previous presentation. We'll be using thermoelectric generator. We have two different heat sinks, one heat sink and heat source. Due to this temperature difference, Peltier effect, what we know as because of Seebeck or Peltier effect. So at a junction, there will be a voltage induced. This voltage induced is a directly function of change in temperature. So that means it completely depends upon the environment. Thermoelectric energy harvesting completely depends on environment. More the temperature difference, more will be the power output. So it depends on environment. So that is the limitation of thermoelectric energy harvesting. If you come to the vibration energy harvesting, so we can convert available source of vibration into electrical energy using different mechanisms. So at present, general mechanisms that we are using are electromagnetic, piezoelectric, and electrostatic. So we heard about all these three things. So electromagnetic is the more general one. We'll see how exactly this works. Electromagnetic, we know that when a coil moves when a magnet moves in the coil, copper coil, there will be a voltage potential generated. We can model this as a basic vibration model with the mechanical part, and we have an electromechanical here in terms of voltage. The voltage produced from Faraday's law, we can get the voltage produced through this electromagnetic energy harvesting. Similarly, we can use piezoelectric method. So you know that piezoelectric, when you apply the mechanical strain, it converts into electrical voltage, and reverse vice versa is true. If you apply the electric input, we can see the mechanical strain on the piezo material. So using this concept, we can produce the energy. So this is simple beam attached with piezoelectric plates and end mass. When this is subjected to vibration, this mechanical vibration will be transferred to piezoelectric plates, which will induce strain inside the piezoelectric plates. So due to pulling and unpulling, so that strain will be converted into sufficient required electrical voltage. So that can be stored and used for the future purpose. Similarly, electrostatic energy harvesting, it depends on the variation in the capacitance, so due to which voltage is generated. But all of them have certain advantages and disadvantages. So based on the requirement, so we can choose one of these to harvest the energy. So there are advantages and disadvantages have been listed here. If you go for electromagnetic, it is not a smart material energy harvesting. We are not using any smart material, and also it doesn't require external voltage for the conversion of mechanical to electrical energy. But the problem here is usually electromagnetic energy harvester need bulky size, like they need more space, they'll be bulky in size. And they are difficult for MEMS scale application. If you come to the electrostatic, here also it doesn't require any smart material. It is compatible for MEMS, but problem is it requires some external electric source. And also it needs mechanical constraint. For piezoelectric, so it is a smart, like it requires a smart material, like piezoelectric, as name itself indicates. So voltage generated using piezoelectric is higher compared to all other mechanisms. You can use this for MEMS as size is compact, but disadvantages with depolarization and PJT is very brittle. So yeah, there is one more option. to go for magnetostrictive energy harvesting. So these are different options available based on application and requirement. We can select one of these. Conventional energy harvester, what we say linear energy harvesting system. So both electromagnetic and piezoelectric have been shown. Spring mass system. Here, this is a fixed magnet and moving coil. So instead of magnet and coil, we can use piezoelectric element for piezoelectric energy harvesting. So conventional energy harvester or the linear energy harvester, so they can produce maximum energy only at the resonance. If you can see that, just away from this resonance, there is a lot of drop in the energy harvesting. So power is dropped drastically away from the resonance. So this is one of the limitations. These limitations are to be addressed, and people are working on these things. So there are challenges to be addressed here. So while dealing with conventional energy harvesters, so there are challenges like single frequency power generation with linear harvester. There is a problem with power is low, and also we have problem with low frequency devices. Problem with low frequency devices. Absence of low frequency devices. We need to design our system which can work in low frequency, because most of the structures like buildings and bridges, their frequency is very low, maybe below 10 Hz. We need to design harvester for this application. So this explains absence of general application for energy harvesting. So they need to be addressed. Now coming on to the possible solution to overcome these limitations, so what we term them as band enhancement. So there are different options available to increase the frequency bandwidth of energy harvesting system. Few of them are, maybe you can go for multi-mode or array of linear harvesters, or we can go for non-linear harvester, or possibly we can go to the electronic side and we can go for advanced electronic networking, so by which we can enhance the energy bandwidth of energy harvesting. But today we'll be limiting just to mechanical part, so to multi-mode and array of linear harvesters and non-linear harvesters. How multi-mode or multiple harvesters work? For example, here instead of going for just one system or first single beam and magnet system, what we can do is we can go for multiple beams with each beam having different frequency. That means I'll be able to harvest energy at different frequencies, thereby covering a band of frequency. We can increase the bandwidth of that particular harvester. Similarly, we can go for multi-mode harvesters here. So instead of harvesting only at the we can harvest energy at multiple frequencies. And there is one more option. We can go for hybrid harvesters, where we can combine both piezoelectric as well as electromagnetic mechanism to take advantage of both the systems. One more option, the limitation with multiple harvesters is that it requires a lot of space. So we are going for miniaturization. Multiple harvesters may not be a solution because it requires space. To overcome that, one more option available is to go for the non-linear harvester. So we can go for non-linear stiffness here. We have seen the previous equation, Kx was a linear stiffness term there. Instead of linear, we are going for cubic non-linearity here with half x into 1 minus x squared cubic non-linearity. So due to this non-linearity, we'll be having multiple wells generated here, multiple potential wells. So this intra-well oscillation of harvester might give us broadband energy. There are various systems proposed which are using magnets to induce potential wells. So except like there are few exceptional cases where they used instability caused due to buckling. So Criswell and others, they used instability due to buckling, and bistable system was induced, and which can harvest energy for the wider frequency band. So So either we can have softening or we can have hardening effect with nonlinearity present, which will increase the bandwidth compared to that of linear system. It is a simple mole beam, or nowadays known by duffing oscillator. So we can have this by using magnets at the bottom. So we can use either two single magnets, two magnets or three magnets based on the potential wells, how many potential wells we need. It may be monostable, bistable, tristable. I think up to quite stable harvesters are available now. With this, what we compare with a linear harvester, we can see that for longer frequency range, we can harvest power compared to this linear harvester. So only at resonance, linear is comparably better than nonlinear system, but at other frequencies, it is producing very low power output. So it is better to go for nonlinear system. There is one more option, so we can go for multiple nonlinear harvesters. We can combine multiple nonlinear harvesters to enhance the bandwidth as well as power output further. So with this, what we can achieve is, we can achieve maximum power as good as linear harvester, also bandwidth equivalent to the nonlinear harvester. It is optimal between nonlinear harvester and multiple harvester. We are not using many harvesters here, which will be saving our space. And with nonlinearity into picture, we are increasing the bandwidth. With introduction of number of harvesters, we are also increasing the power output. Then we want to go for multifunctional harvester. We don't want just to use that particular system to harvest energy. So can that be clubbed with other applications? One of them is control and energy harvesting. We can control the primary system while harvesting energy from the secondary system. So this is one of the basic example of dynamic vibration absorber. So the primary aim here is to mitigate the vibration of primary system. Along with that, if we can harvest energy from the secondary system, it will be better to harvest energy, and that can be used for the sensors which are used to monitor the structure. Here, secondary system is coupled with the electromechanical system. So it is possible to reduce the vibration of primary system as well as harvest the energy from the secondary system. It is a conventional linear dynamic vibration absorber. Now people are looking for non-linear energy sink. So this is a standard non-linear energy sink that we can think of, a simple pendulum with a primary system. And now people have started working on metastructure, wherein we can have multiple unit cells, where we can have multiple, not only increasing bandwidth of energy harvesting, also we need to increase band gap of the primary system to take care of uncertainties. So with the use of metastructures, we can increase the band gap of primary system suppression and also vibration energy harvesting frequency band. Coming on to the market and products available. So at present, we have many products available. If not for commercial, we have some wrist patches where through which we can monitor pulses in medical applications. We have some shoes with energy harvesters. So by walking or while running or walking, we can harvest energy, and that can be used to charge our mobile phone. So this is one of the application in biomedical. They use some certain animal. They pasted piezoelectric energy harvester to the heart of particular animal, and they are successful in supplying power to the pacemaker. Also Philips, so they have come out with a remote, TV remote, which can work on energy harvesting. So this is present, like till 2017. So there is a market value of 1.5 billion for energy harvesting. So in future, we are expecting that it will cost around $5 billion by 2022. So this is a present market scenario for energy harvesting. In summary, So we need to look out for some energy storage system and power management system and other available options for energy harvesting techniques. There are various problems to be addressed till now, and we can minimize the size so that we can use them for the MEMS application. Also, we need to work on low-cost energy harvesters. We need to go for power optimization, power management. Still, we have scope for the future research, so where we can increase our power output and bandwidth, and we can integrate energy harvesting with other applications like structural health monitoring, control and energy harvesting. We need to address these problems, and these are wide open problems that researchers should look for. And also, like compared to thermal, so vibration has more scope. So thermal mainly depends on environmental condition, and for miniature applications, vibration energy harvesting is preferable. From NEM to MEMS, vibration can be adopted. So these are some of the references we can make use of. Some of the collaborators, Professor Farooq Ali, Professor Mike, Professor Vikram, Abdul, Sandipon, and thanks to Professor Litak, Tanmoy, Venkatami, and these are my students working on energy harvesting. So thank you for your patient listening. If you have any questions, so let me know, or you can mail me later also.
Okay, thank you, Professor Malaji, for the nice presentation. And maybe I see that there is some. No, it's not a question. I have some question. Okay. Because in the first part of the presentation, you mentioned about the IoT solutions, and what kind of solutions can you see opportunities actually? Do you see for energy harvesting solutions in the industry 4.0?
Yeah, IoT, like now people are going for. So there is one more term coming into picture now, that is IIoT, Industrial Internet of Things. Most of the industries, they are going for automation, and they are trying to connect their machine. And machines, we need to connect a lot of sensors to the machines. The sensor needs power input. We can utilize machine vibration and supply that power to the sensor, and that sensor in turn can send to the wireless transmission. Through wireless transmission, so where we are sitting, we can monitor our machine and industry. So this is I think presently there are some industry involved. So they are trying to develop IoT system which can work on energy harvesting. But so far it has not been successful, but people are working on it because the amount of power required for IoT sensor is still not sufficiently produced by energy harvesting system. But maybe soon we can see, but to make this IoT successful, we need some kind of autonomous power supply system. So maybe possible in near future. I think that is a question that my answer is correct.
Okay, I see another question from Professor Sheikh Farooq Ali. There is in the chat.
Yeah.
Thank you for your answer.
Currently, it seems very little industry-academia interaction on EH. Exactly. I do agree with Dr. Farooq Ali. So we have very limited interaction with industries now, but we are totally working on theoretical, and even we have limitation that most of us, we are working separately on mechanical part, and people from electronic background or electrical background, they are working on electrical part. So we mechanical people don't know how to exactly come out with a complete product. That first we need to integrate with some other inter-department researchers, and also we need to communicate with industries. But I can see quite industries coming up in Singapore. I forgot that name. Recently, I had attended their presentation. So Smart Singapore, they are planning, and they started implementing this energy harvesting devices for their application. Maybe in Europe also there are some labs, like maybe in Italy, NIP lab. They're working on this, and they are going for actual products. So, but still, what I expect is maybe in next 5 years, there is a lot of possibilities to go for actual products, and we can collaborate with industries. At present, I also feel that there are very less industries who are interested in energy harvesting, like maybe some startups. So they are coming up and they are interested in energy harvesting. Recently, I had a discussion with some of the startups. They want solution for IoT system to power up the sensor, but still they are not sure what exactly they need. So maybe from our academic side, we need to make them sure that this is one of the possible solutions. So this is where we can find ourselves in future. If we can make them to believe in energy harvesting, if it is workable, so then we can go for industry interaction and collaboration with industry.
Okay, Professor. So thank you for your nice presentation. It was a great overview of the energy harvesting, and it can be a basis for everybody who starts with energy harvesting. And now we'll have a short break, and I would like to advise you to also visit the website of ehDIALOG, of our website of the project. I will send I'm sending the link to this website on the chat. So there are more. Actually, we are also upload the videos from our weekly meetings with the experts around the world on the energy harvesting. Okay, so I think we overcame also technical problems, and we'll be back in 25 minutes. So now in this break, there will be some promotion video on Lublin city and Lubelskie Województwo. Okay, so we start again at 12:15.
designed to work perfectly. IKA German Technology.
Witaj, miło Cię widzieć. Chociaż znamy się nie od dziś, myślę, że jeszcze wiele o mnie nie wiesz. Znajduję się w centrum Europy, więc szybko do mnie dotrzesz. To dzięki ostatnim zmianom w infrastrukturze drogowej, kolejowej i rozwojowi lotniczej siatki połączeń. Za granicą jest o mnie coraz głośniej. Ostatnio mówią o mnie, że jestem smart. Wdrożone rozwiązania potwierdza certyfikat ISO i liczne międzynarodowe rankingi. Jestem pewien, że znajdziemy wspólną przestrzeń. Taką, w której będziesz mógł się rozwijać. Będąc kompaktowym miastem, gwarantuje Ci atuty metropolii, jednocześnie zapewniając komfortowe warunki odpoczynku z dala od zgiełku zatłoczonego miasta. Wiem też, że wspólnie możemy się wiele nauczyć. Dzięki mnie dowiesz się, gdzie inwestować w wiedzę. Pokażę Ci, jak kwitnie współpraca biznesu, nauki i samorządu. U mnie znajdziesz miejsca, w których innowacje nabierają realnych kształtów. Przedstawię Cię osobom, które mają na to swoje patenty. Zobaczysz, jak nowe technologie sprawdzają się w praktyce. Przekonasz się, że jestem dobrą inwestycją, nie tylko jutro, ale tu i teraz. Nie czekaj. Przyszłość zaczyna się tu, w Lublinie.
Wybierz kierunek lubelskie. 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 Wybierz kierunek lubelskie.
Witaj, miło Cię widzieć. Chociaż znamy się nie od dziś, myślę, że jeszcze wiele o mnie nie wiesz. Znajduję się w centrum Europy, więc szybko do mnie dotrzesz. To dzięki ostatnim zmianom w infrastrukturze drogowej, kolejowej i rozwojowi lotniczej siatki połączeń. Za granicą jest o mnie coraz głośniej. Ostatnio mówią o mnie, że jestem smart. Wdrożone rozwiązania potwierdza certyfikat ISO i liczne międzynarodowe rankingi. Jestem pewien, że znajdziemy wspólną przestrzeń. Taką, w której będziesz mógł się rozwijać. Będąc kompaktowym miastem, gwarantuje Ci atuty metropolii, jednocześnie zapewniając komfortowe warunki odpoczynku z dala od zgiełku zatłoczonego miasta. Wiem też, że wspólnie możemy się wiele nauczyć. Dzięki mnie dowiesz się, gdzie inwestować w wiedzę. Pokażę Ci, jak kwitnie współpraca biznesu, nauki i samorządu. U mnie znajdziesz miejsca, w których innowacje nabierają realnych kształtów. Przedstawię Cię osobom, które mają na to swoje patenty. Zobaczysz, jak nowe technologie sprawdzają się w praktyce. Przekonasz się, że jestem dobrą inwestycją, nie tylko jutro, ale tu i teraz. Nie czekaj. Przyszłość zaczyna się tu, w Lublinie.
Wybierz kierunek lubelskie. Wybierz kierunek lubelskie. Wybierz kierunek lubelskie.
Welcome back to our today conference, Innovations in Practice 2020. And now we are moving back, we are moving to the second session, and we are starting with the first presenter, our distinguished guest, Mohamed Belhak, professor from L'Université Hassan II de Casablanca in Morocco. And I think Professor Litak will say some few words about Professor. Okay.
This is my pleasure to announce Professor Mohamed Belhak, who is our distinguished presenter. And I would like to tell that Professor Belhak is a leading researcher in nonlinear dynamics. So he contributed to many different systems. He's working in Morocco, and in fact, he is also organizer of a well-known conference, which is probably every 2 years organized in Morocco. So last time we met with Professor Belhak in Tanger. So there would be a continuation of this conference as well, probably in the next year. Yeah. But anyway, I would like to announce that he's our present speaker. So please, Professor, start your presentation.
Yes, thank you for your invitation. So I am trying to. Do you see my presentation on the screen?
Yes, we see. So you can only make full screen presentation, yeah. Because so if you can do this, you can try, yeah.
Try it in animations.
So I cannot. Yes, I cannot see the screen in my computer.
Otherwise, F5.
So
you cannot see, yeah, you cannot see the presentation on your computer, yeah.
Yes, I cannot see the presentation in my computer.
Because maybe you have to manipulate with a monitor, yeah.
Okay. So you can see the. So
I see.
If you put F5, yeah.
It's fine.
F5.
So my presentation, as you see, is the control of the rhythmicity in a self-sustained oscillator by modulated time delay. So the outline of my presentation is first I will start with background and motivation, and then I will present the rhythmic oscillator. So I will discuss the effect of a modulated time delay on the limit cycles in this rhythmic oscillators, and I will conclude. Metastability appears, as you know, in diverse forms in physics, in biomechanics, in brain dynamics, in chemical oscillators, in biology, chemistry, and so on. And a very frequent variant in bistability is bistability. And there are three main manifestations of bistability. The first one is when you have two stable steady states, and the other one when you have one stable limit cycle and one stable steady state, and the third one is when you have two stable limit cycles. And this third form of bistability is called birhythmicity. And oscillators showing this behavior are called birhythmic oscillator. So In many physical systems, the rhythmicity is undesirable. And depending on the initial condition, the system may oscillate in a small amplitude, and this will give less energy, or in with large amplitude, and this will provide large energy. And this makes the importance of controlling the rhythmicity. The objective of my presentation is to study the effect of modulated time delay on the rhythmicity. And the ultimate goal is to investigate energy harvesting in the biorhythmic oscillator. I will present the first part on only amplitude study of amplitude of the limit cycles, and this part of energy harvesting is an ongoing work. So let's discuss a little bit about the biorhythmic oscillator. This is the Van der Pol oscillator with multi-cycles, and you can see we have two terms which are added to the classical Van der Pol oscillator. And in this case, we have coexistence of two stable limit cycles with different amplitude and frequencies, and an unstable one. And as you can see here in the plane, you have two limit cycles, the green and the red, which are stable, while the blue one is unstable. So now let's study the effect of the modulation of time delay on this biorhythmicity. The classical case of Van der Pol oscillator has been already studied recently, and as you can see, this is the classical Van der Pol oscillator, and when we add the modulation of time delay, this was studied in some papers recently, and we got nice result on amplitude and energy harvesting. If we can present this result briefly, we can from this system we can get periodic solution from the slow flow, and quasi-periodic solution from the slow flow here. So just some multiple scale application, and we get all this stuff, and then we can obtain this interesting stability chart of solutions. And we can determine the region where quasi-periodic are stable, limit cycle are stable, trivial solution, and so on. And here we can see the time histories of this system in each region. And then, when you go to the amplitude, you can see that in some parameter of time delay, the amplitude of the quasi-periodic solution are higher than amplitude of periodic solution. And this is one of the motivation to use this high or large quasi-periodic amplitude to harvest energy. And the advantage that in this region, the quasi-periodic solution is stable, and the range over which we can scavenge energy is large, and at the same time we can avoid hysteresis and instability near the resonance. And this is what we done in this application. So we have studied energy harvesting in the classical Van der Pol oscillator with time delay in the mechanical component. In this case, and having the covariant equations of the harvester with the time delay here modulated around the mean value in periodic modulation, we can obtain the stability chart, in this case, of the system, and at the same time we can obtain here also in the variation and the power amplitude versus time delay parameter, we can obtain, as we have seen, the amplitude of quasi-periodic vibration larger than the periodic one, and also the power. The power here is larger than the for quasi-periodic solution, as you can see in this response, larger than the power of the periodic solution. Another example where the time delay is applied in the both components and only the one on the mechanical component is modulated, we have also obtained nice result, the stability chart here with the response and the power, and also we can show that in the control system we can increase the region the power of the response power. So this is what we have done in the classical one-way oscillator. Now, let's go back to the biarrhythmic oscillator. If we consider the biarrhythmic oscillator, the problem and the question is, because we have two limit cycles, one small limit cycles and the big one here, what happens for amplitude in the response when we add the modulated time delay, as in the first example? And depending on the result, this can be interesting for energy harvesting. For example, for the larger limit cycle amplitude, for the green one. So, and this is what we are doing. So let's now see some recent papers result on the problem and what it was done for controlling the biarrhythmicity. Here, in this paper by Gauche et al., they studied the control of biarrhythmicity by time delayed feedback. Look at this term. This is the time delayed feedback. And they have obtained this interesting verification curve. And you can see that we can divide the parameter plane alpha beta in two regions. One region where biarrhythmic exists, and the other where monorhythmic exists. Later, this was all studied also control of biarrhythmicity with conjugate self-feedback. And they show that depending on the control, we can eliminate this region of this stability or of biarrhythmicity completely. Here we have without control, and we have the two regions, and here we have with the control, we have only monorhythmicity. So there is no rhythmicity as we see. The control eliminates the rhythmicity. So this is the objective, is just to eliminate the rhythmicity. And another study on the problem by Biswasi all. They studied the control of rhythmicity by self-feedback approach. And as you can see in the parameter plane U and D, D is the self-feedback strength, we can obtain the region of the rhythmic, here, monorhythmic, and also sudden mode bifurcation, half bifurcation, and so on. Now, let's go back to our problem. As you can see, we add the modulated time delay here. So you have the modulated time delay with in the position, and just we take the time delay in the velocity. And as first result, we can see that the effect of the modulated time delay on the region of the rhythmicity, just you can see that in the absence of time delay, this region is small, and in the case of the unmodulated time delay, this is the region in blue, and with the modulated time delay, this region of birhythmicity is large. So the effect of the modulated time delay is just to increase the region, the domain of the rhythmicity. So this means that we can increase the domain where the two limit cycles exist. And this can give information about the large amplitude of limit cycle. And if just we see some response in the for this region, you can see the response. For example, the rhythmicity we have here in the blue region, we have the rhythmicity, and we have for two different initial conditions. We have two limit cycles. We obtain the small limit cycle and the large limit cycle. And in the region of monorhythmicity, we can have only one limit cycle, and as you can see here, this is one limit cycle in the green region, and or we can obtain also if we go out in another region, we can have this limit cycle with large amplitude. Now let's discuss this stability chart we have obtained in our problem. As you can see, this is the stability chart, and we have many. We can see many regions. We have the white region here. We have only monorhythmic harmonic oscillation in the white region. You can see the response here. And this is the response. We can also have this region where this is interesting, big quasi-periodic rhythmicity. So this means that there is some region where we have also, in addition to be arrhythmic in periodic regime, we can obtain also be arithmetic in quasi-periodic regime. And we can call this the quasi-arithmetic oscillations. So we have two quasi-periodic solutions, one stable, of course, and one quasi-periodic solution with modulated small amplitude and the other with modulated large amplitude. As for the periodic solution, and if we compare with the classical case of Van der Pol oscillator, the case studied before, then you can see the difference between the stability chart here for the classical case and the stability chart for this new case. But it is interesting to see the difference. Of course, in the classical case, we have only limit cycle or quasi-periodic solution. But here we have many possibilities. We have quasi-periodic solution, two quasi-periodic solution, two periodic solution, and many possibilities in the arithmetic oscillator. And in the variation, in the plane of variation, period of amplitude, periodic, quasi-periodic solution versus lambda 1, this is the parameter of the modulated time delay. So we can see an interesting result here. We have the stable periodic solution with small amplitude, and the large one here with the large amplitude. This is the two limit cycles. And between we have the unstable limit cycles. So this is the situation, classic situation in the periodic case without control. But when you add the control, the modulated time delay, as you can see, here we can also have the quasi-periodic. This is the quasi-periodic response. This is the quasi-periodic branch. We have a stable here, unstable between, and another stable quasi-periodic solution. This is as in the classical case. And as we can imagine that this can be used for energy harvesting. We can all use this large amplitude in the quasi-periodic regime and in the periodic regime, all in this range of parameters to harvest energy. And all in this range of response is of the amplitude. We have stability in the quasi-periodic region, here and here, and in the periodic region. And if you go to the frequency response, you can also have the same situation. We have two stable periodic solutions. Between we have unstable, and the green curves correspond to quasi-periodic response. And as you can see, this is interesting because even in the quasi-periodic region, the modulation is very small. So we have, means that we have almost periodic, as this response is very, very close to the periodic solution because the modulation of the periodic solution is very small. And this result, this is a nice motivation for our going work, and to show that how to use this result in the biorhythmic, in the quasi-periodic biorhythmic response to harvest energy, and this will generalize the case we have already studied for the classical wonderful oscillator. So, as conclusion, we have studied the effect of modulated time delay on the rhythmicity. In this, we have shown the model and the difference between the model and the classical one. We have shown, we have obtained a different region in the parental plane of monorhythmic, birhythmic, and quasi-periodic response, and determined the stability chart. And it is shown that the modulated time delay induces quasi-periodic rhythmicity. This is a new result in this problem. Then, as ongoing work, we are studying this problem and using large amplitude responses in biarrhythmic and in quasi-biarrhythmic responses for energy harvesting. This is why I would like to present today. Thank you for your attention. Thank you.
So thank you, Professor, for the presentation. And now the question session is opened, so you are free to ask questions. Professor Becher, I have one question actually, because there are several applications of, for example, Duffing oscillator in mechanical engineering, where you can see the double potential well systems. But do you find any possible applications of Van der Pol oscillator in the real application in mechanical engineering? I'm not sure if you heard him.
Yes. So the model where we are considering, as you see, is the generalized Van der Pol oscillator.
Yes.
So for the classical Van der Pol oscillator, the application, there is many applications, and I imagine that as in other examples in biology or in chemistry, the rhythmicity exists and it is studied. I am confident that we can find this kind of response and of dynamics in mechanical engineering. I guess I'm not a specialist, but I guess that there exists some application in mechanical engineering. Yes.
Because, Professor, my first thought when you have two periods, I was thinking about the airflows. For example, on the fuselage of planes or flights.
Sorry, can you repeat your question?
Okay, because my first thought was the application of, because you have two periods in your response. So I was thinking about some airflow applications, for example, in planes. I don't know if you heard me.
I have some problem to listen. There is some disturbance in the phone.
So, Professor, maybe I will contact you because I'm also taking part in at your conference next year. So maybe I will just write you an email in that case.
Okay.
Okay, thank you, Professor, for your presentation. And now, okay, maybe King Cao, do you have a question? No, there are no more questions. Okay, so Professor, thank you again for your presentation. And now we are coming back to the young researcher session. It was a great opportunity to meet you at this conference and that he gave this lecture. Okay, so now we've got there is a time for next presenter, next presenter from India, Vishnu Roy Chaudhuri from Shiv Nadar University. And I don't know if you hear me, Vishnu.
I do. Thank you.
Okay. Okay, Professor Belhak, so could you stop sharing the screen, and now we will move to the next presentation.
Yes.
Can you see my screen?
Not yet. Wait a minute. Professor is looking for the button.
Yeah,
the button. It's in the bottom of. Okay. Okay, Vishnu. So now we see your screen.
Thank you. Yeah. Okay. So I'll start. I'm Vishnu Roy Chaudhuri, and I'm from Shiv Nadar University, along with my partner Siddharth Pillai. He's also in the session. And
Vishnu, one question only. Can you close the window from Zoom, because on the right side there is a black square, and
okay,
we can see this. We can see the content.
One second.
Yes.
Yeah.
Okay. Now we see more.
Right. Sorry about that, but yeah.
It's fine.
Yeah, so I'm currently doing, Siddharth and I are currently doing a bachelor's degree from Shiv Nadar University. We are in our 4th year, and we're working under the guidance of Professor Venkatramani from SNU as well, and under Pradeep Malaji, Professor Pradeep Malaji, who just presented very lucidly just moments ago. And what we're researching into is basically the response of nonlinear energy sinks under various excitation conditions. And we will be looking at, as Pradeep sir mentioned in his presentation as well, we'll be looking at the energy harvesting aspect of it, and we will be looking at the control aspect of it, that is being able to use these systems as a mode of controlling vibrations in systems. So as an introduction, this is the work that we're doing. Basically, yeah, we use nonlinear energy sinks. More specifically, in our case, we're using a pendulum nonlinear energy sink to control primary structure vibrations that respond to a range of excitations. And yeah, basically, we will be converting these, we will be using electromagnetic flux as our means to convert this the mechanical energy into electrical energy, so that it can be used later on. And we will be also analyzing the response of these systems to random vibrations and to different types of random vibrations and noises. One thing that I will have to mention is that this is an ongoing project. We are halfway there. We are not done. It might take a couple of months. But our end goal is to analyze different types of noises and the response of these systems to those noises. So why energy harvesting helps in basically using or uh, uh, basically using energy that might go to waste otherwise. So energy harvesting is a increasingly growing field and a field that we can is worth investigating into. And we will be using the concept of a dynamic vibration absorber, which basically reduces vibrations in the primary structure. And there are quite a few phenomena that are associated with using a dynamic vibration absorber. Some of them are targeted energy transfer, which is basically the secondary, the absorber, the secondary vibration, the secondary structure uh, can absorb energy from the primary structure and dissipate that energy so that the vibratory response in the primary structure is reduced. So we're basically dissipating the energy. So in the case of, let's say, buildings, for instance, let's say type A 101 actually has a system where it uses a tuned mass damper to reduce the vibrations in the building. If it weren't for the tuned mass damper, which is a system that many high-rise buildings use, there would be very uncomfortable vibrations in these buildings. So, so this is a critical review of literature. To start off with, we would like to analyze the deterministic response of this system. That is basically what this is. The first paper that we analyzed was from Malaji sir's paper, which is yeah. Mm, Right. If I could just move on so I can explain these a little better using the system that we have. So the this is actually the mathematical model. We borrowed this model from Malaji sir's paper itself. So this is the model that we will be using. On the right side, we have mentioned all the different parameters that determine the response of this system. And what we do next is we basically take the Lagrangian of this system is also at the moment in the deterministic condition. So xg provides us with the base excitation problem, and that base excitation for the deterministic case, we will for the deterministic case, it will be in the form of a sinusoidal function. So when we take the Lagrangian, what we get is, because we've got two parameters that actually vary, we've got theta and x. X would represent the vibrations of the primary systems, and theta would be the vibrations of the secondary system, that is the pendulum. So this is the Lagrangian that we get, and the damping coefficients as well. So upon solving these equations and taking the Euler-Lagrangian form, we reduce it to this form. It is a set of coupled equations, and the equations for voltage we get from the Lorentz law, where the EMF produced is proportional to the flux that's changing, which in this case is dependent on the angular velocity of the pendulum, which is moving. So we then non-dimensionalize these parameters. So if you just look at the bottom, you will see that U over here would represent what would be the excitation of the primary systems. Theta stays the same, but yeah, basically these are the non-dimensionalized parameters. So our initial results we only considered the system without the these are the parameters that we used for our analysis. I can come back to this if we have to, but so this is the response of the primary system without the isolator, without the pendulum mass, and as expected, its response to a harmonic force shows that at resonance frequency, omega over here is the frequency ratio, which is omega by omega 1 over here, if you can see it. Omega is the drive is omega over here is the frequency is the driving frequency of the forcing, which is f this parameter over here. So as expected at resonance, we get this response. We get a peak at omega equals 1. So this is our with our pendulum nonlinear energy sink. This is actually the response that we get. We see that there is at the omega equals to 1, there is actually a trough, not exactly at 1, but close to 1, there is a trough, which actually goes to show that this energy sink actually acts as a sort of absorber, and it reduces the amount of vibrations that we can get at this resonance. Another key thing to note would be that as we vary these parameters, we actually see that these colors seem off. This is not how. I'm sorry about the colors, but what it's supposed to be like is R1. The blue line is supposed to be yellow. I don't understand why it's. But yeah, the blue. This is supposed to be yellow. The yellow line is supposed to be blue, and the purple line is supposed to be red. I'm sorry about this inconvenience, but we see that as we change the parameter, R1 and R2 represents the frequency ratio of the natural frequencies of these two systems, of the primary system and the pendulum system. So as we change that ratio, as we increase that ratio, we actually see a shift in the graph towards the right. We also see a change in the peak. So this just goes to show that as we vary these parameters, the frequency response to these of this system can be changed. So over here, as we vary R, we see that the graph moves towards the right. Over here, what we see is this is the graph for the EMF produced versus omega, and we see a similar response over here. The graph is moving towards the right as we increase the R. And over here, we are changing another parameter, which would be the electrical damping coefficient. This electrical damping coefficient is a factor of, well, if we just go back, what we will see is that we have a sort of a dynamo system over here, which is basically used for converting this mechanical energy into the electrical energy that we need. So, and this provides a certain amount of damping. So as we non-dimensionalize that, this would show us the non-dimensionalized electrical damping coefficient. And as we change that as well, we see a couple of changes to our graphs. What we can notice is that this peak is in a different position than it was before. So one thing that so basically the gist of this, the takeaway from this is that varying these parameters can help in A, reducing the vibrations in the primary structure, and B, increasing the amount of voltage or the energy that we harvest from the secondary structure. And it can be used for a wide range of frequencies. As we change these parameters, we can tune it so that it responds correctly to these certain frequencies. So basically, that is what this would show. These are the graphs for these are the time domain graphs that we get as we vary the electrical damping coefficients. And we have just noted down the RMS values for of these graphs after as it reaches steady state. This basically provides a certain amount of insight as to how these will behave, and also gives us something to hold against as a standard for when we are analyzing for random conditions. So these are the values of U that we get for the deterministic conditions. So as you see, as we decrease the electrical damping coefficient, there is an increase in the RMS values of the amplitude of the primary system, primary structure, as expected. Similarly, as we see a similar response over here, as basically this the same thing. So over here, we will now move on to what we are trying to do basically, which is to introduce a certain amount of randomness. The purpose of introducing this randomness is twofold. One is that randomness would probably provide a better insight into how this system would actually respond in a real life scenario, and how this system can be used for practical purposes. Another reason why we would introduce randomness into this system is to investigate how these nonlinear systems, how a nonlinear system can prove to be more effective than a linear system, say a tuned mass damper, when it comes to dealing with random vibrations, because we have such great control over the frequency response of these systems. So this is why we would do this analysis. That is the reason. It would also be interesting to note that these systems would obviously respond differently to different forms of randomness and different forms of noise. So this is a similar graph as from before. We see similar characteristics as before. What we do see, what is interesting to note, however, is that over here we are only changing the amplitude of the forcing. So if it's in the form of, if it was in the form of F naught cos omega t, and what we are changing is the F naught term. And the F naught term basically turns out to be a F mean that we consider, plus a sigma, where sigma is the random component. So for each sample, we get a different value of sigma. Sigma basically shows the amplitude or the maximum range of randomness that we can get. What we notice is that this is the same graph, same analysis, time domain analysis that we did before. What we notice is that as we increase our amplitude of randomness, we actually see that there is an increase in the energy that is harvested, in the sense that there is actually greater EMF that is produced. So introducing randomness to this system actually increases its response, and the increase in randomness also leads to an increase in the way that this responds. Similarly, when it comes to the excitation of the primary structure, which happens to be something that we are seeking to reduce, uh, uh, with the increase of randomness, we see an increase in the amplitude of the excitation of the primary structure as well. So this is one form of analysis that we have done, at least so far. There is more to come over the coming months. This is a very incomplete analysis, so to say, but hopefully we will be able to come up with more in the next few months. One of the reasons why it might be why we are looking into different kinds of noises is intuitively speaking, one might sort of figure out that different forms of noises would cause this system to affect differently. So if our noise were to have a period of, if our noise were to change at a frequency that was much smaller than the forcing frequency itself, we can expect that the response of the system will be quite different from a system where the noise, the frequency of noise or frequency of randomness is close to or greater than the forcing of the system, a frequency of the forcing of the system. So just from an intuitive point of view, it makes sense to perform an analysis on this system. What we have done here is we have basically used we have used a uniformly distributed randomness using the RAND function in MATLAB to generate that. But it would be interesting to see what would happen when this system is subjected to other forms of additive noise, such as white noise or Gaussian noise or pink noise or brown noise. White noise is sort of what we've done now. But that provides us with a scope for the future into how this might help us form a better analysis. So yes, thank you. That would be all. I would again thank the Lublin University of Technology for providing this opportunity for Siddharth and I to present our work.
Okay, so thank you for your presentation, Hishno. And now you can, everybody can feel free to ask the question. Okay, Hishno, because I don't know, do you hear me?
Yeah, I do.
Okay, so because I'm also dealing with the pendulum systems, and you showed the model. Is it a non-dimensional model, or and how do you consider how do you select your input parameters to the model?
It's not a non-dimensional model. We do non-dimensionalize the parameters that we are using. It's certainly not a non-dimensional model. We will be associating units and masses to everything. But how we come up with it, so the parameters for analysis to this are actually, one is that we wanted to make a coupled system, one that would introduce a certain amount of non-linearity to it. So that is how we chose the system. And from that system, as we started off with the system, we kind of worked backwards, and we saw that these are the parameters that sort of affect because we don't want to go into the material nonlinearity or the other forms of nonlinearities. We just want to go into the geometric nonlinearity. So again, based on that initial purpose of analyzing just the geometric nonlinearities, we have chosen our parameters for checking the system.
Okay, and also another question, because you also mentioned about the random excitation, and how do you select initial parameters, or how do you select the excitation? It was in the end of your presentation.
Yes. So it's actually something that we haven't shown in our presentation, unfortunately. We didn't have the time to add it because it was sort of incomplete. But basically what we saw is that the initial conditions of the system don't really change the outcome or don't really change our analysis. We get the same results. We get the same, our EMF produced increases with the amount of randomness that is there. Or rather the amplitude of the randomness that is there. So I hope that answers.
Okay, and do you plan to build the real setup, or now you base it on your experiment on the model? And
so far we don't really have any plans on having a physical actual setup per se, but we do want to analyze this with more forms of noises so that this would be better accustomed to a real life scenario if someone were to use it. So.
Okay, so that's all the questions from me. And if anybody has any question, you can ask it now. But I don't see any more questions. Okay, so thank you, Ishno, for your presentation. And now we've got the last presenter from the second session, from Young Researcher session. It is Yaratinam Murugesan from Indian Institute of Technology. And I don't know if you are with us, Yaratinam. I see Ratinam in the chat, but can you hear us? Nie, to nie on. Ratinam, we don't hear you actually.
Yeah, could you Tinam, could you maybe unmute your microphone? Yeah.
Please you check your option. Because in your PDF it changes your okay. Rayatinam, can you check the internal settings of your audio? We see you, Rayaratinam, but maybe could you open your presentation not in the browser, but in PowerPoint, otherwise, I don't know, in any other software? Because you're unmuted, but we don't hear you. Ja mówię, żeby wyszedł z przeglądarki. So Dr. Rayaratinam, one request. Maybe you can change your presentation into the software, but not to open it up in the browser. Because we see your screen, but we don't hear you. We still don't hear you. And can you check the button mute, and you can check the you can test your speaker. The bottom. It's in the bottom of when you open up Zoom now, please. But it will not be here. I think meeting controls, if you can open it up. Otherwise, you can log in to the meeting again. With the wait a minute, I will send you the. I sent you all the data to log in into the chat, but please, before it, copy it to your copy it somewhere and later use it for login again. Otherwise, everything is in the chat, meeting ID and passcode.
Zależy, ile ta rozmowa będzie trwała i jak, jeżeli to będą takie, wie pan, czy jeden drugi przeszkadza, to tak, a jakiś czas bardziej, że mówi, druga, to będzie troszeczkę taki dyskusja, nie prezentacja, że jedna słowa, a więc mogło pójść na pewno nie będę tego. A ile to może być? Planowane jest godzinę.
So we will wait a few minutes for Dr. Murugesan. So maybe let's give him 5 minutes. Maybe he will log in again. Okay, so Dr. Murugesan, do you hear us, or can you contact me on the via chat? with your presentation now, but maybe you can check the other devices which are connected to your computer, because the voice can be transmitted to other device. Ja wiem gdzie.
Hello, can Ratnam, you hear me? Can others hear me? Hello?
Yes, sir, we're able.
Okay, Ratnam,
Yes, we're able.
what you can do is, if it's possible, you can share the PPT with me. I can present it on your behalf.
So thank you, Doctor. It was actually my next advice, because he's your co-author.
Yeah, so I would request Ratnam if you can share the file, or at least you open it. If I tell next slide, you can go to next slide. If that is also possible.
Because I think he can hear us, but he cannot speak.
Right, so I'll go ahead with the slides, and Ratnam can go to next slide if that is possible. I know it's a weird arrangement, but that's what probably we can do right now to not waste time. Yeah, so shall we start? Ratnam, you have to tell at least in the chat that you can hear me. Yeah, so this work is what we started in Swansea University. It was related to, we have heard Pradeep giving a talk on energy harvesting devices, where he wanted us to know that energy harvesting devices as by its own may not be so much useful, but if you can club it with some other applicable devices, yeah. Hello? In that case, it will be more useful. So this was the idea that we had a long time before. In 2012, we published a small paper on how to use energy harvesting along with control devices for structures. For example, if you have, so the idea came out like, the idea came out as like, where do we see more vibrations? So energy harvesting needs vibrations to happen to get more energy, whereas a controller needs to suppress energy. So those two are completely opposite goals when you deal with structures. What's happening now? I don't know, the screen is off.
Yeah, wait a moment, yeah, because I think it's probably some temporal.
Oh, so Dr. Sheikh Farouk, maybe do you have this presentation or not? Because
I do not have this presentation. It is with him. If I had it, I would have presented it myself.
Nie ma już tej prezentacji, tak?
So Dr. Sheikh Farouk, because maybe one question, I don't know if you hear me.
Yes, I can hear you.
Because maybe we have one idea, because we are unsure. Maybe you can do this way. So now Dr. Ratnam can send you this presentation, and there will be one free time between 5 p.m. and 5:30 for Vijay Patil, but we are not sure if he joined us. So when you can present this his research.
Yeah, that will be very nice. If you get some time, let me know. and I will present it. Otherwise, we will probably, if you don't have any slot or time, then it's okay. It's not a problem. And if you get some slot, let me know. I will go and present it. That's good. Thank you.
So it will be 5 p.m. Of Polish time. So wait, I will look into the. So in India, it's supposed to be 9
9:30, 9:30, or 9 p.m. Okay, I'll go on
9, because there is a time difference between to 3.5 hours.
Okay.
So it will be the time for you of Vijay Patil, according to the program.
Sure.
Okay, so you will deal with exchanging the data, the presentation.
Yeah, he will send me the presentation and then I will present it to you.
Okay, so we will not lose his research. Okay, so thank you very much.
Okay. Thank you.
So, but now we have to move to another panel with entrepreneurs. So now Dr. Worszak will make an introduction.
So let me apologize for all the time consumption and mishap that happened. Sorry for that.
Everything is fine, but we will we'll catch it up.
Sure. Okay. See you that night then.
Okay. Hello. How are you? We prepared this panel for meeting of entrepreneurs and scientists from Poland and abroad, from Nevada, from India, and we hope to talk about some special important topics for starting cooperation between different groups. There isn't any program for this panel, and if somebody want to present some idea or topic, it's free time for discuss. I have the. I'm not sure. Do you hear me very well? Because we are together with entrepreneurs from Poland. Okay, from Poland, Łukasz Kurzępa. This is the scientist from industry. We can ask together. If somebody want to say something, please free to tell. Is join to us.
Oh yes, hello, Paweł Kwiatkowski from State of Nevada, Director for International Trade, and of course Nevada is represented today also with Matt Westfield, entrepreneur in residency, University of Nevada, Reno, and also an Entrepreneurial Assembly, Nevada. So hello, Matt. So we are representing Nevada, but I am in Poland. He's in northern Nevada right now. So I have an idea that if I would be able to share the screen, I may tell you just a few words about Lubelskie Nevada collaboration, because we are in the kind of this very special partnership. And one moment, I will try to do that.
Yeah, so we are just.
Okay. And just to make sure that you will see, do you see my screen?
Yes.
Okay. So just to tell you, it's we are sharing as a Nevada and Lubelskie Voivodeship. We are sharing very special relations, and that would be one of our major point in our discussion from Nevada. But also, what is important is that the startup ecosystem in the world are having enormous problems, and those problems need a lot of innovations in the approach. So I believe that our title of the conference, Innovations in Practice, is very important also for how we can answer or adjust to the needs of startups in Lubelskie, startup in Nevada and globally. And I just collected a few information from Startup Genome and other sources, but basically 41% of startups, doesn't matter in Nevada or Poland, are threatened because of the COVID-19. And the problem is that only in the United States, nearly 70,000 tech startup founders lost their jobs already because of the COVID-19. And the situation is now that the governments, local governments, federal governments have to answer, have to build special programs. And basically, if we will not answer, the problem will be that this sector will be one of the most affected by in the pandemic times. So because of that, we believe that our collaboration between the state of Nevada and Lubelskie Voivodeship is one of the, I would say, best recipes to answer the problem. And just a short history of this collaboration, just to let you know, all the contacts started in April 2015, and we went through several trade missions. And in 2017, actually, that was a very special moment in October in Lublin, in the Lubelskie Conference Center, where the special agreement was signed by the Marshal of Lubelskie Voivodeship and governor, the former right now, but the governor of the state of Nevada, Brian Sandoval, who is now the president of the University of Nevada, Reno. And the agreement was signed about the creation of the special multi-level, multi-phase acceleration program, and we had several cohorts in 2019 and 2020. And interestingly, the last cohort of the companies from Lubelskie came to Nevada just before pandemic time in January this year. And of course, this is the logo. But interestingly, this program is built as one of the most advanced acceleration programs Poland has, and Nevada also, with other parts of the world, because this is the 14 days with basically split between Northern Nevada and metro areas in Reno and Carson City, and of course Las Vegas, but with the several mentors involvement. And we are very blessed that Matt Westfield is with us today, and he will continue in a moment, because he spent with Lubelskie companies, I wouldn't like to joke, but if I say 100 hours, it will be over. That would be too less to tell. Probably 1,000 hours already spent with Lubelskie companies to help them answer the basic question, how to expand globally. And this is just to be very frank, this program is not about expansion to Nevada. It's about opening the eyes for the companies from Lubelskie to enter international markets, global markets, through United States and through Nevada. That's the major reasons for that. And interestingly, we have a lot of successes. That this is the last cohort we were able to gather together. Now that the times are, of course, different, but I just like to point out to you for the picture on the top of the screen, because besides I am the director for international trade for the state of Nevada. I am also the professor of Warsaw School of Economics and SGH. And just in the middle of the picture, there are my two bosses. So one is Christopher Sanchez from the Governor's Office of Economic Development, and just nearby him, on his left, is the right now former rector of SGH, Warsaw School of Economics, Senator Marek Rocki. And around that, there are many people from Nevada and from Lubelskie who attended the one of the last cohorts of from Lublin coming to Nevada, and this is done in the this picture is done in the innovation center in Reno. So how we are answering the problem, and that would be my kind of the major motion today, is that of course not everything can be transferred to online, but of course what is important right now to keep relations, keep the companies engaged, give them still work to do, kind of the homework to prepare before their international expansion. So what we are trying to do, we are trying to move our platform we are using for the companies from Lubelskie. We are calling the platform Nevada Global Virtual right now. We are trying to use webinars. We are trying to even organize bootcamps for those companies, and of course demo days, everything virtually. And we believe we are able to do that. But on the other hand, there is the fourth element, which is the most important for us, so physical presence. And basically what we are ready to do is to move these three phases virtually. But the fourth one, the most important, the physical presence, physical trade mission, we are just waiting for the better times. And as you know, there are a lot of mixed signals right now when the situation improves. But I am a very close follower of many experts, especially in the United States, and last claims from, for example, among others, Dr. Fauci, saying that we may expect a wide distribution of vaccine in the United States, and hopefully also in Poland, Europe, as soon as in April next year. So having that in mind, we are doing everything to stay connected with the companies. We are working, and great big thanks to Marshal Office of Lubelskie Voivodeship, and especially and in particular Danuta Sułowska, who is our counterpart in that program in Lublin, in Lubelskie. But on the other hand, we strongly believe this is the time for the preparation. This is the time to make connection and wait for the opening the world again. And we believe it will happen. It will happen soon, and maybe not in the first quarter of next year. But I am a strong believer that the second quarter of next year will be our coming back. Maybe not as a very that would be slow phase coming back to normal, but we believe that this will happen. So these are my email contact information. I am very grateful also for Professor Tomasz Klepka that I am able to be today together with Matt Westfield. Congratulations for the whole conference, and I have to tell you that this is only one kind of the glimpse about the Nevada-Lubelskie collaboration, because also Lubelskie and Nevada are now bound by very important commercialization project, which is also Matt Westfield and our University of Nevada, Las Vegas are there. So thank you very much for this opportunity to start. But I'm watching Matt Westfield, because I'm sure there is no one in Nevada who knows better Lubelskie companies than him. So thank you again, and of course, yeah, I'm very grateful to be with you.
Maybe who have questions about this cooperation. Maybe some idea for cooperation is energy harvesting. Our idea is using the energy harvester for powering the small devices for monitoring in the industry environment. What are the expectations from industry or offer from science? I can ask Łukasz or Grzegorz or other participants, please.
May I talk a little to Pavel's program that we discussed, ladies and gentlemen? Is that okay?
Sure.
Thumbs up? Okay. So thank you very much, first of all, Pavel, and thank you for that wonderful introduction. It's good to see you, brother. Hugs, man. Hugs. Nice to see you. And Dr. Klepka, Tomas, thank you. Good to see you and my other friends on the call. It's great to see you all. Thank you so much. So one of the other programs we're working on is a program where I have a nonprofit, the largest in Nevada, dedicated to entrepreneurship called Entrepreneurs Assembly. And through that program, we've been working with another division of the governor's office to oversee a pilot program for all technology transfer out of the University of Nevada, Las Vegas. Now, I know you didn't think you heard that right. I work for University of Nevada, Reno, but I'm working on this program with University of Nevada, Las Vegas through their economic development and their commercialization tech transfer research and development, research and innovation department. So basically what we've done is we've taken a 2-year pilot program. We are overseeing myself and a group of other entrepreneurs, a world-renowned intellectual property attorney, people from all over, including peripherally the founder of Bluetooth, John Hodgson, who's a retired Brit who lives here at Lake Tahoe. And I've assembled 7 people from across the state of Nevada who are incredibly talented and very successful entrepreneurs. And what we've done, ladies and gentlemen, is we've started overseeing the portfolio of technologies coming out of the University of Nevada, Las Vegas. Basically, they've aggregated them, and any of them that are in patent, have started filing for patents, have done their disclosures, we then take them out. If they haven't done disclosures yet, they're not officially, looked at as a commercialization project yet by the university here. Well, what's happened is we had a goal for 2 years of 4 licenses and or spinouts. And we had basically about $300,000 US to do it. Well, I'm excited to say that the first year of the program is just up, and we've already finalized 3 of the 4 for half the money. So what does that mean? It means basically we have another year of the program. We can commercialize now up to 6 or 7 technologies potentially for at least get them prove the technologies work, and then find licensees and coordinate the licensing from the university side to the corporate side, to the private sector. Now, what does this do, ladies and gentlemen? What it really does is it brings entrepreneurship and technology together. The problem with tech transfer that we have in the United States, and I'll be very, very honest here for those of you who've been here, we have 300 Division I universities, research universities. Of those, most of them have commercialization, technology transfer. Of those, there are about 5 institutions that do it well. The other 295 in the United States struggle. And these include departments that I've personally spoken to at Cornell University. They have one of the best Department of Agricultures in the world. Have a heck of a time commercializing their technology. One of the problems that I found in 15 years of studying this, and having worked on SBIRs 30 years ago, I worked on virtual reality 30 years ago when we couldn't get a business model. So I'm very, very familiar with bleeding edge technology. The problem we inherently have that I've seen personally, and I've also spoken to many professors, department chairs around the country, and now around the world, thanks to Pavel. When you have academics working with academics to create entrepreneurship, there's a gap. And with all due respect, what we found in this partnership, if we can bring entrepreneurs together with brilliant scientists and PIs and researchers, we find the projects that have timing, they have the technology, they have the ability to be protected, and we can collaborate and intermediate between the university and the licensees. Because for those of us who've been entrepreneurs and have worked at the universities, we understand both sides. We understand one thing that I don't think many research and innovation departments understand, that these commercialization projects are not just patents. These are professors' life's work. And what I've seen is in the university system an inherent focus, let me just say, on the science and not on the professor. So they may get something licensed and it's kind of hard to do and it may or may not fit, but often the professor is off working on something else now. What we've found, if we can put a scenario together where the professor's life's work, it helps the professor for their future endeavors and helps protect what they've built to now, and create a licensing structure that the university wins, the researcher wins, and obviously the licensee wins, because we vetted the technology before we try to get a license, which also increases the value of the license. So a quick example, Pavel, and then I'll give you the floor back. We found a technology at the University of Nevada, Las Vegas that's a fire retardant. I happened to work on a cutting-edge fire retardant 15 years ago. There have been no demonstrable gains in fire retardant in 40 years. 40. Okay, since Nomex back in the 70s. I'm a race car fan, Formula One. And we all know that they're wearing the same suits now that they wore 40 years ago. What if we could improve those suits, make them breathable? What if we could make a better fire retardant that would have a higher burn proof and an efficacy that's superior to anything? We think we may have found it now. The one I worked on 15 years ago, the founder was killed. We never finished the technology. I got a second chance to work with the technology that may be revolutionary in fire retardant science. So what's happened is I got to come to Lublin with Pavel last, now what, 2 or 3 times, Pavel? I guess twice. Twice, yeah. And this last time, I went to the Lublin University of Technology. Wonderful. Dr. Klepka I met there. Pavel Shunowski I met there. Incredible laboratories. And what did I find? A polymer lab. And they've got all of the tools and the professionals and the students that can help us realize if this technology works or not. If it works, I have a licensee in the wings. The University of Nevada wins. Lubelski gets to work with us now on a future technology, and we're looking to put a division of the company right there in Lublin moving forward. So this is not just about research and development. It's about long-term collaboration, long-term commitments, and actually Nevada companies coming to Poland and elsewhere to find the best research, find the best talent, and find the best place in Europe to launch business operations for Europe and often up into Asia, into India. So right now we are finalizing the contracts with Lublin. Dr. Klepka, Pavel, thank you so much for all your help. We are going to begin 90 days of testing. We have a licensee in the wings for the fire retardant. Once the preliminary testing begins, we will then begin future testing in Lublin to create a polymer, create a fabric out of the polymer and a yarn, and then then a fabric, test that fabric and look for the best ways to weave and to create a new, basically a new version of fire retardant products that have never been seen before. And again, all of this is in the wings. We have preliminary funding. We have all the things we need. Once we prove the science, the value of the patents go up. Good for University of Nevada. Good for Dr. Bomick, who's the founding professor with the patents. Good for our project here. Great for Lublin, because now we get to do patents and projects in Lublin on future technologies. This technology may have already been developed, but we're looking at future technologies and collaborating technologies, working together with the lab in Lublin, hopefully hiring students in the next couple of years right out of the laboratory to come to work for this research and development company right there in Poland. How's that?
Maybe just like from my stuff, much easier, I guess, to hear.
Hi, everybody. My name is Lucas Kuzepa.
Hello.
I run a company, my own company, research and development company, and maybe that's something that you're interested in. Well, we don't do much energy harvesting, but we do things with vibrations and vibration monitorings at the moment. So at the moment, we are in a process of testing a wireless sensor, wireless vibration sensor, battery operated with the radio frequencies between 800, 900 megahertz, with a range up to of at least like 300 meters, depending on the speed. And essentially just measuring the vibrations. And the idea is to set up a company which will be producing these sensors, selling these sensors, and also owning sort of a platform, IT platform, whether it be like a website, some sort of like a tools, artificial intelligence, a tools to analyze the data, to predict the machine faults, the bearing faults, etc., etc. All sort of stuff which is helpful for companies, production companies, keep the machines in a good shape, basically.
Okay. So this is for remote, Peter, excuse me, this is for remote monitoring and manufacturing, correct? Is there a specific type of manufacturing you're focused upon that you built this for?
No, it's just looking at the bearings at the moment, but I guess you can do the same thing with pumps, you can do the same thing with engines.
So one of the things we do in tech transfer when we partner brilliant people such as you and your team with dumb entrepreneurs like me is we want to take and focus very narrowly and very quickly. And before we spend any money, who do you believe is the primary customer that needs this right now? Do you believe there is one? And is there a primary and possibly a secondary market that you either focused on when you built it or that you understand to be true, a place to start?
What the customers we're looking at are the customers who who knows they have a problem with the machines, who have a problem with the vibrations. That's the first thing. The second thing is they don't know how to do it because they don't have knowledge of analyzing the vibration spectrum, etc., etc.
Got it.
And the second thing is we're looking at the companies where like machines are working in a harmful environment where it's not easy to put the cable because let's say it's exposed with atmosphere, for instance. Then the battery operated sensors are basically perfect. Places where sometimes the sensors are very easy to reach. Sensors where the places where the machines, how to put it this way, or basically they don't have to be maintained all the time. The idea is to have a sensor which
remote monitoring,
remote monitoring, not online. It's just like this once a day, once per few hours. Just collect the data, just measure the spectrum, send it over to the cloud, do the analysis, and then give not the data but all the information about the machine to the customer. Yeah.
So we have a lot of mines in Nevada, Peter. We have a lot of mines, and the mining industry, as you know, you get a lot of vibration, you get a lot of issues within the mines, in the chambers with the vehicles. Okay, so one of the things I think, well, let's take this offline. Maybe send me, if you have a deck on the technology remember, I'm just an MBA business guy. I built 7 companies and I've helped others build thousands of companies. But one of the things I understand about bleeding technology is it's a wonderful thing, but often we have a solution looking for a problem. I helped a lithium sulfur battery company. And what did he tell me when I met him? Well, we can solve aerospace. We can solve automotive. We can solve da-da-da-da-da. I said, whoa, time out. He could solve everything. But the problem is, if we can solve everything, with all due respect, we don't solve anything. We have got to pick an industry. And what I like to do is I like to work with people like you and pick your brain. And you and we go out and we find the industry that is in terrible need right now of what you do. Because then we're not a solution looking for a problem. We are a solution that has a very big need, and we partner up with that company that's never been able to find the specific solution you're talking about. And now we go from a technology to a business. And we start listening to them very closely. And once we've solved their problem, we find others like them and we solve their problem, either in the same sector or in parallel sectors. And so the power of technologists such as yourself and entrepreneurs that we have out in the network who want to do this stuff, who understand bleeding edge. Not all entrepreneurs can do this, and I say this because you have to understand bleeding edge technology. We have to understand where you are now, and we have to understand how to defend what you've built in a market that's out there for little or no money, okay? Because then we do that. If it's not correct, or we can tweak it or pivot it, we then will spend the money when it's appropriate. But the bottom line is we've got to try to understand on fitting the puzzle pieces together as early as we can with your technology combined with a need in the marketplace. And if we do that, it's magic, because they're getting something that nobody else gets that puts them ahead of the game. It puts you into the marketplace to tweak this in a real life, not a laboratory, but in a real workable setting. And it also helps you understand what's it going to take to scale this business, not just the technology, the business. And the technology coupled with the business. How do we scale them in parallel? Did that help, sir?
Yeah, that helped a lot. Just so you know, we already have an MVP running. So we have built a couple of prototype sensors. We already have a testing setup where we test our sensors. We already have a website with just basic data presented in a sort of a nice GUI way. So that's not something I'm talking about it's not just an idea. It's already happening.
No, I understand. You're far along. Thank you.
And I really believe it's going to pay off at some point. So it's a real thing. It's happening. And I think it's just a matter of time where we'll be able to have first products ready for the first customers. So
I could see applications in construction, in urban monitoring, in when you're doing building development, you're building large buildings and things, and because a lot of the vibration that happens within those buildings can be extremely damaging, and the types of machines in there, and often you've got a 30-story building, like in downtown Warsaw, 20, 30-story new building going up, and they have people security, but there's nobody up and down in that building. So we've got to look at different types of appropriate applications, and I'd love to follow up with you. Pavel, maybe you can help me coordinate, and we can do a follow-up meeting with you and your team, and I can ask you some very pointed questions, and we can start extracting a little more about where you are with this, in what places have you done the testing now, things like that. We look at the MVP, we look at the website, we look at the message, not the message from a technology standpoint, with all due respect, the message from a business standpoint.
Sure, understand.
Okay? The compelling message that we want to get out of the laboratory and into the marketplace. And this is one of the things I work on with entrepreneurs from both here and Poland. And I have a team of incredible entrepreneurs around. So one of the things that we're working on right now, ladies and gentlemen, if I may say, Peter, part of this is we are working on a program to maybe work with Lublin and to do another pilot program where our Entrepreneurs Assembly Platinum team starts looking at some of the technology. Dr. Klepka and I are in preliminary discussions about maybe seeing if we can get the legal things worked out, where I can start doing the same thing in Lublin with partners here and in Poland that we're doing for University of Nevada, Las Vegas. Plus we have partners in India and all over the place, England, Norway, all over the place. So it would be really interesting. Plus with the contacts Pavel has working for our governor, we have a pretty formidable book and a network, I should say, I guess. So Pavel, would you like to speak?
Yes, let me add that thing that Piotr, all our necessary emails and contacts to us, Professor Tomasz Klepka has, but also please also try to be in contact with Danuta Sułowska from Lubelskie Marshal Office, Urząd Marszałkowski, because we are still thinking about preparing for next year for another edition of Nevada Lubelskie Acceleration Bridge program, and there are several eligibility criteria there. So because of that, there is a need to basically you have to know this criteria in advance just to be eligible for the program. So that's another thing. And let me point out the third thing. And Matt mentioned very interesting sector for you, which is mining. 40% of GDP for the state of Nevada is mining. And guess what? The biggest investor of Poland in the United States happened to be in Nevada. And this is the KGHM Robinson mine, which they invested in Ely, Nevada, and they have the copper and /silver mine there. So that's another connection we may have in the mining industry, because that's one of the strongest sectors in Nevada, but also in Poland. So that's the special bond between both the state and the country. But also it gives more opportunities, because you can also try to do it kind of parallelly in Poland and in Nevada. So that's probably the three things I just like to point out. Really, I believe this platform we mentioned, Nevada Global Platform, and the platform which are gonna right now are being built by Matt Westfield. It's unique. It's a unique way to approach, especially commercializations from the universities. This is one of the challenge. I am also from SDH, Warsaw School of Economics, and of course this is not a technology university, but I understand the challenge. We have a lot of startups also at SDH, and there is a kind of the permanent problem how to go from the kind of the academic solution from laboratory to the market. And it's not necessary, of course, every university has its own offices for commercialization, technology, etc. But I would say more holistic approach is always needed, because one of the answers is the international collaboration between states and regions, and of course collaborations between universities from different countries, because we can exchange the best practices here, and I believe we can share a lot, but we can also learn a lot from Lubelskie Politechnika Lubelska. Thank you.
Of course, that's great. Thank you very much for all these nice, fantastic words. I'm happy to talk about the idea after the meeting. Yeah, mining is one of the options, of course. I guess at the moment, like, we are testing the MVP, the business model. So I guess any input is much appreciated, to be honest, because at the moment you're in a testing state. Well, just an idea, to be honest. So any input from potential clients and collaborations would be very much appreciated. To show us the direction, what's the best way to go, what the best properties or the characteristics the sensor should have,
sure,
in order to provide the client the best service he would need.
I love it. So let's talk about this too. One last thing to Pavel's point. We also have a huge manufacturing sector in Nevada, especially northern Nevada, not Las Vegas, but Reno, northern Nevada, and Sparks, and out to Tesla. Okay, so we've got all of this manufacturing. And in this manufacturing, we even have Pavel, who's your friend? The Polish gentleman in Carson City with the manufacturing company.
Oh, this is the Polam Olgierd. This is the Polam Precision Machining Company. This is the name. This is the biggest Polish investment out of Warsaw and Poznań in Nevada. This is the basically precision machining services, mostly for interesting for Tesla, so for basically production of batteries, a bit of cars, but of course 50% is aviation. But when I contacted him recently, Olgier Dovnarowicz is his name, but when I contacted him recently, he said this is the best year for him. Actually, Nevada is our export rose by 20% to compare to 2019. Why? Because of this manufacturing base, and manufacturing base are transferring into the COVID-19. So a lot of equipment, especially medical equipment, is going to be produced and exported from Nevada because of the situation. So it's interesting example how the manufacturing sector was able so fastly to basically to transform from this company was 75% of aviation for the medical devices. So this is one of the examples, but this is another example of Poland's presence in this case in Northern Nevada.
So one of the things I bring this up, Peter, is because what we could do is get one of your MVPs over here, put it in his manufacturing, even if it's not the perfect fit. He would do it as a friend to us and as a friend to Poland and as an expat from Poland, right? So we'd set up, and I'm just giving you a hypothetical. We set that up over here and we test it. While we're testing it, we look to other industries to come look at it. And we figure out if we still don't know the best fit for your technology, we will have the marketplace help us for very little money. We will get it set up into a manufacturing facility, use it there, and show results that we can apply to other sectors, other manufacturers, till we find the perfect fit. But these are the ways that we as entrepreneurs look to build companies, and we look to do it by bootstrapping, because right now, as you know, there's not a lot of money in the world. Money is shrinking. We still have money available here in Nevada, Northern Nevada. Partly to Pavel's point, we're insulated. We're insulated because many of the businesses, my business, same thing. I grew 30% this year in my little company that I own. Now I have bleeding edge things, and I have a little lifestyle company I own. My little lifestyle company is booming, and it's in the pandemic. Part of that's being lucky. The other thing is figuring out how to quickly pivot, which entrepreneurs, good ones, know how to do. You've got to be able, think about it, ladies and gentlemen, those of you old enough, 1990, 88, 90, we had back then in the United States, we had a financial crisis. Okay, 1990, 2000, we had a crisis, right? The dot-coms. 2010, we had a crisis, the recession. 2020. So basically, we've had 20-year cycles in the years that I've been a businessman, or 10-year cycles, where the bottom falls out. And let me tell you, you start preparing for things like that when it keeps happening, especially as a business owner. So one of the things I'm trying to do now is help companies and help entrepreneurs and help technologists understand how this pandemic can affect you and how you can insulate your technology and insulate your startup to what is happening around the world, to Pavel's point, where 50, 60% are going under. I know startups that are booming right now because they protected themselves and because they know how to pivot in an awkward situation, an unstable market, which is where we are. We're in an unstable marketplace. So to stabilize your sphere, there are certain things that we as serial entrepreneurs know how to do. So I love working with scientists. I would love to get this program further down the road, Pavel. Tomas, if you're on there, I can't see you, but if you're on there, Tomas, let's get this done and let's see if we can bring some technology to Poland and help Polish companies and bring Polish technology to the United States to help American companies. This is what this is about, and I love working with my friends from Poland. You guys are incredible, and I love the spirit. So thank you.
Thank you very much. As I said, it's again very nice. Thank you very much for those nice words. Just so you know, we already have a scheduled testing in a company, sort of manufacturing company nearby. So we sort of have a plan of like 4 weeks of testing. Why we are doing this here? Because it's easier to fix something if something goes wrong, right? So I really like the idea of going to US to Nevada to test the sensors. Let me just make sure that they are all running fine as I expected. Then I'll sort of, with my peace of mind, will give you the sensors so then you can test them and then tell, yeah, they are awesome.
Peter, I would expect nothing less than giving me the best, because if you give us the best, you in return will get the best. And that's a really big deal. So thank you for that. But let me just say one thing that I've worked with scientists. Don't let perfection get in the way of marketplace.
We are not scientists.
Beautiful.
I'm telling you, we are engineers, and
you go, brother.
We just
bring it.
It just have to be good enough. It doesn't have to be perfect. It has to be good enough.
Excellent, excellent. You and I are going to get along fantastic. Thank you. Just make it good enough. We'll find people to buy it.
Sure.
Okay. Good.
Thank you very much. We made some steps forward because we talked about commercialization. Maybe some others voice about the application of energy harvesting or wider about the diagnostic industry and using our results.
Good.
Grzegorz, you said about your offer for industry.
No, I love it. I think there's a program here. By the way, I've spoken to the Marshal's office on several occasions. They are your Marshal's office is hugely supportive of this program. We've just spoken to them, what was that, a few weeks ago, Pavel, right? 3-4 weeks ago?
Yeah.
And they are hugely supportive, Dr. Klepka, of Pavel Shanowski, who's running the tech transfer in Lublin, and of what Pavel Petroshinsky is working on with us in Nevada. It's very exciting, but what I'd like to do is I'd like to take it further and make sure that we can put an agreement together where we can openly share with protection, the technologies, and in the spirit of collaboration, business models and potential partners. Because what I do, I think fairly well, is early on, we find partners. It limits the risk. It maximizes everybody's gain. Once you've got a partner, a corporate partner in there, everybody thinks differently and thinks better on both sides. And now we're thinking about the marketplace beyond the technology, and that's where it gets exciting.
Yeah.
Oh. Hey, Marshall.
Yeah, so I just want to tell that we are very, very much interested in some collaboration with industrial partners. We have some experience. However, our main focus is to do research. So we are looking for some problems, and then it's also good for us to find some industrial partners who are willing to develop some new ideas, and for example, this energy harvesting could be implemented in many different ways. One way is of course, this is the leading maybe idea, is to associate energy harvesting with sensors, and then you could have some autonomic sensors. So this could be very helpful, and for example, for sea monitoring or even some mining industry. I think that this is also very interesting point, because in mining industry, maybe you need to have some continuous monitoring, and these conditions are not very good, not good conditions for people, and also for medicine. Medicine is medical applications. For example, I've heard on one of the meeting, I was told by the presenter that these pacemakers for heart He told that you think that this is maybe not large energy you can harvest during walking and some activity. So this is like a normal everyday activity, but you know, you should remember that you have one day that you should exchange battery for your peacemaker. But if you forget, then it is you are finished. But if you have some additional, you know, source of energy, and this is charged, so this battery is charged continuously, then you needn't to remember a very specific day, but of course this is important, that you have to exchange battery, but you could be late for some days, and this is still working. Yeah, so this could be also applied for some other you know, industrial situations that the monitoring is working. You have to make some service, but this is not so urgent. It's not so urgent. So you are more flexible if such system is working, if you implement self-powering, because this is self-powering. Energy harvesting is such a way to reach that, and of course to enlarge this this effect, you can also make some hybrid system that you have not only the vibration, but you have also thermal and some other maybe radio frequency and different effects. So you could combine some effects, and you could make really good system. Yeah, to be. And when monitoring is very efficient if it is based on such approach. Yeah.
Thank you, Professor. I've been taking notes. Yeah, I've been taking notes, Professor. So thank you for this. And I'm looking, you're right, industrial partners. And to me, that is the key for getting science out of the lab. As soon as we get to where Peter said, to point of an MVP, let's go test it in the real world, because that's where everything gets proven or disproven, is in the real world application. So I look forward to following up with you, sir, and with the other gentlemen, but I don't want to take the floor. I want to give it back to my hosts. So first of all, I want to thank you all for allowing me to be part of this conference. I'm honored. I'm proud. I know some people on the call I've worked with, so thank you. Good to see you. And that's just from me. So I'll give the floor back to you folks. Thank you.
Oh, thank you very much for your
nice
sir. Words, and some ideas. Yeah.
Thank you very much.
Thank you again, because it's the night in the US. Yes. No, you should sleep.
It's 5 o'clock in the morning here. My family's asleep at the other end of the house.
Okay, thank you for participation. Łukasz left us because he have to go to his business. Maybe other participants have to say something from this topic about the commercialization offer, request, or other idea, some thinking about cooperation. We know about the cooperation with Nevada and India. We know that you have from Nevada some different program for cooperation. We will propagate information about this program on our project website, and I ask another participant for other. Maybe. Okay. Because today we present some research results, but we hope to application in real.
If not, we will close the meeting, and we start the break after we start after 1 hour and a half. We start some next presentation.
So Peter, let me just say, for those on the call, you can work with Pavel Petroshinsky, who's here. Wave, Pavel. Wave. So Pavel has information. Everything I'm doing is through with Pavel in collaboration with our governor's office, with your marshal's office, and with the Lublin University Technology and your tech transfer. We're going to get all of us together and see how we can help with this and other programs like this to build an exciting vehicle for commercialization, international commercialization. I think this is an exciting meeting. I'm honored to be able to speak to this, and I hope it brings some excitement to the people on the call that there is potential, even in the pandemic, for pushing forward and for success. And it is. There's a lot of opportunity right now, so we just have to embrace it. Thank you, Peter.
Thank you. Yes, of course, pandemic time, it should be time for step forward, for maybe jump forward. We have cooperation with some small and bigger companies from industry. We invited them today, but probably they look at us at the YouTube streaming because they have another task to do. But we will propagate our information later. Thank you very much.
And let me just add the one thing, what kind of the following Matt thoughts. This collaboration which between your Marshal Office of Lubelskie and of course Politechnika Lubelska, and when we go on Nevada side, this is Governor's Office of Economic Development, but with very strong involvement of two strong universities, the University of Nevada, Reno, and in the case of one case of commercialization already, University of Nevada, Las Vegas. It's all of them are strong research institutions and also have strong engineering schools. So this creates extraordinary opportunity, and in case we'll have some spin-off companies, obvious win-win situation in such a difficult time, we may create a value. I strongly believe that.
Thank you. Maybe I will ask, because I see that Damian Gąska in our room. Maybe Damian, you want to show your screen, we show your face, and say something if not, okay. Thank you very much. Thank you very much, and have a good luck. Yes. Yes, and at 4 o'clock in time of Polish, we will continue. And now we will start some videos from Lubelskie. Yes. Okay. Thank you. Goodbye. Thank you very much.
Wybierz kierunek lubelskie. 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 Wybierz kierunek lubelskie.
Witaj, miło Cię widzieć. Chociaż znamy się nie od dziś, myślę, że jeszcze wiele o mnie nie wiesz. Znajduję się w centrum Europy, więc szybko do mnie dotrzesz. To dzięki ostatnim zmianom w infrastrukturze drogowej, kolejowej i rozwojowi lotniczej siatki połączeń. Za granicą jest o mnie coraz głośniej. Ostatnio mówią o mnie, że jestem smart. Wdrożone rozwiązania potwierdza certyfikat ISO i liczne międzynarodowe rankingi. Jestem pewien, że znajdziemy wspólną przestrzeń. Taką, w której będziesz mógł się rozwijać. Będąc kompaktowym miastem, gwarantuje Ci atuty metropolii, jednocześnie zapewniając komfortowe warunki odpoczynku z dala od zgiełku zatłoczonego miasta. Wiem też, że wspólnie możemy się wiele nauczyć. Dzięki mnie dowiesz się, gdzie inwestować w wiedzę. Pokażę Ci, jak kwitnie współpraca biznesu, nauki i samorządu. U mnie znajdziesz miejsca, w których innowacje nabierają realnych kształtów. Przedstawię Cię osobom, które mają na to swoje patenty. Zobaczysz, jak nowe technologie sprawdzają się w praktyce. Przekonasz się, że jestem dobrą inwestycją, nie tylko jutro, ale tu i teraz.
Wybierz kierunek lubelskie. 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 Wybierz kierunek lubelskie.
Witaj, miło Cię widzieć. Chociaż znamy się nie od dziś, myślę, że jeszcze wiele o mnie nie wiesz. Znajduję się w centrum Europy, więc szybko do mnie dotrzesz. To dzięki ostatnim zmianom w infrastrukturze drogowej, kolejowej i rozwojowi lotniczej siatki połączeń. Za granicą jest o mnie coraz głośniej. Ostatnio mówią o mnie, że jestem smart. Wdrożone rozwiązania potwierdza certyfikat ISO i liczne międzynarodowe rankingi. Jestem pewien, że znajdziemy wspólną przestrzeń. Taką, w której będziesz mógł się rozwijać. Będąc kompaktowym miastem, gwarantuje Ci atuty metropolii, jednocześnie zapewniając komfortowe warunki odpoczynku z dala od zgiełku zatłoczonego miasta. Wiem też, że wspólnie możemy się wiele nauczyć. Dzięki mnie dowiesz się, gdzie inwestować w wiedzę. Pokażę Ci, jak kwitnie współpraca biznesu, nauki i samorządu. U mnie znajdziesz miejsca, w których innowacje nabierają realnych kształtów. Przedstawię Cię osobom, które mają na to swoje patenty. Zobaczysz, jak nowe technologie sprawdzają się w praktyce. Przekonasz się, że jestem dobrą inwestycją, nie tylko jutro, ale tu i teraz. Nie czekaj. Przyszłość zaczyna się tu, w Lublinie.
Inkubator Innowacyjności 2.0 był programem finansowanym z dedykowanych środków Ministerstwa Nauki i Szkolnictwa Wyższego, a jego głównym celem było wsparcie podmiotów szkolnictwa wyższego w zakresie komercjalizacji wyników badań, w zakresie wsparcia promocji użytecznych gospodarczych wynalazków. Konsorcjum naukowe UNCS, KUL Creative i Uniwersytetu Medycznego mogło ze środków programu operacyjnego Inteligentny Rozwój sfinansować prace przedwdrożeniowe dla wynalazków opracowanych na uczelni, wzmocnić kadrę brokerów innowacji, a także sfinansować działania promocyjne dla wynalazków i ich ochronę patentową.
Dzisiejsze uczelnie mają przed sobą do spełnienia jeszcze tak zwaną trzecią misję, która polega na pogłębionej współpracy nauki z otoczeniem społeczno-gospodarczym i nasza uczelnia oczywiście tą misję stara się realizować. Żeby ją dobrze realizować, to trzeba mieć oczywiście określone struktury do realizacji. Z jednej strony mamy oczywiście w swoich strukturach Centrum Transferu Wiedzy i Technologii, a z drugiej strony od kilku lat realizujemy projekt pod nazwą Inkubator Innowacyjności. Tenże inkubator ma na celu przede wszystkim realizowanie naszych osiągnięć naukowych we współpracy z otoczeniem, z przemysłem. Chcemy, żeby te nasze osiągnięcia naukowe były po prostu wdrażane, żeby można było je aplikować do praktyki jako takiej. W wyniku działalności inkubatora mamy oczywiście określone osiągnięcia, mamy projekty do realizacji i bardzo nam zależy, żeby przedsiębiorcy z tego skorzystali. Do współpracy z inkubatorem, z naszą uczelnią serdecznie zapraszamy.
UNCS zrealizował 4 prace przedwdrożeniowe w ramach projektu z dziedzin biologii, chemii, informatyki, fizyki i zarządzania.
Inkubator Innowacyjności 2.0 pozwoli nam rozwinąć wcześniej opracowaną aplikację mobilną, która wspomaga prowadzenie badań jakościowych. Przede wszystkim tutaj chodzi o możliwość zwirtualizowania kilku rodzajów technik projekcyjnych stosowanych w wywiadach czy grupowych, czy indywidualnych. Te techniki, które opracowaliśmy, przede wszystkim przyspieszają czas prowadzenia badań jakościowych, bo na przykład technika projekcyjnej mapy percepcji, zazwyczaj wykonywana na papierze z klejem i nożyczkami, zajmowała badanemu kilka ładnych minut, a później badaczowi to już były raczej godziny na przeanalizowanie podobnych układów czy sekwencji, szczególnie w przypadku sortu. Natomiast tutaj te czynności analityczne w zasadzie mamy niejako z automatu. Dostajemy gotowy plik danych, może troszeczkę bardziej pracochłonne, szczególnie na początku jest przygotowanie takiego zadania, ale to różnica w całości czasu potrzebnego na analizę takich danych jest, my szacujemy, że jest to około 70% oszczędności tego czasu badacza, co uważamy, że jest to bardzo dużo. Jesteśmy w stanie zauważyć rosnące zainteresowanie naszą aplikacją. Testowaliśmy to z badaczami jakościowymi. Wystawiliśmy również aplikację na targach innowacji, gdzie otrzymaliśmy brązowy medal w kategorii IT.
Dzięki projektowi Inkubator Innowacyjności udało nam się stworzyć to urządzenie, które my nazwaliśmy VAXO. Jest to analizator wosku pszczelego. Nie ma czegoś takiego, prawda, czyli nawet trudno nazwać to innowacją, bo to nie jest innowacja, tylko to jest nowość. To urządzenie ma ogromny potencjał, bo można za pomocą niego zbadać jakość wosku pszczelego. Ten wosk pszczeli jest także wykorzystywany w wielu gałęziach przemysłu, w kosmetologii na przykład, w medycynie, nawet w przemyśle zbrojeniowym. Mamy kilka firm, które są zainteresowane komercjalizacją tego urządzenia.
Realizując projekt Inkubator Innowacyjności 2.0, Katolicki Uniwersytet Lubelski Jana Pawła II miał okazję przede wszystkim do wsparcia procesu zarządzania wynikami badań naukowych i prac rozwojowych. Badania prowadzone były przez naukowców Wydziału Nauk Ścisłych oraz Wydziału Nauk o Zdrowiu Katolickiego Uniwersytetu Lubelskiego Jana Pawła II. Z budżetu sfinansowano 2 prace przedwdrożeniowe. Pierwsza z nich, prowadzona przez zespół pani profesor Anny Rymuszki, dotyczyła nowego nośnika substancji bioaktywnych. Druga praca przedwdrożeniowa prowadzona była przez zespół pani dr Moniki Janeczko, dotyczyła nowego nośnika roślinnego przeciwmikrobiologicznego.
W wyniku udziału w projekcie Inkubator Innowacyjności opracowaliśmy metodę syntezy pozwalającą na uzyskanie w prosty i dość szybki sposób materiałów charakteryzujących się uporządkowanym układem porów o ściśle zdefiniowanych parametrach. Badania przeprowadzone z ibuprofenem jako standardowym lekiem pokazują, że materiał ten jest dobrym nośnikiem do uwalniania substancji aktywnych, np. w kosmetologii czy medycynie.
W ramach finansowanych badań wytworzono szereg postaci nanomateriałów i spośród kilku kandydatów udało nam się wytypować taką postać, która ma bardzo dobry profil toksykologiczny. W najbliższym czasie planowane są dalsze badania mające na celu sprawdzenie, czy wytypowany przez nas produkt sprawdzi się jako nośnik substancji stosowanych w terapii nowotworów.
Realizacja projektu Inkubator Innowacyjności 2.0 była dla nas okazją do przedstawienia oferty komercjalizacyjnej KUL na targach czy innego typu imprezach Science to Business. Wynikiem prezentacji naszego potencjału naukowego były zlecenia od podmiotów zewnętrznych zakończone podpisywaniem umów komercjalizacyjnych. Ważnym aspektem jest tutaj również to, że zostały opracowane narzędzia służące prezentacji oferty Katolickiego Uniwersytetu Lubelskiego, między innymi internetowa wyszukiwarka interdyscyplinarna, folder interdyscyplinarny czy e-wizytówki prezentujące potencjał naukowo-badawczy poszczególnych instytutów KUL.
Spółka KUL Creative powstała na Katolickim Uniwersytecie Lubelskim Jana Pawła II w celu popularyzacji alternatywnych metod komercjalizacji wiedzy. I taką komercjalizację dokonaliśmy, powołując do życia spółkę Texture w ramach Inkubatora Innowacyjności 2.0.
Kończymy okres inkubatora, który zacieśnił jeszcze bardziej współpracę między naszymi uczelniami, między Uniwersytetem Medycznym, UMCS-em i Katolickim Uniwersytetem Lubelskim. Rozwija się pomysłowość naukowców i ich innowacyjność. Świadczy to bardzo dobrze o potencjale i o zrozumieniu sytuacji, także gospodarczej, i o tym, co można wykorzystać z pracy własnej, z pracy badawczej, co można wykorzystać ewentualnie na rynku. Nasza uczelnia medyczna ma bardzo dużą specyfikę swoich propozycji. Ma także bardzo dużo patentów. Wyniki osiągnięte przez naszych naukowców w ramach inkubatora wzbudziły bardzo duże zainteresowanie przemysłu, małych i dużych przedsiębiorstw. Mamy nadzieję, że wynikami naukowców osiągniętymi w ramach inkubatora zainteresują się firmy, które są zrzeszone w klastrze Lubelska Medycyna.
Projekt Inkubator Innowacyjności 2.0 pozwolił nam na realizację 2 prac przedwdrożeniowych. Były to prace wybrane z szeregu innych zgłoszonych i wybrane przez Radę do realizacji jako najbardziej obiecujące i najbardziej wskazujące na potencjalne wdrożenia. Zespół pod kierunkiem pani profesor Anny Boguckiej-Kockiej przebadał skuteczność triazoli. Są to nowe, pochodne, nowe cząsteczki, które mogą być wykorzystane w chorobach pasożytniczych, przy zwalczaniu nicieni. Natomiast drugi zespół pod kierunkiem profesora Tomasza Baja zajmował się preparatem dotyczącym leczenia grzybic Candidus jamy ustnej. Preparat ten oparty jest na bazie olejków eterycznych z ziół, które są uprawiane również na Lubelszczyźnie.
W naszych laboratoriach Uniwersytetu Medycznego przygotowaliśmy preparat o właściwościach przeciwgrzybiczych, który może być wykorzystywany w leczeniu Candidus. Preparat ten przygotowaliśmy w 2 formulacjach. Dzięki udziałowi w Inkubatorze Innowacyjności 2.0 mogliśmy zweryfikować nasze badania laboratoryjne w badaniach in vivo.
Wyniki naszych wstępnych badań okazały się bardzo korzystne, ponieważ pokazały, że preparat farmaceutyczny stanowiący właśnie kompozycję olejków naturalnych i ekstraktu z rumianku wykazuje bardzo korzystne działanie przeciwgrzybicze, działanie grzybobójcze. W ostatnich latach spotyka się coraz więcej zakażeń o charakterze oportunistycznym, które są powodowane przez naturalne drobnoustrze nastroje stanowiące naszą mikroflorę, bytującą u zdrowych osób. Grzyby drożdżopodobne należą m.in. do takich mikroorganizmów, które zasiedlają nasz organizm i bytują mniej więcej u około nawet 60% zdrowej populacji w obrębie błon śluzowych jamy ustnej.
Wyniki obu prac przedwdrożeniowych pozwoliły nam również w końcowej fazie realizacji tych prac na analizę potencjału komercjalizacyjnego, na ocenę skuteczności tych działań w kontekście zapotrzebowania rynku poprzez zlecenie wycen, strategii komercjalizacji, które dały nam pogląd, co mamy robić dalej, jakie jest zapotrzebowanie rynku, jakie są kolejne kroki, które możemy dalej podjąć. Kolejne nasze działania to katalog własności intelektualnej. Dzięki projektowi mamy portfolio, które wskazuje, jakie patenty, jakie zgłoszenia patentowe możemy zaoferować do potencjalnego licencjonowania, do sprzedaży, a także do innych działań. Wisienką na torcie i podsumowaniem naszych działań, a także miarą naszego sukcesu było pojawienie się po raz pierwszy Uniwersytetu Medycznego z wynalazkami na targach INTARG, targach innowacji i wynalazków, i sukces w postaci 4 medali, a także nagrody specjalnej, z czego 2 to są medale za wynalazki i za patenty, które były objęte pracami przedwdrożeniowymi w Inkubatorze Innowacyjności 2.0.
Podsumowując 19 miesięcy realizacji projektu Inkubator Innowacyjności, widzimy, że potencjał lubelskich uczelni jest bardzo duży. Badania naukowe i prace rozwojowe prowadzone na uczelniach mają duży wkład w rozwój gospodarki. Przedsiębiorcy współpracujący z nami są zainteresowani dalszymi działaniami, kolejnymi projektami. Takie działania jak Inkubator Innowacyjności pozwalają nam na integrację środowiska, na współpracę pomiędzy jednostkami, a także na zawiązanie szerokich kontaktów społeczno-gospodarczych.
Politechnika Lubelska co roku zajmuje bardzo wysokie miejsca w rankingach innowacyjnych uczelni. Także w tym roku w rankingu perspektyw zajęliśmy bardzo wysoką pozycję zarówno w kategorii uczelni innowacyjnych, ale także pierwsze miejsce w kategorii ilości praw ochronnych oraz patentów zgłoszonych przez ośrodki akademickie w Polsce. Jednak nasza działalność to nie tylko zgłaszanie rozwiązań do ochrony w Urzędzie Patentowym, ale także, a może przede wszystkim wdrażanie ich w przedsiębiorstwach. Taką działalność prowadzi Centrum Innowacji i Transferu Technologii, które od lat już prowadzi program Inkubator Innowacyjności. W ramach tego programu opracowujemy rozwiązania, które następnie są wdrażane w firmach. W ostatnim czasie zakończyliśmy program Inkubator Innowacyjności 2.0. W ramach tego programu przeprowadziliśmy 8 prac przedwdrożeniowych, z których najciekawsze zobaczycie Państwo w tym materiale. Rozwiązania te bardzo często są przygotowywane na potrzeby konkretnych przedsiębiorstw, a więc można się domyślić, że po zakończeniu prac przedwdrożeniowych trafiają one właśnie do tych firm, które następnie ze wsparciem naszych naukowców uzyskują wymierne efekty finansowe z tego, że stają się bardziej innowacyjne, mają lepsze produkty. Dzięki temu też możemy mieć lepszą współpracę zarówno ze strony naukowców, którzy w firmach tych znajdują zastosowanie swoich rozwiązań, jak również od strony przedsiębiorstw, które cieszą się z tego, że ich produkty mogą konkurować, mogą być bardziej konkurencyjne na rynku, a co za tym idzie, mogą zapewniać sobie dobrą pozycję konkurencyjną. Podczas konferencji Innowacje w praktyce prezentujemy co roku w zasadzie już najciekawsze rozwiązania, z którymi mogą się zapoznać uczestnicy tej konferencji. Pan profesor Tomasz Klepka zaprasza nas jako Centrum Innowacji i Transferu Technologii do tego, aby najciekawsze rozwiązania, którymi chcemy zainteresować przedsiębiorców, mogły być właśnie tam zaprezentowane. Podczas panelowych spotkań dyskusyjnych Polskiej Akademii Nauk oraz konferencji Innowacje w praktyce prezentujemy co roku najciekawsze rozwiązania opracowane w Politechnice Lubelskiej. Cieszymy się, że jest to okazja do tego, aby przedsiębiorcy mogli zapoznać się z rozwiązaniami, które następnie będziemy chcieli wdrażać w ich przedsiębiorstwach.
Jestem doktor inżynier Przemysław Filipek, pracuję w Katedrze Podstaw Konstrukcji Maszyn i Mechatroniki na Wydziale Mechanicznym Politechniki Lubelskiej. Przedstawiony tutaj sprzęt jest rowerem elektrycznym z zastosowaniem nowatorskiej konstrukcji silnika elektrycznego patentowanego na Politechnice Lubelskiej. Jest to silnik bezszczotkowy, zbudowany z magnesów trwałych oraz uzwojenia. No i do tego wszystkiego sterownik. Silnik nazywa się LMB. W tylnym kole rowerowym zastosowano w rotorze 36 magnesów po obu stronach, czyli w sumie łącznie 72 magnesy stałe. Stator jest elementem wykonanym ze sklejki, odpowiednio wyfrezowanej. W tych rowkach znajduje się uzwojenie i to uzwojenie współpracuje z rotorem, z magnesami trwałymi. z magnesami trwałymi. Z magnesami trwałymi.
Inkubator Innowacyjności 2.0 był programem finansowanym z dedykowanych środków Ministerstwa Nauki i Szkolnictwa Wyższego, a jego głównym celem było wsparcie podmiotów szkolnictwa wyższego w zakresie komercjalizacji wyników badań, w zakresie wsparcia promocji użytecznych gospodarczych wynalazków. Konsorcjum naukowe UMCS, KUL Creative i Uniwersytetu Medycznego mogło ze środków programu operacyjnego Inteligentny Rozwój sfinansować prace przedwdrożeniowe dla wynalazków opracowanych na uczelni, wzmocnić kadrę brokerów innowacji, a także sfinansować działania promocyjne dla wynalazków i ich ochronę patentową.
Dzisiejsze uczelnie mają przed sobą do spełnienia jeszcze tak zwaną trzecią misję, która polega na pogłębionej współpracy nauki z otoczeniem społeczno-gospodarczym i nasza uczelnia oczywiście tą misję stara się realizować. Żeby ją dobrze realizować, to trzeba mieć oczywiście określone struktury do realizacji. Z jednej strony mamy oczywiście w swoich strukturach Centrum Transferu Wiedzy i Technologii, a z drugiej strony od kilku lat realizujemy projekt pod nazwą Inkubator Innowacyjności. Tenże inkubator ma na celu przede wszystkim realizowanie naszych osiągnięć naukowych we współpracy z otoczeniem, z przemysłem. Chcemy, żeby te nasze osiągnięcia naukowe były po prostu wdrażane, żeby można było je aplikować do praktyki jako takiej. W wyniku działalności inkubatora mamy oczywiście określone osiągnięcia, mamy projekty do realizacji i bardzo nam zależy, żeby przedsiębiorcy z tego skorzystali. Do współpracy z inkubatorem, z naszą uczelnią serdecznie zapraszamy.
UMCS zrealizował 4 prace przedwdrożeniowe w ramach projektu z dziedzin biologii, chemii, informatyki, fizyki i zarządzania.
Inkubator Innowacyjności 2.0 pozwoli nam rozwinąć wcześniej opracowaną aplikację mobilną, która wspomaga prowadzenie badań jakościowych. Przede wszystkim tutaj chodzi o możliwość zwirtualizowania kilku rodzajów technik projekcyjnych stosowanych w wywiadach czy grupowych, czy indywidualnych. Te techniki, które opracowaliśmy, przede wszystkim przyspieszają czas prowadzenia badań jakościowych, bo na przykład technika projekcyjnej mapy percepcji, zazwyczaj wykonywana na papierze z klejem i nożyczkami, zajmowała badanemu kilka ładnych minut, a później badaczowi no to już były raczej godziny na przeanalizowanie podobnych układów czy sekwencji, szczególnie w przypadku sortu. Natomiast tutaj te czynności analityczne w zasadzie mamy niejako z automatu. Dostajemy gotowy plik danych, no może troszeczkę bardziej pracochłonne, szczególnie na początku jest przygotowanie takiego zadania, ale to różnica w całości czasu potrzebnego na analizę takich danych jest, no my szacujemy, że jest to około 70% oszczędności tego czasu badacza, co uważamy, że jest to bardzo dużo. Jesteśmy w stanie zauważyć rosnące zainteresowanie naszą aplikacją. Testowaliśmy to z badaczami jakościowymi. Wystawiliśmy również aplikację na targach innowacji, gdzie otrzymaliśmy brązowy medal w kategorii IT.
Dzięki projektowi Inkubator Innowacyjności udało nam się stworzyć to urządzenie, które my nazwaliśmy VII. Jest to analizator wosku pszczelego. Nie ma czegoś takiego, prawda, czyli nawet trudno nazwać to innowacją, bo to nie jest innowacja, tylko to jest nowość. To urządzenie ma ogromny potencjał, bo można za pomocą niego zbadać jakość wosku pszczelego. Ten wosk pszczeli jest także wykorzystywany w wielu gałęziach przemysłu, w kosmetologii na przykład, medycynie, nawet w przemyśle zbrojeniowym. Mamy kilka firm, które są zainteresowane komercjalizacją tego urządzenia.
Realizując projekt Inkubator Innowacyjności 2.0, Katolicki Uniwersytet Lubelski Jana Pawła II miał okazję przede wszystkim do wsparcia procesu zarządzania wynikami badań naukowych i prac rozwojowych. Badania prowadzone były przez naukowców Wydziału Nauk Ścisłych oraz Wydziału Nauk o Zdrowiu Katolickiego Uniwersytetu Lubelskiego Jana Pawła II. Z budżetu sfinansowano 2 prace przedwdrożeniowe. Pierwsza z nich, prowadzona przez zespół pani profesor Anny Rymuszki, dotyczyła nowego nośnika substancji bioaktywnych. Druga praca przedwdrożeniowa, prowadzona była przez zespół pani dr Moniki Janeczko, dotyczyła nowego nośnika roślinnego przeciwmikrobiologicznego.
W wyniku udziału w projekcie Inkubator Innowacyjności opracowaliśmy metodę syntezy pozwalającą na uzyskanie w prosty i dość szybki sposób materiałów charakteryzujących się uporządkowanym układem porów o ściśle zdefiniowanych parametrach. Badania przeprowadzone z ibuprofenem jako standardowym lekiem pokazują, że materiał ten jest dobrym nośnikiem do uwalniania substancji aktywnych, np. w kosmetologii czy medycynie.
W ramach finansowanych badań wytworzono szereg postaci nanomateriałów i spośród kilku kandydatów udało nam się wytypować taką postać, która ma bardzo dobry profil toksykologiczny. W najbliższym czasie planowane są dalsze badania mające na celu sprawdzenie, czy wytypowany przez nas produkt sprawdzi się jako nośnik substancji stosowanych w terapii nowotworów.
Realizacja projektu Inkubator Innowacyjności 2.0 była dla nas okazją do przedstawienia oferty komercjalizacyjnej KUL na targach czy innego typu imprezach Science to Business. Wynikiem prezentacji naszego potencjału naukowego były zlecenia od podmiotów zewnętrznych zakończone podpisywaniem umów komercjalizacyjnych. Ważnym aspektem jest tutaj również to, że zostały opracowane narzędzia służące prezentacji oferty Katolickiego Uniwersytetu Lubelskiego, między innymi internetowa wyszukiwarka interdyscyplinarna, folder interdyscyplinarny czy e-wizytówki prezentujące potencjał naukowo-badawczy poszczególnych instytutów KUL.
Spółka KUL Creative powstała na Katolickim Uniwersytecie Lubelskim Jana Pawła II w celu popularyzacji alternatywnych metod komercjalizacji wiedzy. I taką komercjalizację dokonaliśmy, powołując do życia spółkę Texture w ramach Inkubatora Innowacyjności 2.0.
Kończymy okres inkubatora, który zacieśnił jeszcze bardziej współpracę między naszymi uczelniami, między Uniwersytetem Medycznym, UMCS-em i Katolickim Uniwersytetem Lubelskim. Rozwija się pomysłowość naukowców i ich innowacyjność. Świadczy to bardzo dobrze o potencjale i o zrozumieniu sytuacji, także gospodarczej, i o tym, co można wykorzystać z pracy własnej, z pracy badawczej, co można wykorzystać ewentualnie na rynku. Nasza uczelnia medyczna ma bardzo dużą specyfikę swoich propozycji. Ma także bardzo dużo patentów. Wyniki osiągnięte przez naszych naukowców w ramach inkubatora wzbudziły bardzo duże zainteresowanie przemysłu, małych i dużych przedsiębiorstw. Mamy nadzieję, że wynikami naukowców osiągniętymi w ramach inkubatora zainteresują się firmy, które są zrzeszone w klastrze Lubelska Medycyna.
Projekt Inkubator Innowacyjności 2.0 pozwolił nam na realizację 2 prac przedwdrożeniowych. Były to prace wybrane z szeregu innych zgłoszonych i wybrane przez Radę do realizacji jako najbardziej obiecujące i najbardziej wskazujące na potencjalne wdrożenia. Zespół pod kierunkiem pani profesor Anny Boguckiej-Kockiej przebadał skuteczność triazoli. Są to nowe, pochodne, nowe cząsteczki, które mogą być wykorzystane w chorobach pasożytniczych, przy zwalczaniu nicieni. Natomiast drugi zespół pod kierunkiem profesora Tomasza Baja zajmował się preparatem dotyczącym leczenia grzybic Candidus jamy ustnej. Preparat ten oparty jest na bazie olejków eterycznych z ziół, które są uprawiane również na Lubelszczyźnie.
W naszych laboratoriach Uniwersytetu Medycznego przygotowaliśmy preparat o właściwościach przeciwgrzybiczych, który może być wykorzystywany w leczeniu Candidus. Preparat ten przygotowaliśmy w 2 formulacjach. Dzięki udziałowi w Inkubatorze Innowacyjności 2.0 mogliśmy zweryfikować nasze badania laboratoryjne w badaniach in vivo.
Wyniki naszych wstępnych badań okazały się bardzo korzystne, ponieważ pokazały, że preparat farmaceutyczny stanowiący właśnie kompozycję olejków naturalnych i ekstraktu z rumianku wykazuje bardzo korzystne działanie przeciwgrzybicze, działanie grzybobójcze. W ostatnich latach spotyka się coraz więcej zakażeń o charakterze oportunistycznym, które są powodowane przez naturalne drobnoustroje stanowiące naszą mikroflorę, bytującą u zdrowych osób. Grzyby drożdżopodobne należą m.in. do takich mikroorganizmów, które zasiedlają nasz organizm i bytują mniej więcej u około nawet 60% zdrowej populacji w obrębie błon śluzowych jamy ustnej.
Wyniki obu prac przedwdrożeniowych pozwoliły nam również w końcowej fazie realizacji tych prac na analizę potencjału komercjalizacyjnego, na ocenę skuteczności tych działań w kontekście zapotrzebowania rynku poprzez zlecenie wycen, strategii komercjalizacji, które dały nam pogląd, co mamy robić dalej, jakie jest zapotrzebowanie rynku, jakie są kolejne kroki, które możemy dalej podjąć. Kolejne nasze działania to katalog własności intelektualnej. Dzięki projektowi mamy portfolio, które wskazuje, jakie patenty, jakie zgłoszenia patentowe możemy zaoferować do potencjalnego licencjonowania, do sprzedaży, a także do innych działań. Wisienką na torcie i podsumowaniem naszych działań, a także miarą naszego sukcesu było pojawienie się po raz pierwszy Uniwersytetu Medycznego z wynalazkami na targach INTARG, targach innowacji i wynalazków, i sukces w postaci 4 medali, a także nagrody specjalnej, z czego 2 to są medale za wynalazki i za patenty, które były objęte pracami przedwdrożeniowymi w Inkubatorze Innowacyjności 2.0.
Podsumowując 19 miesięcy realizacji projektu Inkubator Innowacyjności, widzimy, że potencjał lubelskich uczelni jest bardzo duży. Badania naukowe i prace rozwojowe prowadzone na uczelniach mają duży wkład w rozwój gospodarki. Przedsiębiorcy współpracujący z nami są zainteresowani dalszymi działaniami, kolejnymi projektami. Takie działania jak Inkubator Innowacyjności pozwalają nam na integrację środowiska, na współpracę pomiędzy jednostkami, a także na zawiązanie szerokich kontaktów społeczno-gospodarczych.
Politechnika Lubelska co roku zajmuje bardzo wysokie miejsca w rankingach innowacyjnych uczelni. Także w tym roku w rankingu perspektyw zajęliśmy bardzo wysoką pozycję zarówno w kategorii uczelni innowacyjnych, ale także pierwsze miejsce w kategorii ilości praw ochronnych oraz patentów zgłoszonych przez ośrodki akademickie w Polsce. Jednak nasza działalność to nie tylko zgłaszanie rozwiązań do ochrony w Urzędzie Patentowym, ale także, a może przede wszystkim wdrażanie ich w przedsiębiorstwach. Taką działalność prowadzi Centrum Innowacji i Transferu Technologii, które od lat już prowadzi program Inkubator Innowacyjności. W ramach tego programu opracowujemy rozwiązania, które następnie są wdrażane w firmach. W ostatnim czasie zakończyliśmy program Inkubator Innowacyjności 2.0. W ramach tego programu przeprowadziliśmy 8 prac przedwdrożeniowych, z których najciekawsze zobaczycie Państwo w tym materiale. Rozwiązania te bardzo często są przygotowywane na potrzeby konkretnych przedsiębiorstw, a więc można się domyślić, że po zakończeniu prac przedwdrożeniowych trafiają one właśnie do tych firm, które następnie ze wsparciem naszych naukowców uzyskują wymierne efekty finansowe z tego, że stają się bardziej innowacyjne, mają lepsze produkty. Dzięki temu też możemy mieć lepszą współpracę zarówno ze strony naukowców, którzy w firmach tych znajdują zastosowanie swoich rozwiązań, jak również od strony przedsiębiorstw, które cieszą się z tego, że ich produkty mogą konkurować, mogą być bardziej konkurencyjne na rynku, a co za tym idzie, mogą zapewniać sobie dobrą pozycję konkurencyjną. Podczas konferencji Innowacje w praktyce prezentujemy co roku w zasadzie już najciekawsze rozwiązania, z którymi mogą się zapoznać uczestnicy tej konferencji. Pan profesor Tomasz Klepka zaprasza nas jako Centrum Innowacji i Transferu Technologii do tego, aby najciekawsze rozwiązania, którymi chcemy zainteresować przedsiębiorców, mogły być właśnie tam zaprezentowane. Podczas panelowych spotkań dyskusyjnych Polskiej Akademii Nauk oraz konferencji Innowacje w praktyce prezentujemy co roku najciekawsze rozwiązania opracowane w Politechnice Lubelskiej. Cieszymy się, że jest to okazja do tego, aby przedsiębiorcy mogli zapoznać się z rozwiązaniami, które następnie będziemy chcieli wdrażać w ich przedsiębiorstwach.
Jestem doktor inżynier Przemysław Filipek, pracuję w Katedrze Podstaw Konstrukcji Maszyn i Mekatroniki na Wydziale Mechanicznym Politechniki Lubelskiej. Przedstawiony tutaj sprzęt jest rowerem elektrycznym z zastosowaniem nowatorskiej konstrukcji silnika elektrycznego patentowanego na Politechnice Lubelskiej. Jest to silnik bezszczotkowy, zbudowany z magnesów trwałych oraz uzwojenia. No i do tego wszystkiego sterownik. Silnik nazywa się LMB. W tylnym kole rowerowym zastosowano w rotorze 36 magnesów po obu stronach, czyli w sumie łącznie 72 magnesy stałe. Stator jest elementem wykonanym ze sklejki, odpowiednio wyfrezowana i w tych rowkach znajduje się uzwojenie. I to uzwojenie współpracuje z rotorem, z magnesami trwałymi. Z magnesami trwałymi. Z magnesami trwałymi. Z magnesami trwałymi.
Technologia skanowania 3D jest technologią, która w ostatnich latach dosyć prężnie i dynamicznie się rozwija. Obecnie jest coraz częściej wykorzystywana w różnych branżach i dyscyplinach, jak również bardzo często stosowana jest w życiu codziennym. Za jej pomocą w szybki sposób możemy przenieść obiekt rzeczywisty do świata cyfrowego. Następnie ten obiekt w świecie cyfrowym można poddać dalszym modyfikacjom poprzez wykorzystanie odpowiednich programów komputerowych. Technologia skanowania 3D znalazła zastosowanie między innymi w medycynie, kryminalistyce, motoryzacji, lotnictwie, grafice komputerowej, produkcji firmowej, archeologii i muzealnictwie. Skanowanie 3D obiektów muzealnych pozwala na ich publikację w internecie, dostęp do nich z dowolnego miejsca na świecie. Technika ta umożliwia dokładne obejrzenie eksponatu z każdej strony, jego ocenę, jak również ocenę najdrobniejszych szczegółów i detali. Technologia skanowania 3D jest najczęściej wykorzystywana do realizacji takich zagadnień jak pomiar geometrii, objętości i pola powierzchni obiektów rzeczywistych, wzornictwo, inżynieria odwrotna, kontrola jakości, testy i symulacje, bezdotykowa inspekcja, kontrola zużycia, digitalizacja obiektów, archiwizacja zbiorów czy też tworzenie wirtualnych muzeów. Proces skanowania 3D realizowany jest za pomocą skanerów 3D. Skanery 3D są to urządzenia, które umożliwiają analizę obiektów i przedmiotów rzeczywistych o małych rozmiarach, jak również dużych obiektów i otwartych przestrzeni, takich jak na przykład ulice, parki, obiekty architektoniczne lub miejsca wykopalisk archeologicznych. Mogą to być kilku milionów. a nawet kilkunastu metrów. Skanery 3D pozwalają na odwzorowanie rzeczywistych obiektów przy zachowaniu ich kształtu, wymiarów, jak również pozwalają na zachowanie ich kolorystyki. W skanerach 3D stosuje się różne rozwiązania technologiczne. Jednak najczęściej wykorzystywanymi skanerami są skanery bezdotykowe. Są to urządzenia, które oparte są na technologii optoelektronicznej, czyli na technologii, która wykorzystuje właściwości światła w celu zgromadzenia, w celu transferu i prezentacji informacji. W naszej katedrze, czyli w Katedrze Informatyki, posiadamy 4 tego typu skanery. 2 z nich wykorzystuje światło strukturalne, natomiast 2 są to skanery laserowe. Jednym ze skanerów jest laserowy skaner o nazwie Farofocus 3D. Skaner Farofocus 3D jest to skaner, który umożliwia skanowanie zarówno wewnątrz, jak i na zewnątrz budynków. Jest to mobilne urządzenie, które pozwala na szybkie, łatwe i precyzyjne pomiary budynków, pomieszczeń, dużych obiektów, wykopalisk archeologicznych, złożonych konstrukcji, a nawet miejsc wypadków i przestępstw. Skaner ten może być wykorzystywany między innymi do tworzenia dokumentacji stanu i geometrii, sporządzenia archiwizacji przedmiotów i tworzenia ich wiernych kopii, na przykład poprzez tworzenie wydruków 3D, do inwentaryzacji, wykonywania modeli 3D, tworzenia wirtualnych spacerów i zdjęć panoramicznych 360, jak również do opracowywania wirtualnego muzeum w technologii 3D. Skaner ten pozwala na tworzenie pełnej i wiernej w szczegółach dokumentacji obiektów historycznych lub wykopalisk archeologicznych. Jest to bardzo istotne w celu przeprowadzenia np. renowacji, analizy naukowej, zabezpieczenia budynków lub wirtualnej prezentacji miejsc historycznych, do których nie mają dostępu osoby zwiedzające. Dzięki wbudowanemu kolorowemu aparatowi fotograficznemu można bezpośrednio generować fotorealistyczne wizualizacje 3D. Wbudowany aparat HDR zapewnia pełną dokumentację w najwyższej jakości. Jest to szczególnie przydatna funkcja w przypadku, gdy musimy nadać skanom odpowiedni kolor przy trudnych warunkach oświetleniowych.
designed to work perfectly. IKA German Technology.
Witaj, miło Cię widzieć. Chociaż znamy się nie od dziś, myślę, że jeszcze wiele o mnie nie wiesz. Znajduję się w centrum Europy, więc szybko do mnie dotrzesz. To dzięki ostatnim zmianom w infrastrukturze drogowej, kolejowej i rozwojowi lotniczej siatki połączeń. Za granicą jest o mnie coraz głośniej. Ostatnio mówią o mnie, że jestem smart. Wdrożone rozwiązania potwierdza certyfikat ISO i liczne międzynarodowe rankingi. Jestem pewien, że znajdziemy wspólną przestrzeń. Taką, w której będziesz mógł się rozwijać. Będąc kompaktowym miastem, gwarantuje Ci atuty metropolii, jednocześnie zapewniając komfortowe warunki odpoczynku z dala od zgiełku zatłoczonego miasta. Wiem też, że wspólnie możemy się wiele nauczyć. Dzięki mnie dowiesz się, gdzie inwestować w wiedzę. Pokażę Ci, jak kwitnie współpraca biznesu, nauki i samorządu. U mnie znajdziesz miejsca, w których innowacje nabierają realnych kształtów. Przedstawię Cię osobom, które mają na to swoje patenty. Zobaczysz, jak nowe technologie sprawdzają się w praktyce. Przekonasz się, że jestem dobrą inwestycją, nie tylko jutro, ale tu i teraz. Nie czekaj. Przyszłość zaczyna się tu, w Lublinie.
Wybierz kierunek lubelskie. 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 Wybierz kierunek lubelskie.
Witaj, miło Cię widzieć. Chociaż znamy się nie od dziś, myślę, że jeszcze wiele o mnie nie wiesz. Znajduję się w centrum Europy, więc szybko do mnie dotrzesz. To dzięki ostatnim zmianom w infrastrukturze drogowej, kolejowej i rozwojowi lotniczej siatki połączeń. Za granicą jest o mnie coraz głośniej. Ostatnio mówią o mnie, że jestem smart. Wdrożone rozwiązania potwierdza certyfikat ISO i liczne międzynarodowe rankingi. Jestem pewien, że znajdziemy wspólną przestrzeń. Taką, w której będziesz mógł się rozwijać. Będąc kompaktowym miastem, gwarantuje Ci atuty metropolii, jednocześnie zapewniając komfortowe warunki odpoczynku z dala od zgiełku zatłoczonego miasta. Wiem też, że wspólnie możemy się wiele nauczyć. Dzięki mnie dowiesz się, gdzie inwestować w wiedzę. Pokażę Ci, jak kwitnie współpraca biznesu, nauki i samorządu. U mnie znajdziesz miejsca, w których innowacje nabierają realnych kształtów. Przedstawię Cię osobom, które mają na to swoje patenty. Zobaczysz, jak nowe technologie sprawdzają się w praktyce. Przekonasz się, że jestem dobrą inwestycją, nie tylko jutro, ale tu i teraz. Nie czekaj. Przyszłość zaczyna się tu, w Lublinie.
Inkubator Innowacyjności 2.0 był programem finansowanym z dedykowanych środków Ministerstwa Nauki i Szkolnictwa Wyższego, a jego głównym celem było wsparcie podmiotów szkolnictwa wyższego w zakresie komercjalizacji wyników badań, w zakresie wsparcia promocji użytecznych gospodarczych wynalazków. Konsorcjum naukowe UMCS, KUL Creative i Uniwersytetu Medycznego mogło ze środków programu operacyjnego Inteligentny Rozwój sfinansować prace przedwdrożeniowe dla wynalazków opracowanych na uczelni, wzmocnić kadrę brokerów innowacji, a także sfinansować działania promocyjne dla wynalazków i ich ochronę patentową.
Dzisiejsze uczelnie mają przed sobą do spełnienia jeszcze tak zwaną trzecią misję, która polega na pogłębionej współpracy nauki z otoczeniem społeczno-gospodarczym i nasza uczelnia oczywiście tą misję stara się realizować. Żeby ją dobrze realizować, to trzeba mieć oczywiście określone struktury do realizacji. Z jednej strony mamy oczywiście w swoich strukturach Centrum Transferu Wiedzy i Technologii, a z drugiej strony od kilku lat realizujemy projekt pod nazwą Inkubator Innowacyjności. Tenże inkubator ma na celu przede wszystkim realizowanie naszych osiągnięć naukowych we współpracy z otoczeniem, z przemysłem. Chcemy, żeby te nasze osiągnięcia naukowe były po prostu wdrażane, żeby można było je aplikować do praktyki jako takiej. W wyniku działalności inkubatora mamy oczywiście określone osiągnięcia, mamy projekty do realizacji i bardzo nam zależy, żeby przedsiębiorcy z tego skorzystali. Do współpracy z inkubatorem, z naszą uczelnią serdecznie zapraszamy.
UMCS zrealizował 4 prace przedwdrożeniowe w ramach projektu z dziedzin biologii, chemii, informatyki, fizyki i zarządzania.
Inkubator Innowacyjności 2.0 pozwoli nam rozwinąć wcześniej opracowaną aplikację mobilną, która wspomaga prowadzenie badań jakościowych. Przede wszystkim tutaj chodzi o możliwość zwirtualizowania kilku rodzajów technik projekcyjnych stosowanych w wywiadach czy grupowych, czy indywidualnych. Te techniki, które opracowaliśmy, przede wszystkim przyspieszają czas prowadzenia badań jakościowych, bo na przykład technika projekcyjnej mapy percepcji, zazwyczaj wykonywana na papierze z klejem i nożyczkami, zajmowała badanemu kilka ładnych minut, a później badaczowi no to już były raczej godziny na przeanalizowanie podobnych układów czy sekwencji, szczególnie w przypadku sortu. Natomiast tutaj te czynności analityczne w zasadzie mamy niejako z automatu. Dostajemy gotowy plik danych, no może troszeczkę bardziej pracochłonne, szczególnie na początku jest przygotowanie takiego zadania, ale to różnica w całości czasu potrzebnego na analizę takich danych jest, no my szacujemy, że jest to około 70% oszczędności tego czasu badacza, co uważamy, że jest to bardzo dużo. Jesteśmy w stanie zauważyć rosnące zainteresowanie naszą aplikacją. Testowaliśmy to z badaczami jakościowymi. Wystawiliśmy również aplikację na targach innowacji, gdzie otrzymaliśmy brązowy medal w kategorii IT.
Dzięki projektowi Inkubator Innowacyjności udało nam się stworzyć to urządzenie, które my nazwaliśmy VII. Jest to analizator wosku pszczelego. Nie ma czegoś takiego, prawda, czyli nawet trudno nazwać to innowacją, bo to nie jest innowacja, tylko to jest nowość. To urządzenie ma ogromny potencjał, bo można za pomocą niego zbadać jakość wosku pszczelego. Ten wosk pszczeli jest także wykorzystywany w wielu gałęziach przemysłu, w kosmetologii, na przykład medycynie, nawet w przemyśle zbrojeniowym. Mamy kilka firm, które są zainteresowane komercjalizacją tego urządzenia.
Realizując projekt Inkubator Innowacyjności 2.0, Katolicki Uniwersytet Lubelski Jana Pawła II miał okazję przede wszystkim do wsparcia procesu zarządzania wynikami badań naukowych i prac rozwojowych. Badania prowadzone były przez naukowców Wydziału Nauk Ścisłych oraz Wydziału Nauk o Zdrowiu Katolickiego Uniwersytetu Lubelskiego Jana Pawła II. Z budżetu sfinansowano 2 prace przedwdrożeniowe. Pierwsza z nich, prowadzona przez zespół pani profesor Anny Rymuszki, dotyczyła nowego nośnika substancji bioaktywnych. Druga praca przedwdrożeniowa prowadzona była przez zespół pani dr Moniki Janeczko, dotyczyła nowego nośnika roślinnego przeciwmikrobiologicznego.
W wyniku udziału w projekcie Inkubator Innowacyjności opracowaliśmy metodę syntezy pozwalającą na uzyskanie w prosty i dość szybki sposób materiałów charakteryzujących się uporządkowanym układem porów o ściśle zdefiniowanych parametrach. Badania przeprowadzone z ibuprofenem jako standardowym lekiem pokazują, że materiał ten jest dobrym nośnikiem do uwalniania substancji aktywnych, np. w kosmetologii czy medycynie.
W ramach finansowanych badań wytworzono szereg postaci nanomateriałów i spośród kilku kandydatów udało nam się wytypować taką postać, która ma bardzo dobry profil toksykologiczny. W najbliższym czasie planowane są dalsze badania mające na celu sprawdzenie, czy wytypowany przez nas produkt sprawdzi się jako nośnik substancji stosowanych w terapii nowotworów.
Realizacja projektu Inkubator Innowacyjności 2.0 była dla nas okazją do przedstawienia oferty komercjalizacyjnej KUL na targach czy innego typu imprezach Science to Business. Wynikiem prezentacji naszego potencjału naukowego były zlecenia od podmiotów zewnętrznych zakończone podpisywaniem umów komercjalizacyjnych. Ważnym aspektem jest tutaj również to, że zostały opracowane narzędzia służące prezentacji oferty Katolickiego Uniwersytetu Lubelskiego, między innymi internetowa wyszukiwarka interdyscyplinarna, folder interdyscyplinarny czy e-wizytówki prezentujące potencjał naukowo-badawczy poszczególnych instytutów KUL.
Spółka KUL Creative powstała na Katolickim Uniwersytecie Lubelskim Jana Pawła II w celu popularyzacji alternatywnych metod komercjalizacji wiedzy. I taką komercjalizację dokonaliśmy, powołując do życia spółkę Texture w ramach Inkubatora Innowacyjności 2.0.
Kończymy okres inkubatora, który zacieśnił jeszcze bardziej współpracę między naszymi uczelniami, między Uniwersytetem Medycznym, UMCS-em i Katolickim Uniwersytetem Lubelskim. Rozwija się pomysłowość naukowców i ich innowacyjność. Świadczy to bardzo dobrze o potencjale i o zrozumieniu sytuacji, także gospodarczej, i o tym, co można wykorzystać z pracy własnej, z pracy badawczej, co można wykorzystać ewentualnie na rynku. Nasza uczelnia medyczna ma bardzo dużą specyfikę swoich propozycji. Ma także bardzo dużo patentów. Wyniki osiągnięte przez naszych naukowców w ramach inkubatora wzbudziły bardzo duże zainteresowanie przemysłu, małych i dużych przedsiębiorstw. Mamy nadzieję, że wynikami naukowców osiągniętymi w ramach inkubatora zainteresują się firmy, które są zrzeszone w klastrze Lubelska Medycyna.
Projekt Inkubator Innowacyjności 2.0 pozwolił nam na realizację 2 prac przedwdrożeniowych. Były to prace wybrane z szeregu innych zgłoszonych i wybrane przez Radę do realizacji jako najbardziej obiecujące i najbardziej wskazujące na potencjalne wdrożenia. Zespół pod kierunkiem pani profesor Anny Boguckiej-Kockiej przebadał skuteczność triazoli. Są to nowe, pochodne, nowe cząsteczki, które mogą być wykorzystane w chorobach pasożytniczych przy zwalczaniu nicieni. Natomiast drugi zespół pod kierunkiem profesora Tomasza Baja zajmował się preparatem dotyczącym leczenia grzybic Candidus jamy ustnej. Preparat ten oparty jest na bazie olejków eterycznych z ziół, które są uprawiane również na Lubelszczyźnie.
W naszych laboratoriach Uniwersytetu Medycznego przygotowaliśmy preparat o właściwościach przeciwgrzybiczych, który może być wykorzystywany w leczeniu Candidus. Preparat ten przygotowaliśmy w 2 formulacjach. Dzięki udziałowi w inkubatorze innowacyjności 2.0 mogliśmy zweryfikować nasze badania laboratoryjne w badaniach in vivo.
Wyniki naszych wstępnych badań okazały się bardzo korzystne, ponieważ pokazały, że preparat farmaceutyczny stanowiący właśnie kompozycję olejków naturalnych i ekstraktu z rumianku wykazuje bardzo korzystne działanie przeciwgrzybicze, działanie grzybobójcze. W ostatnich latach spotyka się coraz więcej zakażeń o charakterze oportunistycznym, które są powodowane przez naturalne drobnoustroje stanowiące naszą mikroflorę, bytującą u zdrowych osób. Grzyby drożdżopodobne należą m.in. do takich mikroorganizmów, które zasiedlają nasz organizm i bytują mniej więcej u około nawet 60% zdrowej populacji w obrębie błąd śluzowych jamy ustnej.
Wyniki obu prac przedwdrożeniowych pozwoliły nam również w końcowej fazie realizacji tych prac na analizę potencjału komercjalizacyjnego, na ocenę skuteczności tych działań w kontekście zapotrzebowania rynku, poprzez zlecenie wycen, strategii komercjalizacji, które dały nam pogląd, co mamy robić dalej, jakie jest zapotrzebowanie rynku, jakie są kolejne kroki, które możemy dalej podjąć. Kolejne nasze działania to katalog. Katalog własności intelektualnej. Dzięki projektowi mamy portfolio, które wskazuje, jakie patenty, jakie zgłoszenia patentowe możemy zaoferować do potencjalnego licencjonowania, do sprzedaży, a także do innych działań. Wisienką na torcie i podsumowaniem naszych działań, a także miarą naszego sukcesu było pojawienie się po raz pierwszy Uniwersytetu Medycznego z wynalazkami na targach INTARG, targach innowacji i wynalazków, i sukces w postaci 4 medali, a także nagrody specjalnej, z czego 2 to są medale za wynalazki i za patenty, które były objęte pracami przedwdrożeniowymi w inkubatorze innowacyjności 2.0.
Podsumowując 19 miesięcy realizacji projektu Inkubator Innowacyjności, widzimy, że potencjał lubelskich uczelni jest bardzo duży. Badania naukowe i prace rozwojowe prowadzone na uczelniach mają duży wkład w rozwój gospodarki. Przedsiębiorcy współpracujący z nami są zainteresowani dalszymi działaniami, kolejnymi projektami. Takie działania jak Inkubator Innowacyjności pozwalają nam na integrację środowiska, na współpracę pomiędzy jednostkami, a także na zawiązanie szerokich kontaktów społeczno-gospodarczych.
Politechnika Lubelska co roku zajmuje bardzo wysokie miejsca w rankingach innowacyjnych uczelni. Także w tym roku w rankingu perspektyw zajęliśmy bardzo wysoką pozycję zarówno w kategorii uczelni innowacyjnych, ale także pierwsze miejsce w kategorii
So hello and welcome. I think I see Zakaria now on the broadcast. Yes, and we are approaching the end of our today conference, and we are starting the third session today. And the first presenter in the first session will be Zakaria Guli from Morocco. And Zakaria, I think you can start now with your presentation.
Yeah, thank you. Hello, everyone. Do you see? Yeah, full screen. Yeah, hi everyone. My name is Zakaria. I'm PhD in nonlinear dynamics and energy harvesting. Groups, and I'm pleased to present this talk in this conference. I will present on the performance of fellow energy harvester using time delay. I start with introduction, then model description, periodic energy harvesting, analytical and numerical result, and conclusion. Introduction. In recent years, several research projects are focused on the problem of energy autonomy and in particular the power supply of sensors. Generally, the sensors are powered by batteries that require regular maintenance and have environmental problems. The question now, it is possible to replace these batteries with micro generators, autonomous and more efficient. Vibration-based energy harvesting is to convert ambient vibration into usable electricity for powering small electronic devices. They have basic transaction mechanism for vibration to electricity conversion, use electromagnetic, electrostatic, and piezoelectric transaction techniques. And in our case, we use or we explore periodic vibration to harvest in delayed nonlinear oscillator subject to galloping excitation and coupled to electrical circuit by piezoelectric coupling mechanism. In the linear case, the energy harvesting performance is limited because the system operates in small bandwidth near the resonance. To overcome such limitation, we use nonlinearity, and in the case of in the nonlinear generator, the bandwidth of the harvester increases in broad range of excitation frequencies, as you can show in this figure. But the problem of instability and jump phenomena still exist. The solution is to use quasi-periodic solution to harvest energy over broad range of excitation frequencies. The problem we're using quasi-periodic vibration to harvest energy have been presented by Mahmoud in 230. They have studied quasi-periodic vibration from vortex-induced vibration of circular cylinder, and they have demonstrated that the output power is small in quasi-periodic regime, as you can show here. Also, another problem given by Daqqaq and Bibo, they have demonstrated that for harvesting energy with good performance, as you show here, the quasi-periodic regime must. But our contribution concerns time periodic delay amplitude using quasi-periodic vibration to harvest energy with better performance. The first work given by Professor Bulhaq in 216, they studied quasi-periodic energy harvesting in van der Pol harvester with time delay. Equation can be given in the form by equation 1 and 2, then coupled mechanical and electrical components, or they have time delay present in the mechanical component. The time delay or the amplitude of time delay here, it can be modulated as equation 3, and they have demonstrated that quasi-periodic vibration can be that quasi-periodic vibration is more than periodic vibration to harvest energy. Here, as you can show, the time delay is present only in the mechanical component. The case where the time delay is presented in the mechanical and electrical circuit has been considered in this work. Also, the amplitude of time delay in the mechanical component, it be assumed related, and they have demonstrated also that the quasi-periodic vibration is better than the periodic vibration to harvest energy. And more recently, we have investigated the quasi-periodic vibration energy harvesting delayed Duffin. The governing equation of the system can be given by equation 6 and 7. And also the amplitude of the time delay is modulated such alpha equal alpha 1 plus alpha 2 cosinus omega t. And we have demonstrated also that the quasi-periodic, as you show here, the quasi-periodic vibration is better than the periodic vibration to harvest energy. Model description. The energy harvesting system can be considered by an oscillator. They have mass, nonlinear damper, and nonlinear restoring force. In this system, they have piezoelectrical element, coupled to electrical circuit to use this device as piezoelectrical generator. Also, the system is time delay and is under time delay and developing patient to use this device as piezoelectrical generator. The dimensional equation of this system can be given equation M, coupled mechanical and electrical component, and also the system is under delay in the mechanical component. We assume also that the amplitude of time delay is modulated, such lambda t equal lambda 1 cosinus omega t, and also the coefficient can be defined by equation 11. And this present work can be considered as an extension of the result given all, in which only the interleaved case where lambda equals 0 was considered. The objective of this work, in this work, harvest energy in delayed nonlinear oscillation subject to Gaussian excitation and coupled to an electrical circuit by piezoelectric coupling mechanism. It is important to notice that the time delay is not considered as an additional input power delay periodic amplitude in the mechanical subsystem of the harvester to enhance its performance. Periodic energy harvesting. Using the multiple scales technique, the amplitude equation of the energy harvesting system under time delay near the delay parametric resonance up to the first order is given by equation 12. Then A and V is amplitude, and the steady state response corresponding to periodic oscillation are obtained by the following algebraic equation 13, and the first order solution is given by equation 14. Then the voltage amplitude is given by equation 15. The dimensional form of the power is written as equation 16, and then the maximum our periodic power response read equation 17. Stability chart. Figure 3 shows the stability chart in the plan lambda 1 2 and time and power histories corresponding region picked from equation A, 1 for stable and 3 for stable periodic, and 2 is stable quasi-periodic. And we can show here from 1 or 3 to 2, the response bifurcates from stable periodic to stable quasi-periodic oscillation, producing decreases of the amplitude response and the corresponding output power. Analytical and numerical results. Figure 4 shows vibration and powers amplitudes versus the reduced point speed. The black lines for delayed mechanical component and gray lines for delayed system. Present in the presence of the modulated delay amplitude in the mechanical component, the vibration, as you show here in black lines, the vibration and the output power in certain range of wide. Figure 5 shows vibration and powers amplitude versus omega, and we can show from this figure that the presence of small delay amplitude on the mechanical component has a significant effect on the harvesting energy from periodic vibration, and figure 6 shows vibration and amplitude and power amplitudes versus lambda. Lambda is the amplitude of the time delay, and from this figure we shows that for the given value of parameters, the range of lambda where the good energy harvesting performance is achieved. Conclusion. We have studied the periodic vibration energy harvesting in delayed nonlinear oscillator subject to galloping excitation and coupled to electrical circuit by piezoelectric mechanics in the case where the time delay is modulated. This can be considered previous work in which time the periodic delay has been studied, and we have shown that the modulation produces significant increases in the amplitude of vibration then producing power with. And thank you for your attention.
Oh, thank you very much. I just want to ask one question because, for example, in this model, you have Duffing model. Yeah, Duffing model. For Duffing model, you could have some additional solutions, and you concentrated. Yeah. You concentrated on one solution, which is, or you have here some different solutions. Yeah.
Yeah, this model.
Yeah.
For this model.
Okay. Okay, and this is double wells or single well?
Single well.
A single well. Okay. So have you found some bifurcations in this case? I mean some subharmonic solutions.
Yeah.
So my comment is that it would be interesting to show maybe some Fourier transform. Yeah, to check what is the component of the solution in presence of time delay. Maybe this is modified, and this could be clearly indicated. Yeah. So have you tried to calculate Fourier transform?
We have done this for verification of some region, the behavior of some region, transaction between periodic, quasi-periodic.
Yeah. Okay, so thank you.
So Zakaria, thank you for your presentation. And I don't know if there are any questions from the audience. Actually, there are no more questions. Okay, Zakaria, so thank you for your presentation. Actually, I'm doing maybe similar research, which I'm going to present now. And okay, so I think it's all.
Thank you.
Thank you very much again. Okay, So I'm not sure if you see my screen. You see my presentation. So my name is Bartłomiej Bruszkiewicz, and I am actually now the PhD student at the Lublin University of Technology. Actually, Professor Litak was my supervisor of my master's, and this is actually the topic which I realized for my master's, and this is only the part of my research. So the topic of today's presentation is magnetic forces in the electromagnetic energy harvesting system with pendulum. And what is actually the double potential well? Not only in energy harvesting, but the definition of the potential well refers to a bounded region of space in which the potential energy of moving element is less than the outside the region. And the characteristics of the potential well are the weight, that is the distance at which the action of the attractive forces is manifested, and the depth which is equal to the difference in the potential energies of the particles at the edge and bottom of the well. And in the bottom, you can see the plot of the double potential well. And as I read, the double potential well can be characterized by its depth. So the depth is refers to the amount of energy, how to start up the system and take the system out of the potential well. And the weight is a distance with which the action of the attractive forces is manifested. So how the system can operate between the ranges, between it's actually the third, it's the potential barrier, between potential barrier. And this was the concept of my energy harvester. And this is an electromagnetic energy harvesting system with a rotational pendulum. Everything was made of non-magnetic forces. And what I wanted to, I created in the system two double potential wells. The very short pendulum was rotating between the two rows of coils, and additional, actually, here I mount inside the coils. I mounted two pairs of additional magnets, with which and their distance was regulating the double potential well in the system. So I could organize a very close. I could deploy the magnets very close to each other, and each potential well was very strong, and it was very hard to go through the barrier. Otherwise, I could flatten the potential well. Except of making the physical system in 3D printing at most, I prepared the experiment of this system, and here I solved the 2D FEM model. I calculated magnetic forces between the magnets, one on the pendulum and another inside the coil. And on the right hand side, you can see the two plots. And I realized this experiment in actually one of the potential well, but the system was symmetrical. So the magnetic force, the amplitude of magnetic force by very close distance between magnets was 10 times higher than for the deposition of 13 millimeters. And this magnetic force, this calculated magnetic force, was one of the coefficients which I put to the which I used actually for the mathematical model. And here is the equation. Here is the governing equation of the system. So here, primarily, I considered all the coefficients which with regards to the rotational pendulum. Of course, gravity, and the term for magnetic force, which was acting on the rotating pendulum. Additional, I changed the phase of the system for initial conditions, because I had to start up the system in order to obtain the rotating solution. I had to start up the pendulum with hand. And here you can see the total energy of the Hamiltonian system, where I show the two possible solutions of the system. Long green line refers to the rotations of the pendulum, and by each side. Otherwise, the system could get stuck in one of the wells. Here are two wells, and here the saddle points are changed because the system was tilted for some angle, about 30 degrees. And to develop this concept, the numerical simulation in COMSOL was prepared, getting much more accurate results. And in the next slide, I will show you the results. Here is the animation of the rotating pendulum, but I'm not sure if you see it. And here is the deployment for the position of the actually configuration of coils and magnets in my system. Those orange rings refers to the coils with real properties, which I prepared, and inside symmetrical coils, in two pairs of them, there are additional magnets which this was regulated. And here is sorry a moment. Because I have to change to the yes, somebody has okay. I'm back because I had to mute somebody. Okay, so let's continue. On following plots, you can see here is the simulation for one rotation in the second, and here is one rotation in one side and reversed. Actually, it can be observed here on this plot. Later on, the forces are simulated from the. Actually, there is output from the simulation regarding the magnetic forces which are acting between pendulum and additional magnets. Further, and next, here are the results for output voltage and output current from the system, and 30 ohms, 30.3 ohms was the maximum additional resistance which was added to the system. Actually, I tried to match the resistance to the internal resistance of the coils in the system. And what I have to also emphasize, and the line that we used 12 coils which were connected in series. later on, you can see how the magnetic force was changing here by going through the potential wells. Here is actually the symmetry, and in those regions you can observe how the magnetic force was changing in the system by the relative displacement of the pendulum and magnets inside coils. And those results later can be used for much more estimated results can be used for further simulations of the system. And here also the torques between magnet coils and between magnet, which are actually the damping which actually, yes, is a damping of the system. And for my initial experiment, I used those several additional resistance of the system, but here is nothing special that the power output of the system is increasing, of course, with lower resistance. But those results were useful for finding the maximum output of the energy harvester of my concept. Okay, so let's move back to the presentation, and here is actually what I talked about. Here is the magnetic torque of the system and those values, how it was changing in time, and because actually this is one rotation per second, as I mentioned. And on the right-hand side, you can observe the potential, how the potential was changing by the relative displacement. Those results are initial one, and later on will be used for much more developed model. And here I prepared only three possible solutions of the system. The first one, green one, but here I changed the magnetic force of the system, the amplitude of magnetic force. And you can see also the time series and phase portraits. So also in the system, as I mentioned, I can observe also oscillations and rotations of the system, depending on the applied force and several other parameters. And to continue my experiment and my research, I would like to develop the physical system and corresponding it with a mathematical model and FEM model. And here, in my opinion, the most important papers related to my research, where you can see, you can find the results of experiments and also modeling part. Okay, thank you for your attention.
So thank you very much for this nice presentation, Bartek. So now the session is open for discussion. So I can ask maybe the first question. The problem is related to the distance. For example, once you place the additional magnets, is it possible optimize the distance between magnets, and then you can get probably some rotational or maybe oscillational modes.
Yes, it's possible. What I discussed actually, it's possible to adjust the distance of the magnets and obtain also oscillations, otherwise rotations of the system. And that was the idea of the system. But here the double potential was introduced in practice.
Okay, thank you. So maybe if there is no other question.
There is another one question.
Yeah, okay, yeah. So please ask the question. Yeah.
Yeah, hello, thank you for the presentation. My question is, how did you consider the damping in the COMSOL model?
Actually, because I introduced the properties of magnets. So all the parameters regarding the magnets. And I don't know actually what is the computing procedure exactly there, but the results were actually similar from the 2D model and 3D model. But I must say that the 2D model was much more simplified because I was operating in only 2 axes, and the magnets were were rings, and they were rotating magnets.
Okay, so any other questions?
Actually, Sheikh Farouk Ali asked the question.
Okay.
If I may ask directly.
Yes.
Yeah, it's a very nice presentation, especially the video or animation that you have shown. It's excellent. My question is, did you see the effect of the magnets that you have probably placed 10 or 12 magnets around, effect of them on your pendulum? Which I mean, is there a way of locating these magnets optimally?
Actually, the experiment which I conducted was I set the limit actually inside the coils. So actually there is no actually in my paper there is actually the surface how the magnetic force was changing in much more distance, and how it was influenced on the magnetic induction of the system. But I don't know what they mean actually because of optimal solution.
I think looking into optimal solution, which we are also probably doing, will be a good idea to see, because when you have multiple coils around the pendulum, the effect actually makes a lot of change into the harvested energy. We also did experiments, if you have cited the paper, we saw that the position of these coils makes a lot of change. So probably looking into that will be also a good idea to increase probably the power harvested from the system. So I was just thinking that whether you have also seen the similar thing in the experiment. So, okay, thank you.
Okay. Otherwise, you can feel free to contact me. You have my email, so you can ask me also
sure.
much more detailed question via email.
Yeah. So if there's no other question, maybe we can go to the next presentation. Yeah.
Okay. So I will announce another presenter, and it's Aravindan Muralidharan from India. Okay, so the stage is yours, and you can yeah. Ravindan, we don't hear you.
So, is it audible now?
Yes, but you have to change to the Zoom.
Okay.
Because you are sharing the presentation with another user.
A moment, sorry.
Okay, now it's okay.
Okay. Okay. So I'm Arvindan M from Indian Institute of Technology, Madras. So my guide is Dr. Sheikh Farukali. So I'm here to present my work on feasibility study of utilizing 1:3 internal resonance for broadband energy harvesting. So on this occasion. So before moving on, I would just like to show the outline of the presentation. It's going to go like this. I'll introduce the basics of energy harvesting. So I'm not going to go into details of it, as everyone today has given more details on the methods of energy harvesting. I'm going to just give a gist of it. Then we'll see basics of, basic broadband energy harvesting methods available. Then I'll give you an overview of internal resonance, following which we'll go into the work which is going to be presented today. And finally, I'll summarize and then with the scope for future work. So now this technological advancement in the past 2 decades have put a lot of onus on reducing the power consumption behind the wireless sensors. So replacing batteries has become is going to be a much more not going to be much more task because of the technological advancements. So this is followed. So this made it to follow to come up with such an arrangement where we can harvest energy from the environment. So there are so many sources of energy in the environment, like vibration, electromagnetic waves, heat, light, and so many things. So vibration is one which is available in abundance in the environment. So which can be used in plenty. So a vibration energy harvesting came into the roots because of this particular reason. So, but even though the operating domain of vibration energy harvesting is restricted to this zone where it can harvest from nanowatts to the milliwatts, and now maybe like people are looking to push it forward to harvest till watts. And its potential applications are mostly structural health monitoring related, as well as healthcare and so on. We may have seen from the morning that there are different transaction mechanisms. I'm not going to go in detail behind the principle behind it, but I might as well say of all these methods in the literature, electromagnetic as well as piezoelectric transaction are the two methods which have been explored well because of these traits, where they are easy to implement and they have superior power densities, as well as there is no non-requirement of dedicated voltages. And in the earlier stages where the energy harvesting made its inception, mostly there were only conventional harvester designs. Like when it is piezoelectric harvester, you will see a cantilever beam with a piezoelectric harvester attached to its root, or for an electromagnetic harvester, you will see a spring mass system going inside a coil to generate an EMF and so on. But the problem here is, so mostly it is modeled as a linear initial generator where you can see a spring mass dashboard system. So the problem here is, so once you go away, even away from the resonance, your power is going to drop abruptly. So that is the nature of the linear resonance. So if you're going to harvest power, you have to be very sure about the excitation source. Otherwise, it's going to be difficult to harvest power at the resonance because you're not going to capture the resonance on pin conditions. So that is a major drawback. So which prompted the researchers to go forward and find much more reliable methods to harvest power from the broad band of frequencies available in the environment. So there are multiple methods we don't have to go much into it. I'm going to focus more on the non-linear harvesting, which has gained much more scope in the past few years because of the advantages it gives, while not only helping to improve the bandwidth as well as to increase the power magnitude as well. So we'll dwell more into the depths of nonlinear harvesters and the common configurations, mostly using either a magnetic arrangement or a buckling based method to introduce nonlinearities into the system, and these are generally modeled as duffing based oscillators. So either they have a broad potential wells, so with one or more potential wells with broader potential wells, so which gives a scope for harvesting energies even at lower energies. So this gives a wider edge over its linear counterparts. So as a slight digress from the previous slide, so let us see a little more about coupled oscillators in general. So which is like a fascinating subject of interest among the researchers, owing to its resemblance to physical processes in the nature. So the main thing about the coupled oscillators behavior is its collective behavior is much more different than what you see it as an individual unit. So there are many such behavior which you can see from the literature, but the three most important things which you can see from the works reported are stochastic resonance, where the system is going to be sensitive to the noise present in the system, because of which the response is going to be accentuated. And there is also energy. There's also going to be energy pumping across the modes, depending on how the parameters are going to be designed. So which will give an edge to redistribute energy among the modes. And also much more recent entry into the energy harvesting arena, where synchronization is being used to increase the power output. So these all three things can be viewed upon as possible for front runners to actually help the energy harvesting community to improve the power magnitude of the harvester. Of which specifically, so we are going to see more on internal resonance, because this work is going to be on internal resonance. So before we move on, we have to see what internal resonance is. So it mainly occurs in MDOF systems, multi-degree of freedom systems. The condition is at least two of the linear natural frequencies should be commensurate. So what is commensurate? So commensurate is when at least two of them are commensurate. That is when you have a ratio, it should the resulting number should belong to the set of positive rational numbers. So if they are commensurate, so what is assured? Then the assured thing is the energy is going to be pumped efficiently across the modes. So it was first originated in the work of Freud, where he reported that in the ship and roll motion of ships, the internal resonance undesirably increased the motion of the ships. And this is also present in the responses of quadratic and cubic oscillators, which is very well known in the nonlinear oscillators literature now. But the defining characteristics are that there is an absence of steady state mode in certain cases, even when there is positive damping in the system. So this helps in continuously pumping energy between these modes. So this we see as a trait which can be used to harvest power, so which you'll be seeing in the coming slides. So as an example, you can take a simple spring pendulum, just to give a physical perspective to the people who are not into it. So if you take a spring pendulum which has two defining motions, one is a planar motion as well as an extensional motion. So as such, when you design it as a linear system, these two modes are not going to be coupled. But once it is coupled, here in this case, when you couple it in the ratio of 1:2, so such resonance is known as 1:2 internal resonance. When it is designed as a 1:2 internal resonance, you can actually see in an ideal situation. So an extensional motion will be exciting the planar motion, and the planar motion in turn will be exciting the extensional motion. So ideally it will be a perpetual motion, but in a damping case there will be a limit. But to the limit with its strengths, it's going to be beneficial as energy is pumped from different modes. So there are basic applications, so which you can find in a wide variety of physical applications. As we saw earlier, it's pitch and roll dynamics of ships, which started it all, and followed by different systems like double pendulum, which is now more common system for energy harvesting systems. And one more thing is flexible structures, which is of prime importance to us in this work, like beams, plates, shells, and so on. and there are works on internal resonance in vehicle suspension systems as well. So the relevance. So when we come to the relevance, several works have been reported on internal resonance phenomenon being beneficial for improving the power bandwidth. In the literature, if you see, the most important thing is to have an auxiliary oscillator. So you design the frequency of this particular harvester system to match with the frequency of the auxiliary oscillator, which will have its own natural frequency. So you design these natural frequencies to be in a commensurable manner. So you can, people have done work on internal resonance in various mechanisms, energy harvesting devices based on various mechanisms, like it can be piezoelectric or electromagnetic and so on, but the principle remains the same. But the 2:1 resonant dynamics or 1:2, whatever it may be called, is widely adopted in the harvester systems for bandwidth enhancement. So our objective of the study is, not many works have gone behind to exploit the 1:3 internal resonance ratio, because this has been reported in literature that for systems involving symmetric potential, this ratio is going to improve the harvesting power more because of the pumping between the first two modes of a flexible structure, which is known to be efficient under 1:3 ratio. So we would like to take this, see the possibility of exploiting this 1:3 internal resonance for efficient broadband energy harvesting. So the system what we have taken is this, a simple inverted cantilever beam with a lump mass. So the lump mass is attached at an arbitrary distance, say LT here, and the system is in bimorph configuration, and a lump mass is attached arbitrarily at certain distance. So this is the configuration over which studies are going to be conducted. So based on Hamilton's principle of least action, we derived at the governing model equations, the details of which have not been given as a matter of the time constraint of this presentation, but the general form of the governing model equation, mechanical equation, would be of this form, where the linear part goes here and the parts within the summation refer to the non-linear part. So you can clearly see these generalized coordinates, I mean the modal coordinates, are not uncoupled, rather they are coupled. So unlike the linear systems, which is well known. Similarly, because of the large displacement coming into the structure, so even in the governing electrical equation for the piezoelectric system, there is going to be coupling, a non-linear coupling, which is going to affect the power response of the harvester. So here in this case, beta and lambda are the coefficients of inertially and geometrically coupled nonlinear terms, and θ1 and θ2 are electromechanical coupling coefficients. And Cp and RL are the capacitance and resistance of the piezoelectric patch, which we have considered in the work. So before we see the results, first the condition of 1:3 internal resonance should be established. For that, we have to first set the parameter for which these things can be established. So even though there are a lot of parameters which can be exploited, like the length of the beam, the distance of the lump mass, or rather the lump mass itself, we would like to keep it simple just to show the potential of 1:3 resonance. So we have made the parameter to be tip mass. So we have varied the tip mass, and I've seen keeping all of the parameters to be constant, and we have seen where this 1:3 resonance is going to occur. So it occurs at a particular value of critical mass. So we are going to study tip masses close to these critical masses, so that we can investigate the behavior of harvester under 1:3 internal resonance. Okay, before I move on and go on to show the results, I would like to show the parameters used in the analysis. So for the results shown in the coming slides, I have not changed the damping parameter, I have kept it constant, and rather all structural parameters have been kept constant except for the lump mass. So the data for the piezoelectric patch, I have taken it from the Smart Material Corporation's database. So once governing equations are arrived, so there is a need to find the responses of the system. So we have considered the system to be weakly nonlinear because our agenda is to find the responses near the primary resonances. So we have not considered secondary resonances effect here in this slide. So we would like to see how the system is going to respond near the primary resonances. So that constrains us to consider the system to be weakly nonlinear. So for the weakly nonlinear system, we adopted the method of multiple scales, and we arrived at a set of amplitude phase equations where A1 and the modes considered are the first and second mode of the cantilever. So A1 and A2 correspond to the amplitudes, and phi1 and phi2 correspond to the phases. So here the time scales considered are T0 and T1. So 0th order and first order time scales were considered, as well as where epsilon is the perturbation parameter. And there are two detuning parameters used, like in any general method of multiple scales work. So sigma naught here refers to the proximity of the second natural frequency to the thrice the first natural frequency, whereas sigma 1 refers to the natural frequency to the excitation frequency. Since this case is excitation frequency approximately equal to the first natural frequency, we have omega 1 here. Similarly, we have another set of amplitude phase equations for excitation frequency approximately equal to omega 2 as well, and the procedure is same. And instead of omega 1 in the previous slide, we will have omega 2, and rest of all these things are same. Eta 1 and eta 2 in this slide refers to the phase shifts of the system. Here in this case, eta 1 refers to the phase shift of the second modal response, and eta 2 refers to the phase shift of the excitation with respect to the first modal responses. So we'll be studying eta 1 and eta 2 with respect to the first modal response. So once we solve those equations, which we arrived in the previous slides using say a pseudo arc continuation method, so to trace solutions along the curve. So we see interesting results here. So which is much expected when internal resonance is present. So under say an excitation amplitude of say 5 mm, which is considerably low compared to 12 mm. So we see responses somewhat similar to a normal Duffing oscillator, where A1 first modal response is predominant and A2 is going to be 0 when it is linear, but here in this case E2 is somewhat small compared to A1. So A1 is predominant when you excite the system near the first mode. So that is pretty clear. So that is aptly reflected in the frequency response of the harvested power also. But once amplitude is increased, amplitude of excitation is increased, so you see a loop-like branch increasing in amplitude multiple folds. So that will have an effect in the harvested power's frequency response as well. So within the frequency band we are considering, we have one more band within which you can actually harvest power, here in this case by almost increased by twice the fold. So this clearly shows the second modal response is quite clearly activated, which is helping the harvested power to helping to increase the magnitude of the harvested power. And one more interesting response is still the magnitude of the second modal response is quite small when you compare that to the A1, but even though the magnitude of A2 is quite less than A1, you can actually see its influence on the harvested power. So which quite clearly tells that it has a clear say on the harvested power's magnitude as well, even with its magnitude being small. So if you have to study the same thing from the perspective of phase shifts, so here green one correspond to eta 1, as I said, like this is the phase shift of second modal response with respect to the first modal response, and violet curves correspond to the phase shift of the excitation frequency with respect to the first modal response. So if you have to understand this from the perspective of the phase shifts, so one thing is quite clear. For the values of detuning parameters, which means for values of excitation frequency little far away from the first natural frequencies, the system is approaching either the phase difference of 0 or pi. But at a certain point where the stable and unstable branches meet, so at the saddle node bifurcation point, you can clearly see everything merges at pi by 2 phase difference. So this is quite common for a single mode response. So here, so this is for the case where Z naught equal to phi m. So still the internal resonant response, what we saw before, has not set in properly yet. So like in this case, so this is Z naught equal to phi m. So you can quite clearly see the branches, the primary resonant branches without the loop-like branches set in. And similarly, you can also see for the excitation frequency, the phase shift is either 0 or -5. So when you go away from a value of detuning parameter 0, and once the excitation amplitude is increased, quite clearly you can see there is an additional stable branch coming into the picture because of the loop-like branch in the frequency response. So which is peaking at around the value of pi/2 for the second modal response. So when the second modal response is somewhat around this pi/2 with the first modal response, you can very well see the existence of the first loop-like branches in the frequency response. So which again must as well contribute to the power response as well. And similarly for the excitation frequency, it is around the -pi/2 range. So which is not quite surprising, as we saw, like it's 0 to pi for second modal response and 0 to -pi. Similarly here, near the -pi/2 range, so you can clearly see the loop-like branches coming into the picture. And not only that, so we have to ensure that this primary branch is actually this loop-like branch is being contributed by the second mode. So that we have to see. So for doing that, we pick 2 points on the frequency response. So one on the primary resonant branch, and one will be on the loop-like branch. So when you see on the primary branch, you can actually see the first mode response dictating the power output. Still, you can see a second modal response also playing its part in the harvesting process. So the reason for the modulated response are these frequency peaks coexisting together in the frequency space. So this is for amplitude equal to 12 mm. So when you consider the same thing at a point on the loop-like branch, you can see the second peak as well becomes comparable with the first peak, which is due to first modal response. So in fact, this is how doing the first modal response, even though the response is near first natural frequency. So the high frequency components come into the picture, as we can see from the time response. So the loop-like branch definitely is dictated by the second mode, so which again is due to the energy being pumped from second mode onto the first mode. Okay, so we have to see the role of initial conditions as well, because since these branches coexist, so there are chances that initial conditions also play a part. So depending on the initial conditions excited, the branch excited also might be different. So here we see 2 different cases. So with one point on the loop-like branch, so the loopy branch, and the other on the primary resonant branch, so where the loop branch is not present. So if you see the first case, so you can actually see 3 power outputs, so which correspond to 3 stable branches coexisting together. So because of which we see 3 power outputs, and mainly the power output is mainly dictated by the topmost loop branch, while the primary resonant branch comes second. But when the system takes the last branch, the power output is quite low. So by making the system to operate at these initial conditions, so the system can be made to operate on the loop branch. So which is quite possible through the methods now available, like control methods available now. Whereas if you see in the absence of a loopy branch, there are only 2 stable branches coexisting, and with the primary branch dictating the power output, and also there is low power output branch, which is nothing but the lowest stable branch existing in the frequency space. And if you see the effect of the proximity of the lump mass to the critical mass, so we saw that the mass is critical when the second natural frequency is exactly the thrice of first natural frequency. And we also discussed that the power the pumping of energy across modes is optimal when the system is exactly set to 1:3. But when we studied, when we investigated, we actually saw the bandwidth of the response, I mean the one more band which is existing within the frequency band which we consider in the loopy branch, we actually saw the loop-like branch extends across a range of detuning values when the value of detuning parameter sigma naught is not actually 0 but close to 0. So here in this case it's -10. When it's exactly 0, we still have an energy transfer occurring, but it is not maximum. We saw the energy transfer is maximum when the internal detuning parameter is close to -10, which in this case is not the critical lump mass, which has exact 1:3 internal response. So all this way we saw the frequency responses. So yeah, now if we see the amplitude effect of excitation amplitude on the modal amplitudes and the power output as well. So clearly when the excitation amplitude is low, so you see a normal monotonous increase in the value of first modal amplitude with a slight loopy branch available as an extension, after which the solution jumps to the higher stable branch. So similarly, we have a second modal response also, which is not 0 with the amplitude of excitation, which is 0 when it is small, but once it's large, you can actually see A2 picks up in amplitude. And one interesting observation is that because of this, so the value of A2 after certain value of excitation amplitude, it saturates. So even if we go beyond certain value of, a value of excitation amplitude, the second modal response is not going to increase at all. So then again, this will have an effect on the harvested power itself. So the second order response will have an effect only till a certain value of excitation amplitude, beyond which there will be no appreciable effect of second modal response on the harvested power. So first mode will be dictating the response. So once again, this is for the case where sigma naught is 0, detuning parameter sigma naught, which describes the proximity of the lump mass to the critical value, is 0. So when you set it to sigma naught equal to -10, when we saw, you can clearly see the harvested power is quite high when compared to its primary resonant branch. So this clearly shows the the energy pumping due to the second mode's amplitude. It's quite large when you set it close to 0, but not exactly to 0. Same things can be studied when the harvested power is near ω2 as well. But one thing we wanted to show is, so here in this case, we saw an additional isolated branch as well compared to the loop-like branch in the previous case. We also saw an additional isolated branch with increase in the amplitude extends across a wide range of frequencies. So this can actually affect the system to actually to have a much more better bandwidth of power. So once it increases, you can clearly see there are two responses here. One is the actual response, single mode response, where A1 is 0, which means we are exciting the system near ω2, second natural frequencies, and we have first mode response to be 0. So this is possible only when you excite it near the second mode, which we observe. And when it is not equal to 0, you see an isolated branch as well. So these two things occur for two separate initial conditions, like we saw the basins of attraction for the previous case. Basins of attractions can be drawn for these cases also, but here for brevity we are not showing these cases. But our intention is to show that these isolated branches can help in improving the bandwidth of the power. So even with a marginal increase in the amplitude of excitation as compared to the previous case. So previous case we had to go till 15 mm or 14 mm to see the actual benefit of internal resonance on the harvested power. Whereas when you go when you harvest near the second mode, since the second mode is much more dominant on the harvested power, harvesting power from the system, so you can clearly see even under low amplitude of excitation, you have a much more higher magnitude of power harvested with an improved bandwidth as well due to the isolated branch coming into the picture. So just like we saw excitation amplitudes effect on the harvester near ω1, we have ω2 as well. The interesting thing is this isolated branch exists only for a limited range of excitation amplitude, that too very small. So even if we go beyond, that is not going to bring in the isolated branch into the picture. So the system is active only when you run it under low amplitude of excitation. Other than that, if you run it under high amplitudes of excitation, the system is going to behave as if it's a single mode response. So this is one prominent response which we thought, okay, it's going to have an effect on the study of internal resonance on the structure, because it's not going to increase monotonously with the excitation amplitude. Rather, it has a limit beyond which it's not going to be existent at all. So just to make sure the responses what we got are correct, we also numerically validated it using RK45 solver, and we saw the results are in reasonable agreement. So to capture the response of the isolated branch, we tried under different initial conditions, and we got to see that the results are in reasonable agreement with the approximate analytical results which we got using method of multiple scales. So the circles here represent the empty circles represent the forward sweep, and the filled square represents the backward sweep, and you can very well see it's in reasonable agreement. So so summary, if I have to give the study, actually we thought we'll propose an internally resonant coupled oscillator model for the harvester to see what effect it has on the magnitude and bandwidth. Even though work has been done, we thought, particularly we have to see what is the effect of these isolated branches as well as this loop-like branches it would have on the harvester problem. So approximate analytical solutions of the weakly nonlinear governing are obtained using the method of multiple scales. So we also saw the IR mode, if activated, depending on the initial conditions we excite, is going to have a much more say on the magnitude of harvested power, particularly near primary resonances. And we also saw the energy transfer is going to saturate after a critical amplitude of excitation, beyond which there is no appreciable power output because the value of second mode response is going to depreciate after the critical amplitude of excitation. And the presence of these loop-like and isolated branches of the frequency response due to the 1:3 internal resonance might help in augmenting the magnitude as well as bandwidth of the harvested power within the frequency band we consider. So particularly near the primary resonances. So to see whether this is useful, even for the secondary resonances, future studies have to be conducted, because it's if you go much off from the primary resonances, whether these internal resonances are going to be useful or not have to be studied. And also in this study we have just shown the effect of periodic responses. So when the system is going to be unstable, there are going to be some other responses like limit cycle responses or aperiodic responses also coming into the picture, which have also has to be studied if in order to completely characterize this internally resonant system. And also, from the perspective of nonlinear normal modes, if we can characterize the effect of internal resonances, then we can actually have a deeper understanding of what is going behind the responses of these systems, which might help us to design the system much more efficiently. So these are the selected references from which we have referred to conduct this work. And I would like to thank the Department of Science and Technology India for funding this research work. And also, I would like to kindly acknowledge the support extended by ehDIALOG project as well as University of Lublin for providing me an opportunity to present my work in front of this energy harvesting company. So thank you. So any queries?
So thank you, Arvind, for your interesting research. And so you are using also broadband effect in energy harvesting. So we can forget that we should operate in not only in resonance frequency, but we can use also other subharmonics or other superharmonics.
Correct. So that is under process. We have not studied yet, but we just wanted to show the potential of utilizing internal resonance for energy harvesting.
Okay, that is one comment from me. Okay, so the question session is opened.
Okay. Yeah, I just want to ask about this subharmonic solutions, because you did some numerical calculations and you compared to the theoretical predictions, and then probably it is also necessary to check what is actually the solution from numerics. Yeah. Okay. And in my opinion, there could be two components. For example, omega 1 and 3 omega. Yeah, so this could be two components in that solutions, numerical solutions which you presented, but you linked the solution along the theoretical lines. Yeah.
Yes,
but
yes.
The question is, have you checked what is the what are the frequencies of a solution?
Okay, so 1 minute. I'll just open this presentation.
Yeah. Okay. Yeah. I was thinking about one of the last pictures. Yeah, when you have yeah, this is that one. Yeah, and for example, this second solution, maybe in the middle of the bottom. Yeah.
Oh, this one. Okay.
Then you have points, numerical points exactly on the line. Yeah. Yeah. This is in the middle. Yeah. Bottom in the middle.
Yeah.
Have you checked what is the composition of frequencies of this solution? This solution, additional solution. Yeah. For example, by Fourier transform. Yeah. You have.
Yes, I've seen. I've not shown it in the slide, but if I may, okay. So, but similar to the studies, what we studied here, like I also studied the frequency spectrum of near the second mode as well on the isolated branch. So what I saw is on these branches, okay.
You have both frequencies. Yeah. Okay. Yeah.
Both frequencies we had. So particularly on this. So we saw A2 is much more greater than A1. So what we studied is periodic responses. So might be aperiodic responses also might be there. But all I have solved numerically is the amplitude phase equations obtained using the method of multiple scales. So if I can solve for much more inner parameters or under different initial conditions, I might get different solutions as well. So
okay. But in the multiple scales, you had only one component. Yeah. One frequency.
I didn't quite get that. One component in the sense?
Yeah.
Maybe repeat what you told, sir. I didn't quite get that.
Yeah, maybe one is much smaller. Yeah. Okay. Thank you very much. Yeah.
Okay, thank you.
Okay, so I don't see any more questions. So I think we can move to the presentation of Sheikh Farouk Ali. So I think, so I hope you have this presentation from Rayaratinam. And
can you hear me?
Yes, I hear you, of course.
Very good, thank you. Right, that's the first thing to check. Yeah, so let me share the PDF. Share. So it's telling that it will throw me out and then I have to log in again. Okay, so give me a minute.
Okay, it's fine.
Yes, so am I audible now?
Hello? Sorry, now I hear you. Yes, and we see your screen. Can you see the screen? Yes, yes. Okay, good. Right, so this is the work that Dr. Rathinam did, after his PhD, I suppose. So we started working. This work we started, and when I was in Swansea, it was, I think we thought of this idea whether how to use energy harvesting devices along with other sensors or controlling devices that are available for engineering. So the thought came that energy harvesting systems do need a lot of vibration to provide enough amount of energy or to harvest enough amount of energy, whereas the controller systems needs to control the vibration, so it reduces the vibration of the structure. So these two are probably contrary to each other and have different optimization goals. So we gave it a thought, and we looked into literature, and saw this dynamic vibration observer are a certain kind of observers or the controllers where energy from the primary structure is shifted to the secondary structure, which is a dynamic vibration observer, also known as TMDs in civil engineering. And then the vibration observer will vibrate a lot by picking up the energy from the main structure. And that's why they control the main structure. So the objective was, can we engineer the harvester, dynamic vibration observer, to make it integrated dynamic vibration observer and energy harvesting device. So we started working on that in the analytical domain, and in 2012 we published a small paper on the harmonic response of those integrated systems. And what Dr. Rathinam did is to look into what happens when you have non-harmonic response, non-harmonic input, and what happens when you have parametric uncertainty into the system. So that's what he has worked into, and I'm going to present his work. And I'm sorry for the problem that we faced in the morning in presenting this by Dr. Rathinam. So if we look into the outline is like introduction, which I will not take much time because it has been talked about from the morning. Then harvester model, that's what model we are taking here, then mathematical model slightly, and mainly we'll go into the results and the conclusion slide of this. So the slide 3 shows different kind of applications where energy harvesting devices are used. It also shows a few applications where controls can be used. For example, DVAs are used in any vibrating structures, for example, railways to bridges. Bridges uses big ones. They are also used in satellites to change, to absorb the vibrations, small ones, small sizes. And buildings, long, tall buildings. So everywhere DVAs or TMDs are used. The objective is when these TMDs vibrate a lot, can we harvest power out of them or not? So this is a bit of literature that was been done. So this is the one where we Professor Adhikari, we published a paper on the first idea on this integrated harvesting system, and then this is the second part where we did a little bit of uncertainty. So this is the device, this is the schematic of the idea that we had. This is M0 is the primary mass. M0 is the primary mass, which has its own stiffness and damping. And then this is the integrated device, which looks like a DVA with a spring here, damping here, and a mass, MH, which is the harvester mass. H stands for harvester. And you attach somehow a PZT or a harvesting device into it, so that when this main structure vibrates, the energy goes to the secondary structure, and the secondary structure generates, so you tap the energy from the secondary structure. If you do a lumped mass model of those things, you get an equation which will be like this, where it's first the equation represents the primary mass of the system in a lumped mass framework, single degree of freedom. Second equation represents the DVA portion of it along with the damper. And the third equation is the electrical equations that is used to take the energy out of it. And when you have the energy out of it, you use the power equation where P is equal to V squared by R. So there are a few more parameters given here.
This is the complete mathematical equation, and when you have a random excitation to it, so you assume a Gaussian random white noise excitation, and then you do solve the equations of motion in the frequency domain. These are all quite standard, and you get the expectations of deformation and expectation of displacement of the primary structure and expectation of power that you harvest from the harvesting device. Now the objective is you need to find an optimal parameter for your integrated system such that you do reduce the internal motion of the primary structure as well as you harvest enough power out of it. So that's being the objective. So you need to look into different parameter domains by changing the parameters and see how they behave across the various parameter ranges. So the first thing to look into is how the power, the mean of power changes if you change the electrical parameter of the system. For example, the non-dimensional time constant and the coupling coefficient kappa square. If you change that, you see that with increase in the damping, that means with increase in the secondary structure damping zeta h, there is a change in the diagram or change in the functionality of power with respect to kappa and alpha. So this is probably more visible with the contour curves here. As you can see, the contour curves comes more closer to each other as you increase the damping into it. That means it becomes more sharp, and you're going to get a sharp peak in power, losing out on the broadband nature of the system. So if you want to have a broadband nature of the system, you probably need to have reduced damping on your secondary structure. But if you want to have a peak, more high peak power, you probably need to have better damping into the structure. The second part of the result also shows we looked into the optimality of this, the coupling or optimality of the time constant of the device, and this is the picture shows this picture here shows how your damping into the secondary structure damping zeta h, how this damping affects the optimality of alpha. So this is an after optimal. As you increase the after optimal changes and shifts towards 1. So this is one of the another interesting result that we got from it, which gives you the values of alpha that we need to consider. That means it gives you the properties of the harvesting system that you need to choose to get better power output from your system. So a few results, the conclusions of result written here, that power generated increases with reducing the absorber damping. This is because your PZT or the energy harvesting system also acts as a damper. It takes energy out of the system, therefore it dampens the primary structure, and while doing so, it actually reduces the vibration in the primary structure too. And probably all of us know that when a DVA works, it works over a particular optimal zone of damping, total damping. If your parameter of damping changes from that, your control efficiency reduces for the primary structures. So if you have energy taking out from the system, if you're taking energy out of the system, your damping of the secondary structures should be lower than what the analysis tells you. A few more curves here, which are also the parametric zones. They are looked into the power as function of your mass ratio. Mu is the mass ratio and the time constant. Similarly, it looked into for various values of kappa square, and then various values of zeta, that means damping, and then also on various values of harvester damping. So 3 parameters have been looked into, and as you can see, there is always an optimal value that is available. This is the optimal zone where you generally generate higher power of the system, and then that's the optimal thing. And then we looked into how this also affects the deformation or the displacement of the primary structure. That means your interest also is to control the primary structure. So you want to reduce the vibration of the control structure, primary structure. And this is the response, estimated response of the primary structure. And as you can see, there is also again a value that gives you optimal value of mass ratio and time constant that gives you an optimal performance over the primary structure deformation. So therefore, it tells you that there is definitely trade-off possible, and there is definitely a trade-off available, which we can look into, and we can have a comparative results on both sides, on the side of controlling the structure as well as on the side of harvesting power. Then I think Rathinam looked into what happens when you have parametric uncertainty in the structure, and he has considered this uncertainty into the stiffness of the material system as well as uncertainty into the damping of the system. And these are the curves. This is for standard piezoelectric harvester, and this is for energy harvesting dynamic vibration observer. And as you can see, there is a change in the curve from here the peak responses remain the same, whereas this one shows the change in peak response because you are adding a DVA device into it. So you are adding another degree of freedom to the system, and then you can see that there's a broadband nature that comes in as we increase the damping into the system. And then also there is another curve here showing how much efficiency reduces when you have uncertainty into the parameter ranges. And this shows that the maximum efficiency, maximum power curve reduces quite fast as the increase in uncertainty goes up. So this is almost like 20% increase in uncertainty, and then the power curve is reduced to a lot, as you can see. And these are a few curves where the optimal power zone has been looked into with respect to the time constant in the material. And you can see there are peaks that are available, and this peaks vanishes as you increase damping value in the secondary harvester. So it becomes, again, the two peaks goes to a single peak as you go up. So now you have to look into which domain is interesting to you, and we have to look into various options of increasing harvesting as well as reducing damping, reducing the primary structure response, and probably have to look into multi-objective solutions here. So which we have not looked into, probably the next way to go into looking into the multi-objective solution where we can get a single or a range of the parameters for which both the objectives will be satisfied. A few more comes on the non-dimensional electrical coupling coefficient. As you increase the uncertainty in the natural frequency, your peaks, you get two peaks, and then peaks reduces as you go on higher side of the uncertainty. Similarly, when you increase damping, your two peaks reduces vanishes to a single. In conclusion, Rathinam looked into two things. One is what happens when you have uncertainty into the parameters of the harvester, or parameter of the structure, primary structure. And the second thing, he looked into what happens when you have uncertainty into the input to the structure. That means the input is random. What we have to look into what happens when you have combined responses, combined things. That means you have an input that is random as well as the structure has a little bit of uncertainty to it that we have not looked into. Probably that's what we have to look into in the future. And I said the responses, conclusions that harvested power increases when you increase the coupling coefficient and decreases as well as the zeta, that means damping. When you increase the damping of the secondary structure, your optimal responses moves away. So for every damping value, we have an optimal response, and you need to probably do a proper multi-objective optimization to get a proper value, a proper range of the parameter along which you will get both objectives to be satisfied properly. With that, I'll stop. If you have any questions, I'll be happy to answer. And thanks to Project Dialogue for giving this opportunity to present Rathinam's work. Thank you.
So thank you, Sheikh Farouk Ali, for your presentation. And if somebody has a question, now is the time for that. But I don't see any question. I don't see any questions. So I think we can move to our last presenter today. We've got on the line Professor Alper Ertürk.
Thank you. I'll wait for the next talk here. Bye.
Okay. Can you hear me?
Yes, I hear you.
Okay, very good. Because I just came from my teaching. I'm going to go ahead and share my screen. Just 1 second.
It's in the bottom, green button.
Yep. This is screen 2. Okay. Let's do this. Do you see my screen?
Yes, yes, I see it.
Okay, very good. Thank you very much for the opportunity. So let me confirm. I have half an hour, right?
Yes, yes. Till 6 in Polish time.
Okay, okay, very good. So yeah, I'll try to finish early so we can have questions, answers, and that kind of discussion. So
discussion, right?
Absolutely, yeah. So thank you very much for the opportunity, Grzegorz and Peter, and I see Bartolome. So thanks a lot. It's a pleasure. I wish I could be there, and obviously I wish we could be all together, but I think it's impossible. I don't know the setting right now in Poland in terms of COVID, if it got any better, but in US it's not too good. Still, we're entirely stuck at home, teaching from home. My everything is online. So anyway, so let me go ahead and get started. So I wanted to put together something related to this metamaterial and photonic crystal-based concepts for the focusing of the localization of elastic waves and acoustic waves as well. I will show you some most recent stuff and even some unpublished material for especially for the acoustic wave counterpart of the problem. I don't think we have enough time to just kind of like some advertisement, but just so you know, I'm connecting from Atlanta. That's where Georgia Tech is located. So in case there's any of you, if there's any graduate students, like master's students considering PhD and so on, please make sure to consider Georgia Tech as a possibility. And or if you ever visit Atlanta, just let me know so we can arrange to get together. Of course, hopefully at a better time after COVID and everything. Okay, so just some acknowledgement. The stuff I'm going to show you were supported by the National Science Foundation and also by the Air Force Office of Scientific Research in the United States, and especially Şerife, Steven, and Chris and Ahmet were some of the main contributors. Şerife is now an assistant professor. My former student is an assistant professor at University of Michigan, Ann Arbor. Steven is at Lawrence Livermore National Labs. Chris is still with me as a postdoc. Ahmet is a PhD student. He's the guy working on acoustic wave, like 3D wave counterparts of these projects. Anyway, I won't spend too much time of my lab introduction, but we mostly work on dynamics and vibration and acoustics of structures, passive and active structures for a very broad frequency domain, from a few hertz all the way up to sometimes like megahertz for guided waves and their applications, and of course multi-physics problems involving fluid structure interaction as well. So kind of the outline I put together is you're already familiar with vibration-based energy harvesting. Of course, I'm sure you're very familiar with it looking at the program. Not that I can too much follow with the time zone difference, and also with my teaching duties and everything, I couldn't follow the rest of it, but I know that there's a lot of interesting talks on energy harvesting. So basic vibration-based energy harvesting is well established, of course. Like you can create a resonating structure, linear or non-linear, at a given frequency or for a frequency range. You can locate this cantilever-like structure or its non-linear counterpart. You try to maximize the power output. So, what I would like you to think about is the more of like a wave propagation approach to this problem. If I have, let's say, an incident wave, I'm not going to discuss too much this simple structure, but this is a waveguide, like a one-dimensional, like a beam-like waveguide, where you can put a piezo patch. Now, this is not a cantilever, but a piezo patch bonded on the waveguide. So the question becomes, like in the basic energy harvesting problem now, if I have an incident wave propagating, how can I maximize the real power delivered to the electrical load, which could be some complex load, right? So you try to minimize what is being, so of course there is an impedance mismatch at the boundaries of this domain. So there will be some reflection, there will be some transmission inside, and then there will be some reflection again at this boundary, and then some transmission. So you want to minimize what escapes from the domain as a transmitted wave to the rest of the waveguide, is reflected back. You want to maximize what goes to the electrical load. So that's like a most high level or like a basic way of looking at the problem of, like, when we say this wave propagation approach to energy harvesting, this can give you more insight. So can I, for instance, put an obstacle to recover some of the transmitted wave? Okay, so there's some incident wave from the left-hand side. I harvest some of it escapes, right? That will happen always thermodynamically. I mean, there's no such thing as, like, in an ordinary manner to take the 100% of the wave energy to the electrical load. There will be some reflection, some transmission. So, but you can kind of recover some of it by putting an obstacle like a reflector and so on. So there's many, or like this is like an anechoic boundary condition. So if it's a semi-infinite waveguide, what kind of electrical load I can put? If I put, like, you know, conjugate matching load, like, can I enable this non-reflective boundary condition? So this is like early attempts of wave propagation approach to energy harvesting problem. We started as early as when I started at Georgia Tech in 2011. So our first paper is on this elastic wave mirrors, like this parabolic mirror, elliptical mirror, or like metamaterial-based funneling of the wave by creating a band gap domain like this, you know, Bragg scattering-based band gap, and then channeling the wave to here, or creating a defect and localizing the energy. Those appeared as early as 2012 and 13. What I want to rather talk about is our most recent stuff related to the focusing of waves using gradient index photonic crystal lenses. Okay, so some definitions that you may already be familiar with, even from high school physics and so on. The fact that a wave, it could be an electromagnetic wave or an acoustic wave. As it propagates from one domain to another, it bends. Okay, in this case, it's an electromagnetic wave. So the, you know, when light propagates from, let's say, air to glass, it will bend because the speed of light in air is different than in glass. So you can define as something called the refractive index. That is the speed of light in vacuum. That's the maximum speed that you can have, divided by the speed of light in whatever the medium that you're talking about. For instance, if this is glass, that refractive index becomes, let's see where it is, it should be around 1.33. I'm sorry, if it's water, sorry. We work with water most of the time. This 1.33 came to my mind right away. So if it's water, for instance, like that's the factor of difference in the speed of light in vacuum versus in water. Glass should also be around, here we go, 1.5, okay? So that, and then you can use Snell's law kind of arguments to see what is going to be the, you know, for a given incident angle, what would be the refraction angle and so on. But the fundamental argument is that, like, when you have these two different domains, the speed of the phase velocity of the wave changes from one domain to another, and you can use that to enable these gradient index structures. And that was done in optics primarily. So there's this concept of, like, you can find books. It's not a too old concept, but also not too new. It's established enough that you can find textbooks on gradient index optics, how to make a lens to focus electromagnetic waves, like to focus lights, instead of machining glass or like doing like a geometric structure to focus electromagnetic waves. Would it be possible to even use something like an ordinary slab? Can I manage to focus waves? Well, you can, as long as you can tune the properties, like the properties of glass in this case, in a way that the phase velocity is slower here, faster. So if you can do this gradient variation of the speed of light in space, like, you know, you can manage to focus the wave here. So people try to do this like numerically, mostly for guided waves. There were, like, when we got to this kind of research, there was some simulation work, like mostly numerical simulations on like perforated plates or with stubs, show that you can focus guided waves. And by the way, you don't have to do this photonic crystal kind of arrangement. Even if you do some machining of a domain like this, let's say you gradually vary the thickness in a way that the thicker portions will have faster speed of sound, thinner portions will have slower. Yes, you can focus the wave. The advantage of using photonic crystal arguments like this, being able to define things in terms of a unit cell, like a lattice parameter, is that you can do the design in an easier manner. Okay, so just keep in mind from the starting point that you don't have to use a photonic crystal setting. So this metamaterial photonic crystal arguments, that makes life easier to design this structure. So you could gradually machine the domain as well. But if you work with a repeating unit cell, it makes it possible to assume these periodic boundary conditions, like a Foucault boundary conditions at the boundaries of a lattice element with a lattice parameter of A. If I change the diameter, let's say the design parameter in this setting is the diameter of this blind hole. Okay, I could use through hole, I could use stub extensions and so on, but I want to be able to, in the experiment, I want to be able to scan the wave field. So I want to keep some material here. I don't want to do this through hole, but I don't want to add too much mass. I don't want to do stub extension. So that's why we have a blind hole here. And the thing that I'm varying from one unit cell to another is the diameter of the blind holes. So how do we design a lens? So we have to gradually vary the speed of sound, especially mainly the phase velocity, because in a dispersive problem like a flexural wave in a plate, which is mainly we are looking at the A0 Lamb wave mode, the lowest anti-symmetric Lamb wave mode. So we can talk about the group velocity and the phase velocity. The main thing that you're dealing with in the refractive index is the phase velocity. Suppose that I want to design a lens that will work at 50 kilohertz. This is the lowest anti-symmetric mode branch. It's the same, pretty much like a similar branch if you know Euler-Bernoulli beam theory and so on. That's like a low frequency flexural wave, right? Eventually you're converging to that if you go down to very low frequencies. So again, one more time, lowest anti-symmetric Lamb wave mode. That's a flexural, like an out of plane kind of motion that you can observe. So if you change the filling factor, which in this case filling factor is actually like a subtraction factor. If I vary this diameter, I have the largest diameter that's going to be the slowest, because let me see if my pen here, because I just disconnected from class, they would always let me write on the board. So actually if I switch to a pen or even like a pointer kind of setting, here we go. Suppose that I want to design a lens that's going to operate at this frequency. So if this is my dispersion branch, the slope from here to there, this guy here, is frequency divided by wave number. It's the phase velocity, okay? So that means like if I go to this next branch, so these different diameters, as I increase the diameter of my blind hole, the wave will go slower and slower, meaning the wave propagating over here will be slower than that propagating here and there. So that's how eventually it focuses. And you want to enable this hyperbolic second profile of the refractive index distribution. And in the interest of time, these are some simulations with the ray tracing. Let me walk you through directly to the experimental setting. So we get these aluminum plate machine using a CNC machine with different diameters. And we're trying to observe with a scanning laser vibrometer. There's a reflector tape at the back of the plate, and we have an array of piezos, like a plane wave source. And when I run this, you will see the experimental wave field. So basically, when these piezos are triggered in phase, this is going to generate a plane wave. You see the first focusing there. It's going to defocus, and this is the lens domain. It is long enough that it's going to refocus and defocus, but the main focusing point of interest is here, okay? So the waves went slower here, faster, faster, and hopefully maybe I could just a little bit walk you back to that instant, okay? It slowed down, and that's the focusing. First, if you want to use this structure for energy harvesting, like normally, if you have a plane wave coming from the left, and if you don't use a lens, if you put a small piezo patch, right? So suppose that I put a piezo patch somewhere here, I will harvest some of it, but the rest of it will escape. But when you put a lens, you can localize the energy and maximize the power output. So this is typically where, where you would want to put your energy harvester. And in simplest terms, you could design something with a half wavelength. So if I put a piezo patch, like a disc, I want that guy to vibrate like, in this kind of out of plane manner, like a first flexural mode of a disc. So that's why you tune that guy to be like half wavelength so that there's no cancellation. Of course, you can do something smarter, okay? Because the focusing region has a certain neck. You can put multiple segmented piezos and do a proper switching to maximize the power output. But even if you don't do that, like when you compare what you would harvest in the absence of a lens versus, with the lens, the enhancement is by an order of magnitude, okay? And the baseline case, in case it wasn't visible, so this is the baseline harvester, this is the lens harvester, okay? So this portion is the lens portion, this is that back of the plate. So the waves coming from this side is focus, whereas here it doesn't focus, it just keeps going like that. That's why significant part of the energy escapes before, without being harvested, and focusing enhances that performance. Okay, so that design I showed you was like for a known direction. If you know the direction from which the wave is propagating, of course, you can localize the energy and harvest it from there. In that regard, like that first generation thing I showed you is like a unidirectional. I have to know where the wave is coming from. I can orient the lens in that manner. But like there's something called in the optics counterpart a Lüneburg lens, which is relatively omnidirectional. I mean, ideally perfectly omnidirectional. But now, if you try to discretize the domain with, let's say, a hexagonal unit cell, again applying your periodic boundary conditions and so on. Now, I have two extreme directions, like this is one direction, this is the other direction. So I don't know how many of you are familiar with this kind of like band structure or unit cell lattice analysis. Like this is what you're looking at here, this hexagonal setting is the unit cell, whereas what you see here as a triangle is the lowest irreducible, brilliant zone of your unit cell, where you could analyze the wave propagation, especially if I know that, let's say I'm gonna focus on like if my lens is oriented, like designed in this manner, if I'm gonna look at waves propagating in this direction, let's say, okay, like in X direction, so I can look at this particular orientation. But what if my waves will be propagating in some other direction? Let's say if it's 30 degrees by that, you can look at waves, propagating in that other. You can do therefore band structure analysis in the whole, in this whole, X, Y kind of plane. But the ultimate goal that you are trying to accomplish in the Lüneburg lens is you want to achieve this axis symmetric refractive index profile. But again, you have a challenge. It's a discretized domain. It's not a continuous machining. So it's going to be like a quasi axis symmetric. Let me show you some console results first of all. So if you make some effort, so basically you have to decide on the diameters of the unit cells and ultimately come up with a design like this. So what this accomplishes, if I go back a little bit, so you choose all these diameters, your maximum refractive index is somewhere around the center, your minimum refractive index is at the circumference of the lens, okay? If you take the root mean square value, you see the focusing at the opposite end of wave propagation. So if my wave is coming from this direction, what it does is that, like, again, it goes slowest at the center, faster, it focuses at that point. If my wave comes from this other direction, it focuses at this position. So that's what this implies. So because the main curiosity, because the domain is not perfectly axis symmetric, you try to double check to make sure that it works in different directions. Let me move on to the experiments right away and run these simulations. I'll let you take a look at these simulations. These are all experimental. We're using scanning laser vibrometry to measure the out-of-plane motion. You see the focusing of the elastic wave energy at the opposite end, which means, I mean, in an application, if you want to do an omnidirectional lens, you can deploy multiple piezo harvesters, right, at the circumference, because the bottom line is, as compared to not putting a lens, you have again, and that's your baseline. This is the back of the plate. Here's where the lens domain is. Now, if I have a plane wave generator, the harvester A and harvester C are at the same distance. So that's why this is a fair comparison. If I have like A is generating, I'm sorry about this, it's my touchpad screen. A is responding to this plane wave generator, B is responding to that one. So you have the substantial enhancement, an order of magnitude enhancement in the power output. Okay, and I'm gonna try to wrap up maybe a little faster in the interest of time. We did 3D printed counterparts of these things as well. So there could be some time to discuss other concepts. So if you don't want to machine the domain, but add some stubs, let's say a separately, 3D printed configuration like a PLA, which could look like this. This is a perfectly cheap, low quality 3D printing with lots of imperfections, and you go and bond it to your plane, and this is the plane wave generator. It gets more lossy, so your enhancement as compared to baseline setting is not an order of magnitude, but you have a factor of 3 or 4 in the power output. So what we have done most recently, this is 2020 work. The underwater one just appeared recently. It's this one. So you could do the same stuff for underwater wave focusing, which could be, it doesn't have to be energy harvesting. It could also be a power transfer problem. So some of our funding is for wireless acoustic power transfer. So if I want to charge, let's say, a sensor node, like a wireless sensor node in the ocean, can I send acoustic waves like to focus that energy? This is like a small scale counterpart of that, because the application is not necessarily for ocean. You could have also like a medical implant that you want to charge in the body, and tissue is well represented by water. So you could try to focus waves by using 3D printed lenses or like more compliant stuff in that sense. So therefore I'm transitioning from elastic waves to acoustic waves. Sorry about it. Again, I'm just coming from teaching my class, which is 90 minutes of talking. So sorry about my voice. So for instance, like let's try to design unit cells in 3D in a way that we try to accomplish just like a Lüneburg refractive index. This is like a cube-shaped domain. It's not going to be omnidirectional, and there's other reasons that it won't be omnidirectional, but at least it should work in a unidimensional manner if I try to focus waves. One particular reason that this won't be omnidirectional, by the way, is due to anisotropy in 3D printing. Okay. Those of you who are doing 3D printing related stuff, your material properties in the printed printing direction are not necessarily the same as your material properties like elastic modulus, Poisson's ratio or elastic modulus in other directions. So there is some level of anisotropy, but like our intention here is just to design something for a specific direction. Although it works in fundamental principal directions in a good way. I will show you later on a spherical counterpart too. So we use one hydrophone as a source, like a wave in a reverse operation. Hydrophone is like an underwater microphone, and if you operate in reverse, you can send like spherical waves, and those spherical waves at sufficient distance will turn into plane waves. Okay, and you can put another hydrophone at the back to confirm focusing. This is how we identify parameters. Okay, this is where we observe that, like if I we check the longitudinal axial vibration frequencies, go backwards to confirm this 3D printing materials, elastic modulus, Poisson's ratio, and so on. Like if you look at in other direction, you may find that those properties may change. This is the animation, right? Okay. So without the lens, there's no focusing. This is with the lens, experimental and numerical, confirming the focusing. This is the amount of gain that you would have in the underwater problem. There's of course some loss because you're working with PLA. So the main domain of the 3D printed structure in the underwater setting is the domain of propagation. You have, I didn't spend too much time, but like if I go back for a second in the band structure, shear waves become very critical. Okay, so as the wave propagates, it's sustained through this domain, PLA domain, and there is some loss. Of course, it's a relatively soft material. But like that becomes critical. On the other hand, like when you look at the design for in-air purposes, just like this guy here, we use unit cells as simple as these guys here, okay? And we try to vary the properties against some filling fraction in a way that I can play with the refractive index. I'm going to try to show you some final results. This is the air counterpart to make a lens at audio frequencies. Audio frequencies is like typical, human speaking and hearing frequencies from, let's say, 0 to 20 kilohertz. Although this design is closer to the, 15 to 20 kilohertz range. But of course, you can design it whatever the frequency you want. Okay, there's a speaker, there's a plane wave generator, and you have your lens and a microphone. It's confirming the amounts of enhancement with the presence of the lens. And in this case, some harvesting results as well. This one is actually under review. This hasn't appeared anywhere. You maybe you may or may not be familiar with the kind of the work that is done in sound energy harvesting. Most of the time you get nanowatts. You don't quite get microwatts because it's not a very high intensity source. And I'm not talking about, again, I'm not talking about flow energy harvesting, okay? There's a separate body of work using Helmholtz resonators in flow energy harvesting, which we did as well. Like we did hydraulic pressure ripple energy harvesting by putting a Helmholtz resonator. That gets close. If you have a fast fluid, that's more of like a flow energy harvesting problem. Here we're talking about some certain dB level excitation. Can I get microwatt level? So if you put this buzzer kind of harvester without any kind of lens, this is the power level you get with the dashed lines. But with the lens, thanks to the focusing I showed in the previous slide, you can substantially enhance the power output and reach microwatt levels. I realize I don't have too much time, but like a parallel body of work, and I will wrap up, I will stop after this. We try to also do this locally resonant metamaterials where the unit cells are resonating. Okay, it's a fundamental difference between a phonic crystal setting and a metamaterial metastructure setting is that you can put these resonating unit cells to do, let's say, band gap formation. A band gap looks like this in simplest terms. I have a cantilever under base excitation. If I have this resonating unit cells, here is what the band gap looks like. Take a look at the beam response. So you have no wave propagation over a range of frequencies, and we have a good understanding of how to design these, locally resonant metamaterials and metastructures. The main thing, and some experiments for my lab, just to confirm that, this starting frequency in a mechanical setting, it starts, at the tune frequency of these resonators, and the size of the band gap of no wave propagation depends on the mass ratio, how much added mass you have due to the resonators and so on. So the curiosity becomes, can I go ahead? This is comparison of those. Like basically your dispersion plot, like your band structure, is modified. A band gap opens, which is this gray shaded area, the range of frequencies where there's no wave propagation. You can generalize these formulations to other canonical structural forms. So talk is mainly about energy harvesting. So can we also use these concepts? I know other people are also, starting to do these things like in metamaterial concepts, like, can we generate a band gap, also do energy harvesting? What you would typically find is that, okay, you can have your band gap, and most of the energy that you would harvest would be at the beginning of the band gap. Okay, maybe you remember the animation I showed you as we sweep the frequency in that cantilever. At the beginning of the band gap, there is significant energy, and most of that energy is, if I have a cantilever like this under base excitation, most of the energy is harvested by the first few resonators close to the excitation point. This is my band gap, and I'm trying to harvest energy. Most of the energy is in this frequency neighborhood at the starting of the band gap, and most of it, like a significant part, if you look at the total power produced by these guys, most of it is harvested by the first few of them. Okay, so that's an interesting problem. Actually, this is an ongoing master's student's work. It's not published anywhere. To combine these metamaterial and energy harvesting concepts experimentally. There's of course lots of wiring and so on. You want to rectify the outputs and so on. I'm going to skip this one. This is low frequency implementation. Now you can combine these like resonating unit cell arguments with lens concepts to scale down the frequency of this wave focusing. Or if you make a mirror, basically with resonating elements, if I have a plane wave, I don't have to come up with a huge structure to focus low frequency waves. I can use resonating unit cells to that end, is the other thing. Overall, I hope I could give you an idea, unless you're already familiar about the fact that you could make use of these interesting concepts of localizing propagating waves in structures. That's a kind of a relatively different approach to persistent waves and steady state behavior to harvest energy from vibrations in a linear or in a nonlinear manner, where we're talking about you could have a transient, like a wave packet. Most of those experiments and simulations I show you are like a wave packet comes, and you try to localize in space and so on. There's other concepts we work on these days, and some of these can also be combined with nonlinearities too. There's a great deal of advantage with this approach. With that, I know it's already too late in the day. It's only noon for me. I stop here, and I would be happy to take any questions.
Okay, thank you very much for this fascinating lecture. Yeah, I just want to ask for questions. Maybe somebody from the audience. But I can start as a first one. So for example, you studied these ball structures for wave localization. However, I think that this ball structure, as you also discussed, it is the localization is dependent on the coming wave, so the direction. So if direction is different, then you localize in different point. But I think that you can also design such a structure that you could be more flexible with the direction, and the localization point could be still in very close place, because in the ball structure, depending on the direction, the localization point, or maybe this is the point where this wave is focusing. So is moving around if you have different direction of a wave. Yeah, is it true that you can design in such way that you have roughly one or maybe some area, more localized area, and independent from the direction of a coming wave?
Yeah. So in the context of these lens designs, the slide is one way to do that. Like if you try to make this omnidirectional refractive index profile, this can focus in different directions, because these are the two extreme directions in the Brillouin zone, that like this 0 degree and 30 degree. So this guy will focus in all directions. But now another way to approach this problem is like creating a defect. And we looked at that in the past that I did not talk about today. So something like this, sorry, I went too fast. Here we go. Like, let's say you have a lattice, like a 2D crystal, which doesn't have to be stubs, and you remove, and other people start to, this must be the first paper when we did back in 2013 for elastic waves. Now there's other people looking at, this is the defect problem. And this is fundamentally different from, let's say, a lens problem, okay? Because you are not trying to do any refractive index or anything. What this does is that you have, Bragg scattering, like band gap for the, there is no wave propagation in the rest of it, but then suddenly you break like one of the lattices, and what you will see there is the, let's say if this is my defect position, energy will be localized there, is one way. Okay. So this would work in different directions. One of the fundamental issues there is like, now you put this photonic crystal around it, so you don't want the wave energy to localize here, but to go there. But the problem is when the incident wave comes, significant part of it gets scattered by the rest of it, is the problem. So this is like it's more of like, creating a domain where a significant portion is in a band gap, but then you have this, so basically like think of a band gap in that frequency domain. So that's that localized mode in a band gap. So this is one way to look at it, Grzegorz, like if you don't want to do this crazy lens designs and refractive indices. Otherwise, the classical approach in the lens design, yeah, this one is also Lüneburg, by the way. As I was mentioning, you don't have to do this, discrete elements. You can kind of machine the domain. It's a computational paper by some other colleagues. You can put a harvester at the domain, so that will like focus. I wonder if this helps. So lens is not the only way. You can also use a defect to localize energy.
Okay, thank you. So any other question? I had also another question about this.
Sure.
The last pages, because you discussed this. I remember this works with a meta structure. Yeah, so the band is coming here, but there's still a problem. What would be the change to the gap if you have a non-linear system, because this is roughly linear system, yeah. So you assumed that this is
these are linear.
Yeah.
So I think it looks like now that I'm the last presenter anyway, let me try to pull other slides. Yeah, I didn't put anything nonlinear here. Let me show you, give me 1 second. The nonlinear counterpart, if I can find, I may have animation somewhere. So let's say, suppose that each one of the unit cells, let's say, is bistable, and you can talk about still a locally resonant band gap. So I don't know where, I must have downloaded somewhere. Give me 1 second. Actually, the student's dissertation is here that she will be presenting. So maybe this is a good place to look at. So let's say I have these. If you see my screen, this is like, yeah. I have, each one of these resonators, let's say, are bistable. So still, for small oscillations, let's say, if my base excitation level, is it gonna let me draw? Yeah. If my base excitation is small enough, each one of these guys could be within a potential valve, right? I could still have, for low enough amplitudes, I can have a linear band gap, okay? And for larger amplitudes, let me try to go directly to experiments. Yeah, this is good. Is this experiment? This is numerical. Bear with me. This just appeared in Nonlinear Dynamics Journal. And then we had a discrete version of it in the in APL, I guess, last year. Let's go all the way down. Okay, this is experimental data. So, okay, for low enough base excitation level, I do have, if you look at this red or orange, like this kind of level, this is like a band gap. So that goes with like linear resonances. Now, if I keep increasing the excitation level, of course, chaotic vibrations can be triggered, and that gets even more powerful. So when you get to nonlinear domain, that thing is no longer a band gap. I mean, it's advantageous because obviously if you trigger chaos, you get rid of not only like this main mode, but also these other modes. Look like this guy is typically like gradually softening, and this your intraval oscillations are first of all a little bit softening, and then chaos is triggered. Then you can get rid of even these additional modes, but that's no longer a band gap. Is the point? Like band gap by definition is like it's a linear argument, and it's certainly a powerful thing to combine these different things. If that makes sense. So, I mean, let's see if I have. If you want to see some interesting videos, I should even have those, but I don't know how much time there is for you. Okay. But yeah, that's the idea. You can make them nonlinear, and it's very interesting actually when they are nonlinear. And I have some nice videos of those. I just don't know where they are. So.
And this data which you show, it is also simulation or
it's an experiment.
Experiment.
It's an experiment. And actually,
very nice.
I wanted to find give me 1 second actually, if that, the paper appeared and there should be some videos of it in slow motion. Let's give it a try. Let's give it a try to, yeah, I may not be on VPN.
Okay.
I mean, I don't know if this just appeared a few days ago. Yeah, there should be some videos of it. And again, if you're interested, I'm happy to share or find too.
Yeah, and I think it's quite interesting. So maybe we can also find some other time to discuss, to have some longer discussion. Yeah, because
absolutely. But yeah, these are like you could find some like that's a low amplitude. There is very interesting dynamics at certain frequencies, which this is typical chaotic response of the resonators.
Yeah, this is interesting because this is chaos with large number of degrees of freedom.
Yes. Look at this one. That's a synchronization kind of thing almost.
Yeah. This is so reduction of degrees of freedom.
Yeah. So
by synchronization. Yeah.
That's I think that's very interesting dynamics. I mean, we did not go into too much. You know, the student is graduating. I mean, we wrapped up and published that, but there is very complex and interesting dynamics going on there.
Yeah, okay. I would be very much interested in such stuff. So maybe we can discuss another day. Yeah. So sure, we can arrange some focused discussion. Yeah. Okay. So this was very nice presentation. So thank you very much.
Thank you. My pleasure.
And we finally found some convenient,
finally we
good time for you.
I wish we could, you know. My wife and I would love to be in Poland one day. We've never been to. Hopefully, you know, we'll do that too, and hopefully things will go back to normal. We'll get together as well.
Sure. So maybe next year or something. Yeah, but anyway, I just want to ask because this session was also prepared by Bartek, who is my PhD student. So I just want to ask him, maybe he can conclude the session, because from my side, I would like to thank all the speakers and also participants for coming here and for sharing some new results and their ideas. And I pass also to maybe 1 point more, that there is some possibility to publish, to make some, to write some proceedings in our local journal, but the journal is local, published in our university, but it is recognized by Web of Science. So there is some possibility to submit papers, and this would be also supported by Dialogue project. Yeah. So thank you once again, and I pass voice to my my student, who was a very important person in preparation of this session.
Okay, so concluding the session, thank you, Professor ehDIALOG, for your participants today. I'm really amazed of your deep research. I would like to conclude today conference, because I wanted to combine in this hard time the connection and combine the experience of young researchers and the experts in the area of energy harvesting. So I would like to thank you, all of the today participants, to present the research. Every one of us has a different approach to the experiments, to the research, but actually we are around the same scientific area. In a few days, I will prepare the certificates of attendance for you, for all of the participants of the conference. And as Professor Litak said before, that there is an opportunity to publish the paper local journal. But I will send this information to all of the participants in a few days. Thank you again, and I think maybe yes, because also we have some also information about our project ehDIALOG. So we are trying to focus all of the experts in energy harvesting around the world. There is an opportunity to take part in our weekly lectures. Every week, another expert is presenting their research, the outcome of the experiments primarily of the research. So you can follow this website, and we are uploading the new activities. Okay, and on 28th of October, there is a lecture of Professor Carlo Trigona from Catania. So all of you feel welcome to take part in this. Okay, so thank you again for today, and I hope to see next year during the same session. Thank you very much.
Okay, thank you. Take care. Bye.
Politechnika Lubelska co roku zajmuje bardzo wysokie miejsca w rankingach innowacyjnych uczelni. Także w tym roku w rankingu perspektyw zajęliśmy bardzo wysoką pozycję zarówno w kategorii uczelni innowacyjnych, ale także pierwsze miejsce w kategorii ilości praw ochronnych oraz patentów zgłoszonych przez ośrodki akademickie w Polsce. Jednak nasza działalność to nie tylko zgłaszanie rozwiązań do ochrony w Urzędzie Patentowym, ale także, a może przede wszystkim wdrażanie ich w przedsiębiorstwach. Taką działalność prowadzi Centrum Innowacji i Transferu Technologii, które od lat już prowadzi program Inkubator Innowacyjności. W ramach tego programu opracowujemy rozwiązania, które następnie są wdrażane w firmach. W ostatnim czasie zakończyliśmy program Inkubator Innowacyjności 2.0. W ramach tego programu przeprowadziliśmy 8 prac przedwdrożeniowych, z których najciekawsze zobaczycie Państwo w tym materiale. Rozwiązania te bardzo często są przygotowywane na potrzeby konkretnych przedsiębiorstw, a więc można się domyślić, że po zakończeniu prac przedwdrożeniowych trafiają one właśnie do tych firm, które następnie ze wsparciem naszych naukowców uzyskują wymierne efekty finansowe z tego, że stają się bardziej innowacyjne, mają lepsze produkty. Dzięki temu też możemy mieć lepszą współpracę zarówno ze strony naukowców, którzy w firmach tych znajdują zastosowanie swoich rozwiązań, jak również od strony przedsiębiorstw, które cieszą się z tego, że ich produkty mogą konkurować, mogą być bardziej konkurencyjne na rynku, a co za tym idzie, mogą zapewniać sobie dobrą pozycję konkurencyjną. Podczas konferencji Innowacje w praktyce prezentujemy co roku w zasadzie już najciekawsze rozwiązania, z którymi mogą się Zapoznać uczestnicy tej konferencji. Pan profesor Tomasz Klepka zaprasza nas jako Centrum Innowacji i Transferu Technologii do tego, aby najciekawsze rozwiązania, którymi chcemy zainteresować przedsiębiorców, mogły być właśnie tam zaprezentowane. Podczas panelowych spotkań dyskusyjnych Polskiej Akademii Nauk oraz konferencji Innowacje w praktyce prezentujemy co roku najciekawsze rozwiązania opracowane w Politechnice Lubelskiej. Cieszymy się, że jest to okazja do tego, aby przedsiębiorcy mogli zapoznać się z rozwiązaniami, które następnie będziemy chcieli wdrażać w ich przedsiębiorstwach.
Jestem doktor inżynier Przemysław Filipek, pracuję w Katedrze Podstaw Konstrukcji Maszyn i Mekatroniki na Wydziale Mechanicznym Politechniki Lubelskiej. Przedstawiony tutaj sprzęt jest rowerem elektrycznym z zastosowaniem nowatorskiej konstrukcji silnika elektrycznego patentowanego na Politechnice Lubelskiej. Jest to silnik bezszczotkowy, zbudowany z magnesów trwałych oraz uzwojenia. No i do tego wszystkiego sterownik. Silnik nazywa się LMP. W tylnym kole rowerowym zastosowano w rotorze 36 magnesów po obu stronach, czyli w sumie łącznie 72 magnesy stałe. Stator jest elementem wykonanym ze sklejki, odpowiednio wyfrezowana i w tych rowkach znajduje się uzwojenie. I to uzwojenie współpracuje z rotorem, z magnesami trwałymi. Z magnesami trwałymi. Z magnesami trwałymi. Z magnesami trwałymi. Z magnesami trwałymi.
Technologia skanowania 3D jest technologią, która w ostatnich latach dosyć prężnie i dynamicznie się rozwija. Obecnie jest coraz częściej wykorzystywana w różnych branżach i dyscyplinach, jak również bardzo często stosowana jest w życiu codziennym. Za jej pomocą w szybki sposób możemy przenieść obiekt rzeczywisty do świata cyfrowego. Następnie ten obiekt w świecie cyfrowym można poddać dalszym modyfikacjom poprzez wykorzystanie odpowiednich programów komputerowych. Technologia skanowania 3D znalazła zastosowanie między innymi w medycynie, kryminalistyce, motoryzacji, lotnictwie, grafice komputerowej, produkcji firmowej, archeologii i muzealnictwie. Skanowanie 3D obiektów muzealnych pozwala na ich publikację w internecie, dostęp do nich z dowolnego miejsca na świecie. Technika ta umożliwia dokładne obejrzenie eksponatu z każdej strony, jego ocenę, jak również ocenę najdrobniejszych szczegółów i detali. Technologia skanowania 3D jest najczęściej wykorzystywana do realizacji takich zagadnień jak pomiar geometrii, objętości i pola powierzchni obiektów rzeczywistych, wzornictwo, inżynieria odwrotna, kontrola jakości, testy i symulacje, bezdotykowa inspekcja, kontrola zużycia, digitalizacja obiektów, archiwizacja zbiorów czy też tworzenie wirtualnych muzeów. Proces skanowania 3D realizowany jest za pomocą skanerów 3D. Skanery 3D są to urządzenia, które umożliwiają analizę obiektów i przedmiotów rzeczywistych o małych rozmiarach, jak również dużych obiektów i otwartych przestrzeni, takich jak na przykład ulice, parki, obiekty architektoniczne lub miejsca wykopalisk archeologicznych. Mogą to być kilku milionów. kilku, a nawet kilkunastu metrów. Skanery 3D pozwalają na odwzorowanie rzeczywistych obiektów przy zachowaniu ich kształtu, wymiarów, jak również pozwalają na zachowanie ich kolorystyki. W skanerach 3D stosuje się różne rozwiązania technologiczne. Jednak najczęściej wykorzystywanymi skanerami są skanery bezdotykowe. Są to urządzenia, które oparte są na technologii optoelektronicznej, czyli na technologii, która wykorzystuje właściwości światła w celu zgromadzenia, w celu transferu i prezentacji informacji. W naszej katedrze, czyli w Katedrze Informatyki, posiadamy 4 tego typu skanery. 2 z nich wykorzystuje światło strukturalne, natomiast 2 są to skanery laserowe. Jednym ze skanerów jest laserowy skaner o nazwie Farofocus 3D. Skaner Farofocus 3D jest to skaner, który umożliwia skanowanie zarówno wewnątrz, jak i na zewnątrz budynków. Jest to mobilne urządzenie, które pozwala na szybkie, łatwe i precyzyjne pomiary budynków, pomieszczeń, dużych obiektów, wykopalisk archeologicznych, złożonych konstrukcji, a nawet miejsc wypadków i przestępstw. Skaner ten może być wykorzystywany między innymi do tworzenia dokumentacji stanu i geometrii, sporządzenia archiwizacji przedmiotów i tworzenia ich wiernych kopii, na przykład poprzez tworzenie wydruków 3D, do inwentaryzacji, wykonywania modeli 3D, tworzenia wirtualnych spacerów i zdjęć panoramicznych 360, jak również do opracowywania wirtualnego muzeum w technologii 3D. Skaner ten pozwala na tworzenie pełnej i wiernej w szczegółach dokumentacji obiektów historycznych lub wykopalisk archeologicznych. Jest to bardzo istotne w celu przeprowadzenia np. renowacji, analizy naukowej, zabezpieczenia budynków lub wirtualnej prezentacji miejsc historycznych, do których nie mają dostępu osoby zwiedzające. Dzięki wbudowanemu kolorowemu aparatowi fotograficznemu można bezpośrednio generować fotorealistyczne wizualizacje 3D. Wbudowany aparat HDR zapewnia pełną dokumentację w najwyższej jakości. Jest to szczególnie przydatna funkcja w przypadku, gdy musimy nadać skanom odpowiedni kolor przy trudnych warunkach oświetleniowych.
designed to work perfectly. IKA German Technology.
Witaj, miło Cię widzieć. Chociaż znamy się nie od dziś, myślę, że jeszcze wiele o mnie nie wiesz. Znajduję się w centrum Europy, więc szybko do mnie dotrzesz. To dzięki ostatnim zmianom w infrastrukturze drogowej, kolejowej i rozwojowi lotniczej siatki połączeń. Za granicą jest o mnie coraz głośniej. Ostatnio mówią o mnie, że jestem smart. Wdrożone rozwiązania potwierdza certyfikat ISO i liczne międzynarodowe rankingi. Jestem pewien, że znajdziemy wspólną przestrzeń. Taką, w której będziesz mógł się rozwijać. Będąc kompaktowym miastem, gwarantuje Ci atuty metropolii, jednocześnie zapewniając komfortowe warunki odpoczynku z dala od zgiełku zatłoczonego miasta. Wiem też, że wspólnie możemy się wiele nauczyć. Dzięki mnie dowiesz się, gdzie inwestować w wiedzę. Pokażę Ci, jak kwitnie współpraca biznesu, nauki i samorządu. U mnie znajdziesz miejsca, w których innowacje nabierają realnych kształtów. Przedstawię Cię osobom, które mają na to swoje patenty. Zobaczysz, jak nowe technologie sprawdzają się w praktyce. Przekonasz się, że jestem dobrą inwestycją, nie tylko jutro, ale tu i teraz. Nie czekaj. Przyszłość zaczyna się tu, w Lublinie.
Wybierz kierunek lubelskie. 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 Wybierz kierunek lubelskie.